Day 6. Days are passing and we are steadily upskilling. Great to see you again, and we are really happy with such a tremendous response from our dedicated learners. Today is day 6 of Software Development Week by Simplilearn. So far, we are done with data structures and algorithms, C++, core Java, and advanced Java. Object-oriented programming languages have really streamlined and secured the process of software development. Yet, C++ and Java, also known as giants of programming, with their well-structured coding paradigms bring complexities to light that many beginners feel hard to synthesize. What if you were given a programming language that could simply outperform Java and drastically decrease the code length from thousands of lines to 100? What if I say there's actually one existing that stands as the flag bearer of simplicity, so much so that it sets up its runtime environment and environment variables, eliminating all the hassle for you? Yes, that's how Python is. Today's session is all about mastering the Python programming language. So without any further ado, let's allow our experts to take over the session.
So we will start by learning the history of Python and understand the top 10 reasons to learn Python. You will look at the job role of a Python developer, the skills they need to possess, and how the resume of a Python developer should be. Then, we will see how to install Python and the Anaconda distribution of Python. Then we will shift our focus towards learning the basics of Python such as data types, variables, operators, lists, tuples, and dictionaries. Next, we will understand about loops and conditional statements. After that, we'll get an idea about object-oriented programming concepts and functions in Python. We will also cover some important advanced Python programming concepts such as iterators, modules, generators, as well as packages. Finally, we will see the important Python interview questions that are often asked. So let's get started.
Let's begin and learn about the development of Python and gain insights about the current IT trends. Python is very famous for its simple programming syntax, code readability, and English-like commands that make coding a lot easier and efficient. Due to this, it is the most popular and preferred language. Python is an interpreted, high-level general-purpose programming language developed by Guido van Rossum at National Research Institute for Mathematics and Computer Science, Netherlands. In contrast to popular belief that Python was named after the snake, Python was actually named after the show Monty Python's Flying Circus. Guido van Rossum formulated Python in the late 1980s as a successor to the ABC language. In 1994, Python version 1.0 was released with features like exception handling, lambda, map, filter, and reduce. Python 2.0, released in 2000, introduced features like list comprehensions and a garbage collection system capable of collecting reference cycles. Python 3.0 was released on the 3rd of December 2008. Undoubtedly, Python 2.x and 3.x have proven to be the most used versions. As of today, Python 3.7.4 is the latest stable version released in the summer of 2019. Python is popularly used for development, scripting, and software testing. Top IT companies like Google, Facebook, Instagram, Spotify, and Netflix, among others, use Python. Some major applications of Python can be seen in the fields of machine learning, artificial intelligence, data science, and IoT. Python also offers many libraries like NumPy, SciPy, Keras, TensorFlow, Django, and Flask. Pep 8 is the official style guide that defines the styling conventions for Python code. A few popular open source Python projects include pipenv, Chatistics, solving the traveling salesman problem using self-organizing maps, and Python to BPF converter. Some of the trending Python repositories on GitHub today include NLP, ML from scratch, PyTorch transformers, 100 days of ML code, among others. Popular websites on the internet like Reddit and Quora are built using Python. Civilization 4, Battlefield 2, Sims 4, and World of Tanks are some popular games developed using Python. According to Indeed, the average salary of a Python developer in India is about 5 lakhs per annum, and that in the US is around $124,000. Users and admirers of Python, especially those considered knowledgeable, are referred to as Pythonists, Pythonistas, and Pythoneers. Since its inception, Python has come a long way to become the most popular coding language and continues to revolutionize the IT industry.
So what really is Python programming language? Python is an object-oriented, high-level programming language that supports built-in data structures and dynamic semantics. It supports multiple programming paradigms such as structured, object-oriented, and functional programming. Python is often described as batteries-included language because it has a comprehensive collection of standard libraries. Python supports different modules and packages, which allows program modularity and code reuse. Python was developed by Guido van Rossum, and its implementation started in December 1989. Python 1.0 version was released in the year 1994. Python 2.0 came out in October 2000, while Python 3.0 was released in December 2008. Now that you have got an understanding of the Python programming language, let's now look at the top 10 reasons why you should learn Python. So at number 10, we have ease of use. One of the most common reasons to like Python is that it is quite easy to learn and code. It provides a simple syntax that improves readability and makes it easier to understand. So developers can create any desktop or machine-based application using this language. Python is very versatile and is instrumental in artificial intelligence and machine learning. We will talk about this later in the session. Compared to Java or C++, it has fewer lines of codes. In the example here, we are printing a Hello World program in Java. As you can see, if you have to write a program in Java, you first have to declare the class name along with its scope. Next, using curly braces, you need to pass the main method along with its arguments. And then, using system.out.println method, you can print Hello World. That's quite a tedious task, isn't it? The same task of printing Hello World can be done using just one line of code in Python, as shown here. You can write the print function and pass whatever you want to display inside the brackets, and that will print the output. It is so simple. That is why Python is considered as a high-level language and it's open source. You can just download it from the website and start using it. At 9, we have active community. You need a community to learn new technology, and friends are your best asset when it comes to learning a programming language. Python has large community support. It has an extensive and active community to assist engineers, developers, analysts, and data scientists with expert support in case of programming errors or issues with the software. You can just go ahead and put your queries in the community forum. The community members will address your queries in real quick time. Communities like Stack Overflow also brings many Python experts together to help learners. Python Enhancement Proposals, or PEP, is where the proposals and the improvements are announced. Also, there are a set of recommendations or core values called the Zen of Python, written by Tim Peters, that represents the guiding principles for Python development. Up next at 8, we have portable and extensible. Multiple cross-language operations can be performed effectively because Python is portable and extensible in nature. For example, if the users have a Python code written on Windows and they want to execute on a Mac operating system or Linux operating system or Solaris, they can easily do it without any amendment. They can also run this code on any platform flawlessly and without any interrupt. Due to its extensibility feature, you can integrate other programming languages such as Java, .NET, C and C++ codes with Python. The components of other programming languages can be used with Python, and thus it can be used to make a cross-platform suitable application too. So it is a really good feature that Python provides. The next reason to learn Python is testing frameworks. Python supports several built-in flawless testing tools and frameworks that help in debugging and speeding up workflows. Some of the tools and frameworks supported by Python are PyTest, Selenium, and Splinter. This is the reason for which every tester tries to use Python-based tools and frameworks to test any application or code or to validate it in an easier manner. PyTest is the most recommended testing framework for functional, integrational, and unit testing. You can run Selenium test scripts using Python programming language to automate various tasks. And Splinter is an open source tool for testing web applications using Python. It lets you automate browser actions such as visiting URLs and interacting with their items. At number 6, we have libraries and packages. Another reason why Python has become so popular in the industry these days is that it has a massive collection of libraries and packages that make your task simple and easy. It has a range of libraries, packages, frameworks, and modules for data manipulation, statistical calculation, web development, machine learning, and data science. Python programmers have developed tons of free and open source libraries that you can use. You can find many of them via Python Package Index, the repository of Python software. Python provides the default package called pip. Anaconda is a third-party Python ecosystem. Other examples include NumPy, SciPy, and Django. Then we have scripting and automation. Python is not just a programming language. It can also be used for writing scripts for automating tasks and workflows without human intervention. The code can be written in the form of scripts and executed later. Further, it is interpreted by the machine and checked for errors at runtime. The machine is used to read and interpret the code. Once the developer checks the code, it can further run or be used several times without any interruption. This allows you to automate a set of certain tasks within a program, or the same code can be used with other applications as well. At number 4, we have web development. Another reason to learn Python is that it makes the web development process so much easier. It provides a wide collection of frameworks that make it easier for developers to develop web applications. Some of the examples are Django, Flask, Pyramid, TurboGears, CherryPy, etc. These frameworks are written in Python, which makes the code a lot faster and stable. The task which used to take hours in PHP can be finished in minutes using Python. Python is also used for web scraping. Django offers many elements of intricate programs such as template design, management panel, signing in, signing up, signing out, URL routing, etc. Once the user establishes the framework, all these features become ready to use. Flask is a microwave framework written in Python. Of all the components that are part of this module, they are all ready to execute in the server context. Pinterest and LinkedIn use Flask. Pyramid offers more attributes than Flask. It will assist users with URL routing and authentication support. TurboGears is a highly recommended and scalable framework that supports features such as authentication, caching, identification, management of sessions, and pluggable applications. Up next at number 3, we have machine learning. The growth of machine learning has been phenomenal in the last 5 years, and it's rapidly changing the world around us. Python is one of the most preferred programming languages for machine learning because of its simple syntax and support for several machine learning libraries. Using different libraries and functions in Python, the system can learn and train itself from past data. Once the system is trained, it can then learn to adjust itself to new inputs. Finally, it can make predictions and perform human-like tasks automatically. At number 2, we have data science. Machine learning and data science go hand in hand. Python is robust, scalable, and provides extensible visualization and graphics options. Hence, it is widely used in data science. Python has libraries such as NumPy for numerical computation of data, pandas for operations to manipulate data on numerical tables and time series. It also provides SymPy for symbolic computation and SciPy for technical and scientific computations. It has another library called PyBrain, which is sought for Python-based reinforcement learning, artificial intelligence, and neural network library. Scikit-learn is the machine learning library for creating classification, regression, and clustering algorithms. And finally, it provides PyTorch and TensorFlow for deep learning. Finally, coming to the most important and the top reason to learn Python, which is career opportunities and salary. Python language provides a variety of job opportunities and promises a high growth graph with huge salary prospects. It is being used by most of the tech giants. Industry leaders using Python are Amazon, Google, Facebook, IBM, NASA, Netflix, and YouTube. Next, you can see the Google Trends, where I have considered 3 programming languages: Python, Java, and C++. I have compared them for the past 12 months. You can see it clearly on your screens that Python has become a front runner in terms of popularity and web search volume. It means people are interested in Python, they want to learn it and use it in their work. You can also check for the YouTube search. There also you will find that Python programming language is the most searched language on YouTube. Now on your screens, you can see the report of PYPL, which is Popularity of Programming Language Index. It is created by analyzing how often language tutorials are searched on Google. It is a leading indicator. The raw data comes from Google Trends. The bar graph depicts that Python is the most popular and widely used programming language across the globe, followed by Java, then JavaScript, and C#. The Popularity of Programming Language Index can help you decide which language to study or which one to use in a new software project. The next graph shows the popularity of Python and Java over the years, starting from 2004 till the current period, which is 2020. Worldwide, Python is the most popular language. Python grew the most in the last 5 years by 19.4%, and Java lost the most by -7.2%. Now let's talk about the different career opportunities and the job roles that you can get into if you learn Python language. First, you can become a Python developer, where you will be asked to write and test codes, debug programs, and integrate applications with third-party web services. Second, you can become a web developer. Here, you will be responsible for writing server-side web application logic. Python web developers usually develop back-end components, connect the application with third-party services, and support the front-end developers by integrating their work with the Python application. You can also become a data analyst if you know Python. As a data analyst, you have to gather data from multiple sources using scripts, analyze that data, develop and implement databases, and data collection systems. You can become a data scientist. As a data scientist, you need to understand the challenges in business and come up with the best solutions using modern tools and techniques to analyze, visualize, and build prediction models to make business decisions. Lastly, you can be a machine learning engineer, where you can develop intelligent machines that can learn from vast volumes of data and apply knowledge without human intervention. So there's a lot of scopes if you learn Python. Now let's have a look at the salaries of some of these job roles. So if you become a Python developer, you can earn an average salary of $76,526 per annum in the United States, while in India, you can earn an average of 4,98,000 rupees per annum. Also, if you learn Python and become a data scientist, you can expect an average salary of $113,000 per year in the United States, while in India, you can earn an average of 10,28,000 rupees per annum. Let me now go ahead and call out the 10 reasons for learning Python once again. At number 10, we had ease of use. At number 9, we had active community. At 8, we had the portable and extensible feature of Python. At number 7, we saw the testing frameworks. At 6, we had libraries and packages. Then at 5, we saw scripting and automation followed by web development. Then we had machine learning and data science at number 3 and number 2 respectively. And finally at number 1, we had career opportunities and salary.
So who is a Python developer? Let's answer this. So here are some of the technologies used by a Python developer. Pandas, Anaconda, TensorFlow, Python IDEs, Django Web Framework, and Python. A Python developer is one who develops backend components of a web application using Python when working as a web developer. Now, the web frameworks like Django and Flask are used for this purpose. A Python developer is also the one who writes effective, testable, and scalable Python code. He also performs data analysis when working in the field of data science. So basically, a Python developer develops, deploys, debugs, and maintains a project. So let's go through the skill set of a Python developer. Now, the core Python skills that a Python developer possesses are data structures like arrays, list, stack, queues, trees, and graphs. There's OOP concepts like inheritance, classes and objects, and abstraction. There's packages and functions, that is importing external packages into a Python code. Database and its connection, that is connecting a Python backend to a database like MySQL. When it comes to data science skills, there's NumPy, that is a library for performing mathematical calculations. There's Pandas, that is the library for storing and manipulating data efficiently. There's SciPy, and then there's Matplotlib, which is a library for plotting charts and graphs for a given data. And finally, there are machine learning algorithms, which consist of models like supervised learning, unsupervised, etc. Now coming to web developer skills, there are frameworks like Django and Flask for backend development of web applications. And then there's web scraping, which includes taking data from websites and converting that data into usable format. There's API handling, which is basically handling API requests for a web application to perform server-side operations. And finally, there is backend connection, which basically involves the backend part of a web application, usually handled by Python frameworks. Now moving on, let's look at the Python developer job roles. First up is Python web developer. Now a Python web developer usually writes server-side code, works on the web frameworks like Django and Flask, collaborates with the data team to gather end users' requirements, develops the server-side platform, deploys applications, performs tuning, usability, improvement, and automation. Moving on, next job role is data analyst. Now, a data analyst generally works on Python libraries including Matplotlib, NumPy, Pandas, etc., carry out data analysis, collect using the scripting language, explore data sets, gather requirements, tune in applications, analyze problems, communicate findings with the team or stakeholders. The next job role is automation test engineer. Now, an automation test engineer usually works on Python test framework tools, including PyTest, PyUnit, perform complex system tests, troubleshoot code issues, create test scripts, design the automation framework, perform A/B testing. Next up is machine learning engineer. Now, a machine learning engineer has the following roles: to perform statistical analysis of data, put machine learning models into production, research and transform data science prototypes, research and implement appropriate ML algorithms and tools, perform ML tests, and keep updated with the ML trends. The last job role is software engineer. Now, a software engineer is expected to write server-side code, collaborate with the design team to gather end users' requirements, develop the server-side platform, deploy applications, perform tuning, usability, improvement, and automation. Moving on to the next topic, let's look at the Python developer salary trends. Now, software engineers with Python skills are offered better salaries across the globe. The average salary of a Python developer in India is around 7,55,000 rupees per annum. The average salary of a Python developer in the US is about $79,000 per annum. Moving on to our last segment, Python developer resume. So let's go ahead and understand what a Python developer resume should portray. Just keep a few things in mind when you're preparing your resume. Your resume should be clear, updated, and concise. You should prioritize the skills according to the job role you're applying for. And do not write anything extra. That's a big no. The recruiters are smart enough to know that. So do not lie and do not write extra. Firstly, let's look at the fresher resume. So if you're a fresher, these are some of the points that you need to know. First, you have the resume header. Now the summary is supposed to be clear and concise. Just say what exactly you want and some of your strengths. Next is the profile links and your portfolio. So you can mention your LinkedIn profile link and also your GitHub repository link if you have. Next up is the projects. Now clearly depict the goal of your project. So just in case you worked on say 5 projects, make sure you keep it concise and crisp. Next up is your education. Do not lie here. Make sure you give relevant education with grades. Next you have the certifications. If you have any certifications or achievements, go ahead and write them down. Next you have the technical skills. Now again, prioritize according to the job role. And lastly, you have your non-technical skills. This could be your communication, analytical skills, problem-solving skills, etc. Moving on to an experienced developer. So again, mention the resume header. Then you have the summary, again very crisp and clear. Go ahead and mention your portfolios and your links. Coming to experience, now here you'll have to clearly depict your work. You'll have to make sure that you write down all your responsibilities in that company. Do not go overboard and write extra. Keep it very concise. Again, relevant education and your grades. You have technical skills. The same goes for this as well. Prioritize according to the job role. And finally, you have your non-technical skills.
Now let's go over some of the features of Python. And these features are actually why it's considered that using Python is advantageous over using other languages. So let's start with some of these points. Now, as we mentioned, Python is it's a very readable program. Code readability is very important. It's one of the design philosophies behind this when it was being developed. It's very easy to learn, which is why Python is an entry point for many people that are just beginning to learn programming. And as I mentioned earlier, it's a high-level language. In Python, since Python is open source, as I had already mentioned, so it benefits from all the benefits you get from any open source technology. Now, it's also portable. So what this means is that if we create a code in Python and we create it in a particular system, say on Windows, we don't need to make any changes if we wanted to use the same script or that same piece of code on some other system, say on a Linux system or a Mac system. Python itself comes with a very large standard library. This facilitates us a lot because we don't need to create our own libraries or modules or have to download very specific libraries. Most of the problems that we do encounter quite commonly can already be solved by the standard libraries that have already been provided by the developers of Python right from the beginning. Now later on during the course, we will encounter what is the meaning of a data structure. A data structure is essentially manipulation of an object of data. And as you will see later, Python has one of the most user-friendly data structures that can be found in any language, especially compared to some of its contemporaries. Now, Python is a dynamically programmed language, and this is very important. And what this means is that in most compiler-based languages, there are certain processes that can only happen during the compilation stage. So what a dynamic programming language does is it takes all those compilation-specific tasks and processes, and it does it for us as we actually type the code. So we don't need to waste time or spend extra time to do something that would otherwise be needed to be only done in compilation. We would have to set out specific runtime just for that. So this allows us to create our programs and solutions much faster and allows us to debug much easier. And so it's a very important feature about Python. Now quickly I will just go over some of the areas of Python where areas of or different domains where Python is very heavily implemented. And the first few ones that come to mind are like web development and are AI and machine learning. So you have technologies like Django and Flask that are built on top of Python that are used extensively for web development. When it comes to something like artificial intelligence or machine learning, you have distributions such as Anaconda, you have Pandas, and many other libraries like SciPy and NumPy that are used extensively to tackle problems in this domain. And similarly, Python finds use in most of the scientific work that goes on nowadays because of, again, some of the libraries that I have already mentioned, such as SciPy. Interestingly, if you are into game development or gaming in general, you would see that Python actually has certain libraries and certain technologies that facilitate game development very, very well. One very popular game, if in case you are into gaming, is a World of Tanks that is built on Python. Some of the other applications are, of course, desktop, creating desktop GUIs, image processing, graphic design applications, and something that is very relevant to me and, of course, you as well, is creation of education programs and training courses. There are many technologies in the environment of Python that were almost designed for the specific purpose of being able to present certain concepts or to be able to teach certain classes. And I can't think of too many programs or too many environments outside of Python that are better to solve these education and training course related problems and situations. Let's get to actually installing Python. So now that so I will show you how to install Python on Windows, since I have a Windows system. However, I will also point out the way you would have to install Python on Mac OS or Linux or even on mobile. So yeah, let's get started. So to install Python on your Windows computer, it's as simple as going to the website python.org and selecting the downloads section. When you do click on downloads, you get redirected to this website this web page that I'm on out here. By default, it will ask you if you want to download Python 3.9, which is the latest version. But of course, if you, for whatever reason, if you needed a particular version of Python, you can download that as well by just scrolling down and choosing the option that you want. Now, it's important to note that whatever option you choose, of course, I would recommend the latest one, but no matter what option you choose, I would recommend you choose a version of Python 3 point something, because previous versions of Python, namely Python 2.7 and basically every version of Python 2 point something it will not receive any more maintenance and updates because the developers have decided that Python they are trying to shift towards maintaining and updating Python 3 point whatever completely right now. So yeah, let's not delay this any further and let's just download Python 3.9. So once you select the option out here, you'll get an installer. All you have to do is click on that and it'll give you two options: to customize installation or install now. I would of course recommend just do install now. Since you're a beginner, do not worry about what a custom installation is. If you have multiple drives in your system, by default the Python will be downloaded into the drive where your Windows is actually installed, your main drive. So as you can see now, that once my setup is done, it should give me a pop-up soon. So my setup is done for Python, and this is essentially how you would download Python on your Windows system. But what if you had Mac OS or if you were using Linux? Well, for Mac, it's actually almost as simple. You just go, if you see out here below this download button, Python option, you get the website asking you, are you looking for Python on a different OS? And it gives you the options of Linux, Mac, and even other OSs. But for Mac, if you wanted, you would just open this tab, and just like the Windows option, you would choose a version and you would choose an installer for that version. So if I wanted, say, Python, the latest one, I would just download this installer and I would install on my Mac system. Now, when it comes to Linux, I cannot show you exactly how you would install it. There are certain commands that you have to execute, but essentially, again, if you would just choose the Linux option out here, it would take you to a page with different installers and essentially packages for Linux systems in specific. What I would recommend to you, if you are a Linux user and you need Python, is to go over to the realpython.com website, and they have a very good essentially instructions on how to install Python. And since I don't have a Linux system, I cannot directly show you how to install Python on Linux. So yeah, if you do have Linux, please head over to this website, and this should be of a lot of help to you. Now, as I had mentioned, you can actually install Python on your mobile devices as well. So if you were, say, an iOS user, you would go to the iOS App Store and download an app called the Pythonista app for iOS. It essentially is like a full-fledged Python environment where you can develop in Python on your iPhone or even iPad. And if you were an Android user, you would go and download an app called the PyDroid 3. There's a free version and a paid version for this app. And of course, the difference between the free and paid is that the paid supports code analysis and code prediction. These are certain details you don't have to worry about right now. And honestly, if I wouldn't worry too much about installing Python on your mobile devices currently, since I am assuming most people would be learning programming in Python on their PCs or laptops. What I had actually shown you was installing what is called an implementation of Python on your system. An implementation is essentially a program or a software or an environment that allows you to actually work in Python. So what I showed you was how to install the by default or the most basic or reference implementation that has been created by the developers, which is actually called CPython. Even though you would not have seen the letter C or the prefix C, but yeah, that implementation that I had downloaded myself and I had shown you to download is actually the CPython implementation, which is Python built on top of C, the C language essentially. There are other implementations such as IronPython, which uses the .NET framework, and JPython that uses Java virtual machines that you could use if you were interested. But again, these are things that I would not worry about too much right now. So now that we have tackled on how to install your implementation of Python, I want to introduce what is called a distribution to you. This distribution is called Anaconda. Anaconda is a very important distribution, especially if you are looking to use Python in data science and machine learning and AI, which I am assuming is the motivation for many of the people that are actually watching this video, that they actually want to move into data science and they need to learn Python as a foundation towards moving towards data science. And if that is your goal, or in any case, whatever your goal may be, I would recommend that you install Anaconda distribution. Now, do not get confused between Anaconda and Python. Anaconda is Python with in the form of a bundle, and this bundle contains not only the basic Python implementation that I had shown you to download, but it contains a lot of extra libraries and technologies and softwares as well. So, of course, this means that would you need to download both? Of course not. If you downloaded Python, you do not need Anaconda to work on Python. And if you have already downloaded Anaconda, which I will show you how to do it in some time, if you have already downloaded Anaconda, you don't need to download Python separately. So I'll just speak about Anaconda a little briefly. So as I said, it's a distribution. It contains a bundle which includes the basic Python implementation and a lot of technologies and softwares and applications that essentially help us to use Python in specifically managing big data applications and data science related projects. So now I will show you actually how to install Anaconda on your system. It's as simple. It's actually as simple as downloading just this thing. So if I did a quick Google of Anaconda, so the website that I'm looking for is anaconda.com, and I'm looking at products and I'm looking at individual edition. There are other editions as well, like commercial, team edition. These are for companies usually, or for more professional sort of projects. So of course we are looking at the individual edition, and if you selected this page, you would be taken to this particular web page where it will ask you if you want to download. And again, there are options depending on which machine you're using. If you're using a Linux, you would choose one of these two. If you are using Mac OS, you would use one of these two. And since I am a Windows user and I have a 64-bit system, this is the option I would use. So again, it will first download an installer for you. And as you can see, my installer has been downloaded. So upon opening it, it will open up this installation thing. You can just click next on most of these. Again, if you want to specify your destination folder, you can change it here. Mine will be with a default folder in the C drive, and you can leave this unticked. You can change these options much later. So this is how you install Anaconda on Windows, and it's pretty much the same on other systems as well. Now once it's done, I will show you what are some of the things that Anaconda contains that are not there if you installed Python, like the way I had shown you earlier, just the bare bones Python implementation. So as you can see here, my installation is actually complete, and now I will open Anaconda and I'll show you how you can actually use this Anaconda. So if I search for Anaconda in my system, I would look for something called Anaconda Navigator to actually get started with this. And when I open that, it should open something like this. So this is what opens when you click on the Anaconda Navigator. And as you can see, there are a bunch of applications. You don't need to worry about what these mean right now. Just understand that this is essentially a bundle of different applications and technologies that come along with just the normal installation of Python that you get when you install Anaconda Navigator. Now that we have actually tackled where we've seen how to install, and I'm hoping and I would recommend definitely that everyone who is watching this video installs Anaconda, not just the normal Python installation or implementation. Now that we have gotten all the introductions and the basics and the installations regarding Python aside, let's get down to actually creating our first script. So now the question is, how do we actually start doing this task of creating our first Python script? How do we realize now that we've installed Python, how do we start doing something? So the answer to that question is that typically when you're working on Python, one of the most basic things that you can do is create a Python script and execute a script. A script is essentially a sequence of commands and instructions that you give for Python to run and execute to give you a certain result. So I will show you how you can create a Python script. Now there are multiple ways of creating a Python script. You can create it directly from command line, which is obviously something I would not recommend because it is not convenient and easy, and it's not very useful for a beginner. Another way is using a text editor, such as the one I have opened right now, which is the Notepad++ text editor. Now it's very important to not get confused between Notepad++ and the standard Notepad that comes with your Windows or WordPad for that matter. In fact, text editors such as Notepad and WordPad that you are more familiar with create text and files in a form that is called rich text. Now, rich text is text that contains formatting and fonts, which is actually a hindrance when it comes to creating actual code. So what we need is a text editor that creates or writes text in what we call as plain text. Plain text is obviously text which does not contain these fonts and these formattings, and it only respects white spaces and indentations, those two being actually useful towards creating code, unlike fonts and formatting, which are only a visual thing. So Notepad++ is obviously a text editor that creates plain text documents. That was actually created with programming in mind. Obviously, you can use a bunch of other text editors such as Vim and Atom, and you can Google for these. There are plenty of them. So without any further ado, let's create our first Python script. So one of the most common, one of the most famous examples of a first program in any program for that matter, not just Python, is creating a print statement that gives us a statement saying hello world. So in Python, this is how you would go about it, or this is the syntax you would use to create this statement. Alright, now where it is very important when you are saving your Python program that you use the .py prefix. So if I were to save this, I can choose whatever folder. I am going to choose, this folder seems fine. So now I give the file name over here as, say, I want to keep it as test. I need to prefix this with .py, and this tells any sort of interpreter, or anytime we need to read the script to know that it's a Python script, we need to add a .py Otherwise, it will not be treated as a Python script. It will be treated as some normal document sort of a thing. So now that I have stored it as .py, I have created my first Python script. Now, obviously, the next question is I need to see what happens when I execute this line, when I run this script, essentially. So to see that, there are multiple ways. The first way that I will show you is a command line method, which is obviously, again, before we get into it, it's not something that I will be using to teach you. It's not something I would recommend you to immediately start using. But for the sake of showing, I will show you how to execute a script in command line. Well, to do this, you go, since I have installed Anaconda in my system and I will be using Anaconda to work in Python, what I will look for is something called the Anaconda prompt. As you can see, this is the option that I get, Anaconda prompt. This will essentially open you a command line under the environment of Anaconda or Python. So in this, now I am already in the folder, I believe, that had my script. So how do I call this script, or how do I run this script? Well, the command is Python space the name of my file, which was test. Of course, the prefix is very important, so I enter test.py. If this was in a different folder, you would have to change your folders in command line, which is again something that I might show you later. But since I am in my command line, I would just have to enter this command right now. So if I execute, as you can see, it's given me an output of hello world, which is what I wanted. I wanted it to print this these two words for executing a Python script. Now another question would be, well, this isn't the most visually appealing or not the easy to read or easy to executing scripts, and I would agree, and that's why I'm going to introduce another technology or a software called the IDE. So the IDE in Python or environment, it's essentially a software that not only allows us to run scripts, but it allows us to create the scripts, it allows us to debug, it allows us to see outputs, it allows us to see intermediary outputs, it allows us to do a wide variety of tools and tasks, and it comes with a bunch of robust features to enhance our Python programming experience. So let's see. So I will show you an IDE called Spider, which comes bundled along with the Anaconda distribution that I had mentioned earlier. So if I open the Anaconda navigator, as you can see, called the Spider IDE, which is over here, as you can see here, it's a scientific Python development environment. This is exactly what I'm looking for. So I am looking to launch this. So now that I've launched it, you can see out here, this is what an IDE looks like. Now this looks very sophisticated, and almost any IDE is a wonderful software that where you can create your code, you can debug your code, you can check the results, you can make adjustments, changes, and you can do a wide variety of tasks and functions with relation to your programming. Again, don't worry about the details, the syntax, what I'm exactly doing. These are things that we will actually cover in upcoming videos and modules. So let's create a variable called A. Let's store a number 3. Let's create a variable B, store a number 5. All right. Let's create another variable C, which will store the result of what's in A and B, in the addition of A and B. All right. And let's print the result. I will print a statement saying the result of I get the result in this pane. So let's execute this, and you can see my first line is executed saying I will perform basic maths, and the next line says the result of the addition of 3 and 5 is 8. So in this script, what I've done is I have performed 2 print statements, and I've performed a basic expression way of we can create a completely new script. We don't need to create a script from some special file or text editor. I can just create a new file here, and this is my new script essentially. So I can start working with this new script right over here from the get-go. So IDEs are very powerful. Spider IDE comes bundled with Anaconda. There are other IDEs such as the IDLE IDE. It stands for Integrated Development and Learning Environment. So the IDLE IDE comes as part of the basic Python implementation that I had shown you in the previous video, where if you just installed a basic Python implementation, it would come along with a basic IDE known as IDLE, or Integrated Development and Learning Environment. But of course, since we are using Python, and that is what I would recommend, it comes with a more robust IDE called Spider, which is actually very, very helpful for scientific and numeric applications, and was designed specifically with that in mind. Now, this is not the only way we can actually work with Python. There's another very interesting and a very educative method of creating Python, let's say Python programs. And it's something that I will be using extensively throughout this course to explain different concepts. So this technology is called, or this software is called notebooks. Now, before I get into the details, I will just open a basic notebook. So the notebook that comes as part of Anaconda is called the Jupyter notebook. And when I open or when I launch the Jupyter notebook, this is what I get. Now, a very important feature or a feature of notebooks is that notebooks are a web browser or a web-based application. So it's not something that you can use if you are offline or disconnected. Basically, if you're disconnected from the internet, it is something for which you would need an active internet connection. However, it is way more robust, and it has very, very good properties that allow it to be used in education or for presentations and such. So as you can see, this is my Jupyter notebook. These are a bunch of folders. You don't need to worry about what these are right now. I will show you how to create a fresh notebook. So if you go here, you go to new and you select under notebook the Python 3 option. It will open your first notebook. As you can see, this line is essentially waiting for me to enter some sort of a command or a statement that I would give in a normal Python thing. Now, if you would have noticed until now, everything that we were doing involved us creating a script, which was the whole series of commands and functions. So if I go back to my Spider IDE, as you can see, like this is a whole script, and this script contains multiple different tasks and functions that are individually being performed. So this is a separate print function, this is a separate addition, another separate print function, and for longer programs or larger programs, you'll have multiple different tasks being done. And if you were using a script, you can only see the result of something like this by executing the whole thing at once. You cannot see exactly what is the result of just this print statement or just this. It's not typically what an IDE is used for. And this is where notebooks come in super handy. If I had to break down my previous script essentially, where I first did a print statement, where I said some random thing, say hello. Yeah. So if I execute this particular line, you can see it gives me the result. Now I want to do what is 5 plus 3. It should give me the result over here, 8. Now the next, another part of your program might be storing 5 and 3 into variables. So I can do this and I can do this. So now this line will store the variables. Now I want to do the addition of what is 5 plus 3, but I want to use the variables and I want to see what's the result. As you can see, a plus b means 5 plus 3, which is 8. And I've essentially broken down various different parts of my previous script into its individual tasks, and I'm able to see what each part of that script does. And this is very good when it comes to making presentations or trying to teach a class. So I will personally be using notebooks a lot to explain different concepts when it comes to Python. And I would recommend that you get used to notebooks in general, because it's an amazing way to learn Python programming, or programming in general, in fact. And again, as I had mentioned earlier, notebooks are something that it's an online application. It's a web-based application. So I will have to need a active internet connection to be able to work on a notebook, which could be a disadvantage if you do not have a consistent internet connection. And in that case, you would probably use your IDEs or text editors, which can be used offline as well. In this video, we will be introduced to the concept of variables and expressions. Let's start with expressions. Well, an expression in Python is anything that results in a value. Its difference, or the difference between an expression and a standard statement in Python, is that a statement in Python is something that results in an action or an execution of a command. There is no calculation per se, or any sort of manipulation, or, as I said earlier, calculation resulting in between two different, say, numbers or other objects that results in a value. And this happens in the case of an expression. So for example, if I were to add two numbers, say 5 plus 10, this is an expression where two objects 5 and 10 are being added and a result is being given to me, which is 15. Now let's see an example of a statement. Well, a statement could be something like a print statement. So when I ask Python to print something for me, it's not calculating anything, it's not evaluating anything, it's simply performing an action that I have, or a command that I have given the system, which is to print whatever I have entered over here, as you can see. So this is a statement. Similarly, there are another type of statement known as assignment statements, which we will learn actually right in the next section. Well, let's move on to variables right now. Now, earlier, you might have learned about objects in Python. So objects are essentially data that we can work with or manipulate in Python. Now, variables are a place to store these different objects. Usually, it's much easier to store objects in Python instead of using the objects explicitly themselves, because objects may be very complicated, whereas variables are very simple to use and very simply are named in a very simple manner so that we can use them quite often in our programs. Now, it's important to note that in Python, we do not have to explicitly declare or define a variable to create them. In fact, variables are created in the same statement where we assign some object to that variable. In Python, the assignment of variables happens using the assignment operator, which is the equals to sign. So if I wanted to assign a number, say 100, to a variable, say b, well, it would be as simple as doing this. Now, anytime I want to know what is stored in b, I just have to enter b and I will get the value that is stored in it. And we can store different types of objects inside any variable. Let's say I want to store this particular word in the form of a string. Now this is stored in x, and if I want to know what is in x, I can just see what is here, and it's a string hello, which I had stored earlier. Now it's very important that we follow certain naming rules when it comes to naming our variables in Python, or else we may be thrown errors or we might get some problems in our program. So the first rule is that you cannot start your variable name with a number. So if I were to give a variable name like 4num is equal to something, say the same string hello, this would be an illegal variable name and I will get an error when I try this. So if I were to choose in num4 is equal to hello, this would be perfectly fine. I won't get an error. The second rule is we are not allowed to use any non-alphanumeric characters except the underscore character while naming our variable. So for example, if I were to name my variable num_4 and I said random, some random string, this is perfectly fine. However, if I changed num_4 to num-4, this will throw me an error, as you can see over here. Next, the third rule is that variable names are case sensitive. So if I have a variable called num, or say num, if this was one of my variables and I stored, say, the value 50, this is not the same as me writing num all in capitals and say storing some other value 60. These are two different variables. So it's very important that when you name your variables, you are aware of what case you are writing them in, because Python variables are case sensitive. Now the final and probably one of the most important rules in Python is that you're not allowed to use what we call reserve words in Python. Now Python has a bunch of reserved words. These words essentially are performed, or they are used to perform certain special functions and are used as identifiers for certain special functions in Python that have a special purpose. Like that particular word has a special purpose within the Python programming language, and we cannot use them to name our variables. So a list of them, as you can see over here, some of them are like false, def, if, del, raise, and there are around 33 of them. And sometimes some of these words are taken out. Sometimes there are more words added as Python gets updated. Now, let's move on to a concept where we try to really understand what do we mean by storing data inside a variable. Now, when I say that we are storing something inside a variable, you get an image or you get an idea in your head that this variable is like a container where we store or we put a particular object inside it. So does this mean that variables have a place in the memory? Are they also an object? that is placed in the memory where we can put other objects inside of? Well, I'll show you an example where this idea is kind of disproven, or where I'll show you that the idea of variable is kind of different than what we understand by storing something inside a variable. Now, let's say I'm storing the same object. I will take this object as some random number, let's say 100, and I'm going to store it into two different variables. So I take x is equal to 100 over here, and in the next line I will store 100 in y as well. Now, if variables were objects that we placed in our system, then x and y should have two different IDs. But let's see what happens when I check the ID of x and the ID of y. They should be different in case variables were their own objects. However, as you can see, the ID of x and the ID of y are exactly the same. So, well, obviously we know that two different objects in Python cannot have the same ID. So what does this mean when it comes to the nature of a variable? Well, the fact is that variables are not actually objects in Python. In fact, variables are more like pointers or references to the actual object. So when I said x is equal to 100 and y is equal to 100, what I'm actually telling the system is that there is this variable name called x that I want to refer or point towards the actual object that is in my memory called 100. And I do the same thing with another variable y. So I am not exactly creating a different space in my system for these variables. These variables are more like placeholders or references that point to a particular place in the memory where this object is located. And that is what happens when I do ID of x and ID of y. It's not giving me the ID of something called x or the ID of something called y. It's giving me the ID of 100 each time because 100 is stored in x and y. So as you can see, this is something like a visual representation of what I'm trying to say. And similarly, if I were to, so in this example on the left, as you can see, I've used the value of 50 to explain my point. So as you can see, initially x and y are pointing towards this value 50 because I have stored 50 and 50 in both x and y. Now what if I changed the object that is stored in x? Well, that means x is now pointing towards this new object, and I have stored this new object called hello, this string called hello, as you can see here. So now x is pointing to a new object in the system, and it's called hello. And I haven't changed anything with respect to y, so y will point towards the same thing. And I can also make the pointer of y different, or what I'm trying to say is I can store something else in y. Say I stored this list in y, 50, 60 and 100. And when I do that, now y is pointing towards a different object in Python, and x is also pointing towards something else. So what happens to this object 50? Well, now that there's no variable referring to this object 50, it becomes what we call an orphaned object. And we can actually see that when we do the ID of x, now let's go back to my example on the right where I stored x is equal to 100. So as you can see, it gives me some ID represented by this number. Now let's say I stored something different in x, say 200. Now if I do the ID of x, it should give me a different ID because as you can see, the values are different. And this is because this object 200 is what is stored in x, and when I do the ID of x, I'm actually getting the ID of this new object now, 200. So as you can see, variables are, they should be, and they are treated more like references or pointers instead of containers for a particular object. In this video, you will be introduced to the concept of objects in Python. Now, what are objects in Python? Well, all the data that we manipulate or use in our operations in our code are represented as objects or relations between objects. So if you want an example, two numbers that you add in your code, well, both of them are objects, and they're usually numeric type objects. Similarly, if you want to store someone's name or an address of your hometown in your code, you usually store it in a form of text, and that text is also an object, usually a string. Similarly, you might want to create a container of different smaller objects inside them, and that big container is also a type of an object, and one of those containers are called lists. And similarly, we have many different types of objects which we will be covering during the duration of this course. The following pictorial representation gives us a broad classification of different Python data types and objects. As we can see, there are 5 broad classifications: numeric, which contains integers, complex numbers, and floats. We have the dictionary data type. We have the Boolean, which essentially consists of objects that have only two valid values, true or false. Then we have sets, and we have sequence data types, such as strings, lists, and tuples. Every object in Python has three important properties that kind of define that particular object. They are its identity, its type, and its value. The identity of an object is, it can be considered as a place in the memory or its address in the memory where an object is stored. An object's identity does not change once it has been created. So for example, if I took an example of, say, a string called hello, I can use the id function, this is how you use the id function to find out the id of this object. And it should be, the answer should be in the form of a particular long integer. So as you can see, the id of hello is this integer 2326476623024. Similarly, all objects in Python have an identity. We have another operation with regarding the identity of an object is the is operator. And the is operator compares the identity of two objects. So if two objects have the same identity, it should give the answer true, otherwise false. Now the next property of objects is the type. The type of an object is essentially what defines what kind of values and operations that object can have. So for example, a numeric data type in Python, such as an integer, would allow us to do arithmetic operations. And similarly, string object type in Python will allow us to do concatenation operations. Much like its identity, the type of an object cannot be changed as well. Now let's see what's the type of that particular object that I had shown you above. As you can see, it should be string. str stands for string. Similarly, if I did a type for a number, say 50, it should give me int, as you can see. Now the third property of an object in Python is its value. Now the value is the actual data that is contained in the object. It's the thing that we use, that we display, that we can manipulate, and that we can perform operations on. So for example, if I were to talk about this string is hello. So the value of the string is the word or the sequence of letters that spell out hello. And similarly, this particular object is a numeric object with the value 50. Let's see, in this pictorial representation, I have shown you that you can assume this dashed blue area as the memory of the system. Now within this memory, we have objects created called 50 and hello, and this list containing smaller objects called cat, pen, and 40. Now, what I'm trying to show you here is each of these objects have a type, an ID, and a value. And let's see what they are. So if I wanted to see, as we had already seen the type of 50, now let's find the ID of 50. As you can see, we get this unique ID for the object 50, which is obviously not the same as the ID of the object hello above. And the value of this object is the value of 50 itself. So that was a brief introduction into objects in Python. In this video, we will cover the topics of numeric object types and type conversions in Python. So let's get started. Numeric object types in Python are a broad classification of objects. Plenty of common real-life applications that we associate with numerals, such as arithmetic operations and calculus, are done in Python using numeric object data types. There are three main types of numerals or numeric data types in Python. They are integers, float, and complex. Integers, as the name suggests, represent all integer values in Python. These can be such as 100, -3, 305, and so on. Floats are used to represent numerals that contain decimal points, such as 100.3, 3.9, 4.8, -6.8, and so on. Then there is the complex object type, which is used to represent complex numbers in Python. And this is an example of a complex number, 3 plus 7j. This is a complex number 3 plus 7j, where the real component is 3 and the imaginary component is 7. All complex numbers have a real and an imaginary component, and this is how we denote them. Now it's important to note that this j is a very common symbol in maths and engineering used to denote the imaginary portion of a complex number. And it's the same in Python as well. So moving on, let's talk about type conversion in Python. Type conversion refers to the conversion of an object from one data type to another. For example, from string to an integer. And there are different types of conversions, and let's go through some of them. First of all, let's consider the conversion of something to an integer. And more specifically, let's consider the example where we convert a string to an integer. So let's consider my example string to be something called 145, and I'm storing this within a string for a reason, because I want to convert a string to an integer. So as you can see, I have stored this 145 within my within a variable x, and if I were to confirm that it is actually an integer, I can use the type function and see that it is actually an integer, str. Now let's convert this into an integer using the int function. So how would we use it is simply passing the int by passing the variable that we want to convert into the int function. And as you can see, this is what I've done over here, but before this I will also store it into another variable. Alright, now let's see what's in y. Well, y gives us 145, but are we sure that it's an int? We can just check it by using the type function. And as you can see, the type gives us the answer int. That means that we've converted the string to an int. Interestingly, we can convert something and also specify what base we have to treat the number as. By default, when we pass something in the int function, the program or Python will treat whatever we have passed within the string as something in base of decimal. But what if we were to pass something that is, well, not in a decimal? Well, we could do it like this. Now let's store y, and in y let's do this, and I will show you what this means. X, and I will give a comma and 8. What this tells Python is, well, I want to convert the string in x into an integer, but I want to treat whatever is in x as a number of base 8. So 145 is actually 145 in the base 8. Now when we see what's in y, we get 101, which is different to 145, because, well, 101 is actually the decimal equivalent of 145 in the base 8. Similarly, if we were to give it in the base 2, we would just replace 8 with 2 over here. Now next, let's talk about converting something to a float. Now as we know, float is just simply something that has a decimal point. So let's convert an integer into a float. How would we do that? Simply by using the float function. So if I gave 120 and I pass this integer through the float function, I should get 120.0. These two are not the same, though they may mean the same things to us, but for Python, 120 is an integer and 120.0 is a different object, which is a float. And this is how we convert something to a float. Now what if we wanted to convert an integer to a string? Well, we can use the str function. We can also use the hex and the oct function if we want to convert a particular number to a hexadecimal or an octal string respectively. Let's look at all three examples. Say I have a number 688 and I want to convert this into a string. I just use the str function around this. So as we know, just to confirm, let's see what the type of 688 is. This should be an int, as we can see. But let's say we convert it into a string 688 and let's store it into some variable. Let's call it a. Alright, now let's see what's in a. It gives us 688 in the form of a string, but we can confirm by checking the type of a. It is an str, so it is a string. Similarly, we can use hex if we wanted to convert an integer into its hexadecimal equivalent as an output of a string. As you can see, this sort of complicated thing is actually telling us that we have converted 688 in terms of hexadecimals. Now, how do we read this output? This 0 should not be treated as anything. It's more like an identifier, which says that the letter after this first 0 is the base of this whole number. So it's saying that x stands for hexadecimal. So it's saying that 2b0 is to be treated as a hexadecimal number. And if you did basic maths, you would find that the decimal equivalent of 2b0 is 688. Similarly, if I did oct, if I use the oct function for 688, it will give me the result something like this. So again, how to read this. The first 0 is to be treated as an identifier and not part of the number. What it's saying is the letter after the first or after this 0 is the base of the number following these two characters. So as you can see, what's this saying is that this whole number is an oct represented by this letter O, and the number itself that we are dealing with is 1260. And 1260 in octal system is the equivalent of 688 in the decimal system. So this is how we've converted an integer into a hexadecimal or an octal string. Now what if we wanted to convert two numeric objects into a complex data object? Well, for that we can use the complex function, as you can see here. If I passed complex 5 and say something like 3.1, let's see what this gives us. As you can see, it gives us a complex object where our real part is 5 and our imaginary part is 3.1. So what this does is essentially you pass two numbers. The first one is the real component and the second is the imaginary component. It combines to give you a complex number, as you can see here. Now let's look at some other type conversions. The next type we will be talking about is converting something to a tuple or a set or a list. So what if I wanted to convert a string into a tuple? I will use the tuple function, and as you can see over here. So let's say I have a string called random. Let's call it random. Alright. Now if I want to convert this to a tuple, I will use the tuple function, as you can see over here. The output will give me tuples where each individual component of this tuple are the individual components or the individual characters of my string random. Similarly, if I wanted to convert the string to a list, I would use the list function. And this will give me a list of the individual characters of the word or the string random. And I could do the same thing with the set function to create a set of individual characters of the string random, as you can see here. So yeah, these were some of the basic Python type conversions that I have shown you. As we learn about more complex data types and different object types in Python, we will learn different type conversions and functions associated with them. In this video, you will be introduced to the concept of strings. Strings are an object type in Python used to store textual data. This textual data could be something like, for example, someone's name. It could be an address of a place, or it could be something like a word or a sentence. Now, strings in Python are an object type that is actually a subtype of a broader classification of objects called sequences. Sequences are objects in Python which contain components placed one after the other, where each component is given what we call an index, a numeric index. This numeric index identifies the component in the sequence and its position within the sequence. Now, since Python is a zero index based language, the first object of any sequence is always index 0. The second is index 1, the third is index 2, and so on. Now let's move on to defining strings. How do we define them? Well, strings are defined using what we call delimiters, and delimiters occur in pairs, an opening and a closing delimiter. In Python, these delimiters are pairs of single or double quotes. So for example, if I were to use single quotes to define a string, I would do it like this. This is a string. As you can see, this is a string is printed over here. This is delimited using single quotes. Similarly, if I were to define a string using double quotes, it's as simple as doing this. This is also a, as you can see. Now a valid question arises. What if I wanted to include a single quote within my string? Well, if I tried to, let's see what happens if I try to print a statement with a single quote naturally inside it. So say I'm saying it's my birthday. Alright, let's see what happens if I try to print this statement. It says invalid syntax, and this is because, as I had mentioned, in Python single quotes and double quotes are delimiters, so they have a special function in Python, and we cannot simply just use them within a string because Python will treat them specially for a special purpose. So what Python will do is it will pair this and this delimiters or single quotes and say, okay, this looks like a string to me, and it's not going to understand the rest of this, and then it will find a random single quote, and it won't find its pair, and it will basically throw us an error because of this. So one way or one workaround to introduce single quotes into a string is simply to delimit our string itself using the other type of delimiter, or double quotes. So if I want to include a single quote, I will close my string using double quotes. So if I did this instead of what I had done earlier, this is a perfectly valid and legal way of defining my string. And I would do the opposite if I had to introduce, say, double quotes within my string. I would use single quotes to close it. So if I were to write a speech statement, she said, I am hungry. Alright, I want these two double quotes to essentially show that this is a speech, and I'm going to close the string using single quotes. And this is a valid way of doing it. As you can see, my string has these two double quotes. Now, I had mentioned that strings are sequences. Well, let's describe how are they sequences. So first of all sequences in Python are essentially a sequence of smaller objects that form the sequence, right? So let's try to understand like how are strings to be treated as sequences. Some sequences that we will learn later are like lists or tuples. And in all sequences, we can retrieve any particular object or component in that sequence using its index. And how do we use indexes in Python? Well, we enclose a numeric index within square brackets. Now let's see what I'm trying to talk about by this example. Now say I'm storing a particular string called, say, random within. Now my variable name here is test, and I'm storing the string random within it. Alright? And this is a way of retrieving a particular index from test. I write the variable name, and then next to it I put the square brackets. Now I'm supposed to put a numeral within the square brackets to tell Python like what particular index I'm looking for. So let's try 0. Now, as I said, Python is zero index based language. So the 0 index essentially means the first part of, or the first component of a sequence. So let's see what happens when I ask Python to retrieve the first part of what is stored in test. It gives me the string R. In fact, it's just one character R, and it's a string. So as you can see, it has given me the first character of the string random, which is R. So what this shows is that this string random is essentially a collection or a sequence of one character strings. So random is essentially a collection of the string R, the string A, the string N, and so on together combined to form the whole string that we call random. Similarly, if I wanted the character at the third position of this thing, I would use, well, since it's the third position and since we're working in Python, I would use the index 2, and it should give me the letter N. As you can see, it's given me the letter N. So this is how we can show that strings are also sequences in Python. Well, now let's move on to certain string operations and functions that we can perform. Well, as you have seen already, that we can retrieve any particular character within a string using numeric indexes. Well, what if we wanted to know what index is a particular character at? And we can do it like this. We use the index function. So let's say my test, and I want to know where or what position the character D is in my string random. So this is how I would use the index function. Index, and within the index, say I'm looking for the character D, and now it should give me the answer 0, 1, 2. It should give me the answer 3. So if I execute this, it gives me the index 3. So this is the index function that we can use for our strings. Now, what if we want to say slice a string into a smaller part? We want to slice it, and we want to retrieve only that particular slice. Well, here is an example. Say I'm going to use the same string called random, and it's stored in test, right? So the way of doing this is like this. Now let's just see what this does first. As you can see, it's given me A and D, and if I went to my string random, A and D is this particular slice. Now let's try to understand what I have done by entering 1:4. Well, what this has done is it's retrieved a slice from the first position, the first index, which is the character A, up until the fourth position, which is the character O. but it has not included O. So it's very important when I index like this, every time I put something to the right of this colon, I am not including this itself. Alright, so it's essentially when I say 1:4, what I'm telling Python is give me the first, the second and the third character, but not the fourth one. So it's given me A, N and D, and this is how we do a slicing operation in Python. Similarly, if I were to say slice from the first, if I wanted only the first and the second character, I would do, this is what I would do. If I wanted the first and the second character, I would do 1, 2, 3. So this way it tells Python that I want the first, I want the second, but not the third of. So as you can see, I get A and N. Now, so this is a basic slicing. What if I wanted the portion of a string from a particular point all the way to the right or all the way to the left? Well, let's consider the example of where I want the portion of the string random from the say fourth character until the left. Well, the way I would do this is test. Now since I want it all the way to the left, I don't enter any index to the left of my colon sign, and since I want everything to the left of the fourth character, I enter 4 here. So as you can see, it gives me A, R, A and D, which is everything from the fourth character of my string random to the left. Similarly, if I wanted something to the right of it, I would just do it like this. I would enter some index here and I would leave the portion to the right of the colon blank. So this will give me everything including the third character, since this is how we treat the indexing in Python, everything including the third character all the way to the right. So this is DOM, as you can see. Now another perfectly valid slicing is, say I want to slice or take out different characters from the string, but I want to skip certain characters. Like I want this one, then I want to skip one, and I want to take the next one, and then I want to skip one. Well, in that case, we have to introduce a step. So one way of doing this is, now how do we read this? So as you can see, I've written 0:6:2. So what this is telling Python is, I want every character from my string test, starting from the 0th character up until the 6th, but not including the 6th, after skipping or taking 2 at a time. Taking 2 at a time can also be assumed as skipping 1 at each step, or skipping 1 character at each step. So what this will do is, it will go to random, it will take the 0th one, it will take R, and then it will skip the next one. So it will not consider A, and then it will pick N, and then it will not consider D, and then it will consider O up until the 6th character, whichever that may be. And if you see the output, it gives us R, N, O, which is exactly what we wanted. We wanted R, we wanted N, we wanted O, where we skipped A and D, or we skipped every second character essentially. So this is a way of slicing strings while also skipping certain characters, or skipping characters in steps. Now Python is also there's another interesting technique that we can use in Python to where we can start retrieving characters from the rightmost side of a sequence or a string. We can use negative indexes. So if I were to, for example, show you, let's see what this gives me. Test what is a -1th index. It gives me the character M. Now remember, a string is random, so -1 gave us the last character of the string random, which was M. So this is a way of using negative indexes. And similarly, if I used test -2, it would give me the second last character, which should be the character O, as you can see here. Now there are some other important functions that you may use in Python. So for that, let's create another string. Let's call it upper, lower. Alright, now I'm storing it again in the same variable test. Let's see what happens when I use the upper function and what happens when I use the lower function. Now I'm going to use the lower function for this. So these two functions will respectively give us the result, or give us our string in uppercase and lowercase respectively. So as you can see, the upper function created the first string in full uppercase, and the second one created this string in full lowercase. Now another important, and probably one of the most important methods that we use for strings, especially when it comes to data science, is the split function. So let's see what I mean by the split function. Let me create another string. Let's call it hello world. Alright, and I'm going to use a split function, and I'm going to see what happens when I use this function essentially. So what I'm doing in these three lines is I'm creating the string hello world. I am storing it in test, and then I am using the split function on the test, and whatever result I get, I'm storing another variable called sliced, and then I'm just going to show you what is in sliced. As you can see, what's happened to the string hello world is that I have broken it into its components, or its component words, if that makes any sense, into hello and world, and I've stored both of these into what we call a list. Now you might ask, well, how does Python know that it has to separate at a blank space? Well, the split function by default will break up a string at its blank spaces. But if we wanted, we could break it up using or at every comma. So for example, if I wrote hello world using comma, and if I put a comma inside over here, and now if I try to execute this, like for example, I'm going to look for commas in the string, and then I'm going to try to split it. As you can see, there's no splitting happening. I have one list with my original string itself because it's not found a comma. What if I introduced a comma over here? Now let's see what happens. As you can see, the splitting has happened. It's found this comma and it's caused a split between hello and world. Similarly, in my string, if I put a comma again and I put something else, it should give me the split over there again. So we can define our split using whatever we put in between these circle brackets after the split function. It's just important to note that by default, if in case we do not enter anything over here, it will use blank spaces to do the splitting. Another very important operation and very common operation in strings is what we call concatenation. So if I have two strings first and say another string second, and I want to join these together, well, the operator I would use to do this is called the plus symbol. This is the concatenating operator when it comes to strings. So what is the result of this? Let's see. Let's print this out. Let's print this whole thing, and let's see what is the result. As you can see, what this has done is it has combined the first string first and the string second into one string called first second. So this is the concatenation operator. Now finally, the last topic in this lesson is the topic of escape sequences. Now escape sequences are special commands that tell Python to either suppress special meaning of some character or symbol in a string, or give some special meaning to an otherwise ordinary character in a string. So let's look at the first example. Now remember earlier in this video where I was telling you like what is the way of writing, or how do we introduce single quotes or double quotes into a string, and I had told you the trick. If I want to use a single quote in my string, I just close it using double quotes, or if I want to use a double quote, I close it using single. Well, another way of doing this is using what we call an escape sequence. And an escape sequence in Python is the backslash character. Alright, so let's see what happens when I use the backslash character where I want to introduce my single quote. So if I use my previous example where I wanted to introduce a single quote and say I'm going to close it using single quotes as well. So I'm going to go back to my error example, so as to speak. Now this would throw me an error, right? As you can see, it has thrown me an error. So what if I used the escape sequence that I mentioned? The escape sequence is just backslash character. Now this is the point of the string where I want my single quote. So I introduce a backslash. Now I have my single quote, and I continue writing the rest of my statement. Let's close the string. Now will this work? As you can see, this has worked. So what this has done is this backslash character has told Python to not treat this special character or the single quote, to not treat it specially and let it be as a part of the string. So as you can see, that's what's happened here. Now the next case, or the other use case of escape sequences, is when we want to give a particular character that is otherwise just ordinary some special meaning. So let's take the example of the character T and the character N. We use the character T to introduce tab space, and we use the character N to introduce what we call line break. Well, let's see by an example. So normally the character T has no special function. So the character T within a string will just be outputted as the character T itself. However, as you can see here, I'm going to introduce a backslash before this character T. Let's see what it does. It introduces this thing that we call a tab space, which is a larger than normal space. Similarly, if I were to use the backslash n combination, this would introduce what we call a line break. And if you were to see the output of this, you can see at the point of the string where I have this combination of \n, a line break has occurred. So there are plenty of other escape sequences that you may choose to learn, and these are just two of the probably the most common ones that I used. In this video, I will give you an introduction into lists and tuples. Starting off with lists. Lists are a collection of ordered, arbitrary objects that are similar to what we call an array in other programming languages, but lists are way more flexible when it comes to Python. Python lists are a type of sequence, and you might have seen what a sequence is when we were learning about strings. And much like in sequences or any other sequence, list objects are assigned a numerical index, and whenever we want to manipulate an object in a list, we use its respective index. How do we define lists? Lists are defined using square brackets. So this is a simple way or a simple list that I have just created and assigned to a variable a, which contains 3 objects, 1, 2, and 3. Let's talk about some of the features of Python lists. Python lists are ordered, and what this means is that even if 2 lists contain the exact same elements, if the elements are placed in a different order, the 2 lists are actually unique and different. And I can check that over here. I have created a list 1, 2, and 3, and say if I create another list 2 and 1 and 3, the same elements but in different order, I will use the is function to check whether these 2 lists are the same. And if they are the same, when I use the is function, it should give me the value or the answer true. And if they're not the same, it should give me the value false. And as you can see, I get the value false because even though I have 2 lists with the same elements, they are in different orders. And so they are different. And that's what we mean by lists are ordered. The next property for lists are that they can be manipulated using their indexes, or the elements and the objects inside a list can be manipulated using the indexes. And we will see that in the section where I show you list operations. The next property is lists are mutable. What this means is that once we create a list object, we can actually make changes and modify them without having to create a new list object. The next property is that lists are dynamic. And what this means is that as we are programming, we can actually make changes to an already created list as we are programming without having to go through a compilation stage. So if we had to say increase or we had to add certain elements to an already created list, that original list grows in size to accommodate for these new elements. The next property is that lists can contain any arbitrary objects. So if I created a list right now where, say, if I want to store some numbers, say some floating point numbers now, and I can put strings as well into my list. All of these are valid when it comes to objects that can be put inside a list. We have no such restrictions, so we can put any arbitrary objects inside our list. The final property that I want to talk about is that lists are they can be nested to any arbitrary depth. What this means is that I can put a list within a list, and I can keep nesting it essentially by putting as many lists I want within my list, and I'm only essentially restricted by my system's memory. So if I created a list like this, within this, say I put another list, and within this list I put another list, I can keep going on doing this, and I'm only restricted by the memory of my system that I'm using. So moving on, let's move on and talk about some important list operations that we will be doing when it comes to lists. So let's create a basic list called A, where I'm storing 6 numbers. So now say if I wanted to retrieve a particular element, say if I wanted to find out what's on the index 3, this is how I would do it. If I wanted a slice of my original list, and much like strings, I do it the same way. So what this does is, it tells Python that I want all the elements of list A from index 1 to index 4, but not including index 4. So it will give me 1, 2, and 3 index objects. So it should give me 2, 3, and 4 in this case. As you can see here, 2, 3, and 4. I can do the same thing by considering elements, say 2 at a time. If I wanted to consider elements or consider every second element, what I would do is this syntax. I would use this syntax. And when I give this command to Python, what it understands is I want every element from A, from index 1 to index 4, but not including index 4. But I am going to consider every second element essentially. So what it will do is it will go here, and then it will skip one, and then go here, and then skip one. And that's essentially what we call slicing by using strides. So I'm taking strides. I'm not considering elements consecutively, but I'm skipping certain elements in between. If I wanted to consider every third element, I would change this to 3. And fourth element, I would change this to 4. Alright. So let's see what happens when I take every second element. It should give me, it will consider, say, from 1 to index 3, right? So it should consider essentially this section. But since it's going to skip 1, it's going to consider this, skip this, and then consider this. It should give me 2 and 4. As you can see, it has given me 2 and 4. And like in other sequences, we can use negative indexes as well. Negative indexing essentially starts looking from the right hand side of the list. So when I say A minus 1, it's essentially looking at the last element of the list. So it gives me the sixth or the last element, which is the object 6. If I did A minus 2, it gives me the second last element. Similarly, another neat trick that we can use for sequences is the following syntax: double colon, and we give a minus 1. What this tells the system is I want the list A, but with all the elements reversed. So as you can see, I get my list A, but the elements have been reversed right now. Let's move on to concatenation and replication. Well, concatenation, much like in strings, is done by using the plus sign. So as we know, on either side of the plus sign should be two similar objects. So if I'm doing A plus something, A being a list, on the other side it should be a list as well. So let's add a list like this. Now let's see what's in A. As you can see, my original list has 7, 8, 9 added to it. And I can also add things to the beginning of a list similarly. So if I wanted to add, say, 0, at the beginning of a list, I just do it like this. And I get the element 0 added to it. It's very important to note that I actually added 0 within a list, because if I did 0 like this, it will throw me an error, because like this 0 is just an int object and it's not a list. But when I put the square brackets, I make it a list, and then this concatenation becomes valid because A is also a list. Similarly, if I did A star 2, this is essentially replication, or a replication function, where I'm repeating the values in A twice. If I did A star 3, it's the same function, but now I'll have the elements repeated thrice, as you can see here. Let's move on to modifying list values. This also shows the mutable property of lists that I had mentioned earlier. So let's consider this example. So I created a list with elements where there's the 3 strings: eggs, apples, and carrots, and I have 5 int objects, 1, 2, 3, 4, and 5. Now if I wanted to change, say, the first element, all I have to do is take the 0th index, and say if I want to replace eggs with say mango, this is how I would do it. Now I've replaced eggs with mango. If I check what's in B, you can see the eggs have been replaced with the element mango. Similarly, I can use the slice syntax to replace a particular slice from my list with a slice essentially. So let's look at this. I want to replace the first 3 elements. I want to replace mango, I want to replace apple, and carrot. So what I will do is, I will consider this, since this carrot is the second index, so I will consider 0 to 3 because the third is not counted. Now I'm going to replace this with 3 different, let's see, kiwi and say sponge. Now let's check what's in B. You can see my 3 elements have been replaced. In fact, I don't have to replace like for like. If I want to replace, say, 3 elements with only 1 or 2 elements, that is also possible. So now if I want to replace the first 3 elements, kiwi, orange, and sponge, with just 1 element, this is how I'll do it. Let's say wine. Now let's check what's here. As you can see, 3 elements have been replaced with 1 wine. I can do it vice versa as well. I can replace smaller number of elements with a larger number of elements. But here there is a slight caveat that I want to show you. So an obvious way of doing this would be, say if I wanted to replace the first element wine with 3 different elements, an obvious way would be just consider that element's index and then put whatever objects you want. say I want to add, instead of wine, I want to add beer, I want to add ball, and say club. Yeah. Well, let's see what happens. Now if I say B, check what's inside my... Now you can see my elements have been added, but they seem to have been added as is, you know. I had entered a list over here, and that whole list has been replaced, or this wine has been replaced by this whole list in the first position. But that's not exactly what I wanted. I wanted the elements within this list to be individually placed into my list. And the way to do that is not this syntax, but actually what I'm going to show you now. If I want to replace one, if I want to replace the index or the object at index 0, I would give this statement, a slice statement, where I will give 0:1. So when I do this, and if I, so let's create my old scenario again, where I had wine, and I had 1, 2, 3, 4, and 5. Now if I do this, B0, but I give a slice, then this slice is essentially a single object slice. It's essentially the 0th index again. But because of this formatting or this type of syntax that I'm using, what Python will do is, now when I say beer and ball and club, now what Python will do is, it will not consider this whole list and add it to in place of wine or whatever I want to replace. It will actually consider the elements inside of this individually and then replace. So if you see here, now if you see my list, I actually have the, I've removed wine, and in place of it I've put beer, ball, and club, but these three are actually individual objects within my list and not objects within a list that is then placed within my original list. So this is an important caveat that you should take note of. So moving on, let's talk about certain methods associated to lists. Let's take a simple list now, 1, 2, and 3. The first operation that I want to show you, or the first method, is the append method. So when I do a append, and say if I want to append the list by one object called 4, I just do it like this. Now let's see what's in A. So as you can see, the append has put the object 4 into my original list. Now say if I wanted to append 3 different objects, I want to append 5, 6, and 7 now. Let's see what append function does. Oh no, as you can see, it's done a similar operation to what we have seen earlier when we gave a single index or the single element replacement that we saw earlier. It essentially put this whole list into this particular spot into the list. And this is not what I wanted. I wanted 5, 6, and 7 to be individually placed. And we do have a way of doing that. And the way to do that is the extend function. That is what I'll show you next. Now, if I want to extend, say, the original list by 3 different elements, 8, 9, 10. When I use the extend function, it will not put this whole thing. It will consider each object inside this thing individually and then add it to A. So if you see my result, this is exactly what I wanted. Now, the next method that I want to discuss is the remove method. So the remove method is how you use it is within the parentheses, you put the object that is present in the list that you want removed. So you don't give an index over here, you give the object itself. So if I want the object 8, alright, this number, if I want 8 itself removed, what I will do is put the value 8 here and it will remove it from my list. So if I check my list A, as you can see, the value 8 has, it's gone. Another similar function to remove is the pop function. Now the pop function by default will remove the rightmost value from the list. But unlike remove, the pop function actually outputs a value and that value is what we have popped out of the list. So by default, it will pop out the rightmost value of a list or rightmost element of a list. And in this case, that element is 10. So it should give me 10. But of course, if we want to pop out any particular object, in this case, we do not give that particular object, we give its index. So now say if I want to remove this list object from my bigger list, as I can see, it's in index 0, 1, 2, 3, 4th. It's the 4th index. So if I want to remove the list which is at the 4th index, I give the index value inside the parenthesis and it pops that out for me, as you can see over here. So this was it for lists. Let's move on to tuples next. So tuples are another ordered collection of objects much like lists, but they differ from lists in two key properties. First of all, tuples are defined using parentheses instead of square brackets. So this is how I would define a tuple with elements 1, 2, and 3. And the next very important property that is different, or that differentiates tuples from lists, is that tuples are immutable. And what this means is that once we create an object of type tuple, we cannot make any modifications to it. We would have to only create a new object if we wanted something different. And this is obviously a key difference between a tuple and a list. But apart from this, every operation that we have done on lists are actually possible to do in the case of tuples as well. So any operation that we did to lists that did not modify the list, or that does not do any modification, we can actually apply to tuples as well. So if I wanted the first element of this tuple, all I have to do is call it by the index 0. It should give me the value 1, as you can see. If I wanted a slice, I can do that as well. It should give me 2 and 3. And if I wanted to reverse my tuple, well, I can use my same neat technique that I've used for lists and that I can use for strings as well. So it gives me my old tuple, but with the elements reversed. So now the natural question is, why do we use tuples over lists? Well, one important difference is that when we make a program execution where we are manipulating a tuple, if we did the same thing for the exact same objects in that if it were present in a list, it would be much faster in a tuple. Essentially, program execution is just faster on tuples when compared to an identical list. So you use tuples over lists when we want to be efficient while we are creating an ordered list of objects. So whenever we create an ordered list of objects that we don't need to, or we don't want to make any further modifications to, we don't need to create a list, we can create a tuple. And another very important area where we use tuples over lists, or why we need a tuple instead of a list, is when we are using dictionaries. Dictionaries, as we will see later, is a data type in Python that needs an immutable component while we are creating the dictionary. So if we want to use something that is like a list, but since lists are mutable, we can use a tuple instead and use that when we are creating our dictionary. And we will see like what I mean by the immutable component for a dictionary when we actually learn about dictionaries. But yeah, these are some of the places where we would use a tuple over a list. A brief section on tuple unpacking and packing is what I will be doing right now. And what that means is that when I give this sort of a statement, you can assume this to be me packing this tuple into a object or a variable t. Now what's very interesting is, and this is something that's very key to tuples, is that I can unpack a tuple onto another tuple. So let me show you what I mean by that. So now that I have packed 1, 2, 3, and 4 tuple into t, let's unpack it into another tuple. Let's call this, let's put these elements into this tuple, and I put this into t. Alright. Now let's see what I mean by unpacking something onto something. Let's see what happens when I put a. If I just want to see what's in a, it actually gives me the value 1. If I see what's in B, it gives me the value 2. If I see what's in 3, it gives me value 3, and D gives me value 4. So essentially, if you think of it, what I have done is I have matched this tuple, then put it into T, and then put that tuple T into this tuple A, B, and C, D. So what has happened essentially is the element A has been, or a better way to say this would be the element 1 has been packed onto or unpacked onto A. 2 has been unpacked onto B. 3 has been unpacked onto C. 4 has been unpacked onto D. To show you what I've done in a single line is essentially this. This is essentially what I've done. I have assigned 1 to A, 2 to B, 3 to C, 4 to D. I have matched these two tuples together like this. And this is a very neat feature of tuples. The only important thing that you have to keep in mind is the elements on this tuple and the elements on this tuple should be equal. So if there are 4 elements here, there should be 4 elements here. Alright. In fact, another very important thing about, or a neat feature, is that we don't really need to mention the parentheses when we're doing this unpacking or packing. So if I did X, Y, Z, if I did it like this, if I put say 5 and 6 and 7, this is also a valid way of packing and unpacking. So now if I see what's the value in X, it is actually 5. If I see what's the value in Y, it is 6. If I see what is the value of X and Z, it should give me a tuple containing 5 and 7, as you can see over here. So this is a neat feature of tuples called packing and unpacking. In this video, we will cover concepts surrounding dictionaries. Dictionaries are another type of composite data type in Python that are also a collection of objects, much like tuples and lists. And like lists, they are also mutable, dynamic, and can be nested. However, a key difference and property of dictionaries is that they are unordered. Items in dictionaries are paired using keys, unlike in lists and tuples where the objects are assigned numerical indexes. To define a dictionary, we use curly braces. Each key value pair in this dictionary in a dictionary is separated using commas, and the key and values themselves in a pair are separated using a colon. Let's look at an example. This is a dictionary where I have 3 key value pairs. As you can see, they have been separated by colons, and each pair themselves are separated by commas, and these are enclosed in curly braces to define the whole dictionary. In this example, these are the keys: banana, apple, and grape, and their respective values are yellow, red, and green. So this is very important, that in this particular data type, we have what we call a key, and that key is assigned a value, and we can have multiple such pairings, and we have 3 such pairs in this particular example. Another example, or another type of way to define a dictionary is using the dict function. This is how we use it. As you can see, I have inputted 2 value or 2 object tuples. This is a tuple, this is a tuple, and this is a tuple. And when I use it in a dict function, when I place it within a list, what Python will do is it will consider the first element of each tuple as a key and the second element of each tuple as its respective value. Now if I check what's in D, as you can see, the key banana has a value yellow, the key apple has a value red, the key grape has a value green. So this is another way of defining dictionaries. An important note over here is that the objects that we use for keys have to be of an immutable data type. So we cannot use, for example, lists as an example of keys, but we can use, say, integers or strings for our dictionary keys. Also, keys have to be unique when it comes to a dictionary. You cannot have 2 different keys with, or should I say, the same key having 2 different values. You can have only one key, and that one key will have a unique value assigned to it. Duplicate keys are not allowed. However, when we speak about values, we have no such restrictions. You can have a mutable or an immutable data type as a value in a dictionary, and you can have duplicates as well. So, if I created a dictionary with a key, say, banana, and if I associated with it a value green, I cannot create another key banana and associate a value yellow. Let's see what happens when I actually do this. If you actually see, what has happened here is Python has considered the second case. So it first looks at the first pair, it goes, okay, so my dictionary has a key banana with a value green. But right after it, it sees another key banana with a value yellow. So it overwrites my first key banana with the second key, and it overwrites the first value green with the second value. And we essentially get one key banana with the second value yellow. So obviously, this is Python does this to avoid duplicacies. However, if I created a dictionary with a key banana again, if I gave it a value yellow or say green, and if I created another key, and if I gave this also a value green, this is perfectly fine, and this will nothing special will happen in this case because values do not have to follow such rules. Let's see certain dictionary operations and functions now. So let's bring back our original dictionary, which we had created earlier with the 3 pairs. Alright. So what if I wanted to, we can use keys to essentially do these operations and functions. Let's see what happens when we So much like how we use indexes in example of sequences, we use keys when it comes to dictionary. So let's see what happens when we use a key over here. So as we know, banana is a key in this dictionary. Let's see what happens when we give this command. It actually gives the value associated with that key, which is yellow. What if we wanted to change a particular value associated to a particular key? I would do this. I would give the key and assign it the value that I want to change it with. Alright. Now if I check my dictionary, you can see the key banana no more has yellow value, but the value gold. What if I wanted to add a new pair? A new key with a new value completely. I would do it pretty much the same way as I did in the previous step. I would essentially write my new key, whatever I wanted. Say if I wanted a new key called watermelon, I would assign it a value red. And now if I check my dictionary, at the end of the dictionary, you will see that my new key value pair has been added, watermelon red, as you can see over here. Now what if I wanted to remove a key value pair from my dictionary? I can use the delete function, which is called by using the del function. Now how do I do it? Say if I want to remove the key value apple and red. So all I have to do is do del, d, and within square brackets, I have to only mention the key. I don't even need to mention the value, just the key. So you can probably draw parallels in how we use indexes when it comes to lists and tuples and even strings, and how we use keys when it comes to dictionaries. They are quite similar. So if I did this, and if I, I think red is actually not a key. As you can see, red is a value. My key is apple actually. It's not red, it's apple, as you can see. Now if I see my dictionary, the key apple and its value red has been removed. So these are some of the operations that we can do for dictionaries using keys. What if we wanted to use certain inbuilt functions that are associated with dictionaries? Well, some of the examples are as follows. There is a get function. When we use the get function, all we have to do is enter a key inside the parenthesis, and it will get the value associated with that key. So if I gave the key grape, let's see what value is associated with it. As you can see, it's green. There is also a function called items that returns the key and value pairs in our dictionary as a list of two object tuples, where the first object is the key and the second object is a tuple. So let's see what it does. As you can see, it gave me a list, and in this list the objects inside the list are two object tuples, where the first object is always the key and the second is the value, and it's the same for each of the tuples. So this is what items function does. Let's see what the next function is keys. Let's see what the keys function does. As you can see, it returns a list of all the unique keys within our list, within our dictionary. Similarly, there is a function for values as well, and as you can see, it returns all of the different values that are present in our dictionary in the form of a list. Also, it's important to note that if we have a particular value that has occurred multiple times in a dictionary, it will appear as many times it has occurred in the dictionary or appeared in the dictionary in our list over here when we use the value function. So if, say, a particular value, say I had another key where its value was green again, so I would have the value green appear in this list once more, essentially. Our next function is pop item. What this does is, much like the pop function in lists, it gives us the last entered key value pair that is present in our dictionary. So the last entered pair was watermelon, key watermelon with the value red, and that's what has popped out when we give this function. Another important function associated with dictionaries is the update function. And the update function is a very neat function that is used to merge two dictionaries together. So say if I had a dictionary, let's say I'm creating a dictionary using the dict function where I have, say, some key called kiwi. So as I had mentioned, I will use two object tuples in this case, and let's say I give this also a value green. All right, and another pair would be, say, mango, and let's give it a value yellow. All right, so this is another dictionary that we have created. As you can see over here, we have created a dictionary with a key called kiwi with value green and another key mango with a value yellow. And I already have a dictionary D with these values. All right, now if I want to merge these two dictionaries, I can use the update function. What I do is, say if I want to merge D with X or X with D, only the ordering will change, and that doesn't really matter when it comes to dictionaries. So if I want to merge D with X, I use D update, and then inside it I put my target dictionary. Now when I check what's in D, I have the dictionary X and its key value pairs merged inside my original dictionary D. As you can see, I have my original ones here and I have the merged ones over here. So this was the update function. In this brief video, I will explain what we call the type hierarchy or the standard type hierarchy in Python. It's also known as the data model in Python, and it probably has other names. So essentially what we do or what we speak about in this is how the different types that we use in Python are categorized and classified and what are their subtypes. So it's important to note before we continue further that in future versions of Python, there might be new types that are introduced or the existing ones may be modified. But it's safe to say that what I will speak about in this video will still form the core of what we call Python standard type hierarchy. So let's begin. So the first type is the none type. It's accessed through the built-in name none. Its truth value is false. It's essentially used to denote functions, or it's returned as the value for functions that don't really return anything. So if you have an expression or a function that returns no particular value, you actually get a data type called none. That is how Python interprets it. Then there is the ellipses. Ellipses is something that you might encounter later. It is accessed through the built-in name ellipses. It is used to indicate the presence of this particular syntax, this particular symbol or expression or syntax in a slice. Its truth value is true. Again, don't worry too much about ellipses right now. Next is numbers. And numbers is something that we are very familiar with. We've worked with numbers a lot. They are an immutable type. They are created through numeric literals, and they are the outputs of arithmetic expressions and built-in arithmetic functions. Its subtypes are integers, floating point numbers, and complex numbers. Within integers, you have plain integers that represent numbers in the range this number and this number. So this number is basically the largest positive value that you can represent using 32-bit notation in 2's complement, and this is the equivalent for the negative side. Long integers, on the other hand, are used to represent numbers in an unlimited range that is only subject to the available memory of your system. So these are two types of integers, and as we know, floating point numbers represent machine level double precision floating point numbers, or numbers with a decimal point and a component after that. Complex numbers are numbers that contain a floating point number that represents a real part and a floating point number that represents an imaginary part. So these are the types of numbers. Then we have sequences. Sequences are finite ordered sets indexed by natural numbers. So each element in a sequence has an index, and that index is a natural number. The different types of sequences are based on the mutability, whether the objects can be changed or not, is essentially what we mean by mutability, right? Once we create an object, whether we can modify it or not. That is how we differentiate different types of sequences. So there are mutable and there are immutable types. Now, the different types of immutable ones are strings. We know what strings are. They are sequences that contain characters. Unicode is the other immutable sequence, and then there are tuples. Tuples are a collection of arbitrary Python objects, and unicodes are sequences that contain Unicode characters. Then we have mutable sequences, and there is only one. Currently, there is only one built-in mutable sequence in Python, and that is lists. Lists are also, again, collection of arbitrary Python objects. Finally, we have, well, not finally, but next we have mappings. And mappings are, again, sets of objects, but these objects are now indexed using arbitrary index sets. You know, the difference between a mapping and a sequence, you could consider sequences are ordered, but mappings are not ordered, and the indexes given to the objects in sequences are always numbers. They're natural numbers, whereas in mappings, they are not natural numbers, but they are certain arbitrary objects that we can set for ourselves. Again, in Python, there is only one built-in standard mapping type, that is the dictionary. Dictionaries are they represent finite sets of objects indexed by nearly arbitrary values. The only condition is that these indexes must be of an immutable data type. So these, so what I have mentioned until now are probably the most common data types that we encounter, or that we have encountered now. So next types are like callable types, such as user-defined functions, user-defined methods, built-in functions, built-in methods, classes, and class instances. So again, callable types as a whole are referenced using the call function, and this is something that we will learn when we start learning about functions, when we learn about object-oriented programming, and methods and functions and such. The other type are modules. So modules are module objects, or modules essentially are referenced or called using the import function. Again, modules can be considered as these large libraries or larger pieces of code or applications that we that contain various different methods and functions and objects and classes within them. Again, modules are something that we will think about a little later. Files are data types that are called using the open function. So anytime we, and as we will during the course of this tutorial, during the course of this course essentially, we will be working with a lot of files. Some of these files are text files, some of them are comma separated files. So all of these files that we open using the function open or some other certain specific functions, where we create file objects out of these files. These are what we call file data types. Finally, there are internal types that are used by Python interpreter. Again, this is something that does not concern us right now, but just know that the interpreter for Python uses these data types for its functioning. In this video, I will show you some of the categories of operations that are possible in Python. So let's start off. So the first category of operations are arithmetic operations. And as you can see in this table, there are different types such as addition, subtraction, multiplication. So let's go over them one by one. So a simple addition operation would be like 5 plus 6, giving me the value 11. I can do 5 minus 3, that's subtraction. Similarly, I can do a multiplication using 5, say 5 into 2. There's division where I use the backslash. So say I did division of 8 divided by 2. Now you might encounter another type of division, which is called the floor division, where we use a double backslash. And what this does is it returns us the largest whole number that is lesser than the result of our division. So the difference between the float division and the normal floored and the floor division, or the single and the double backslash, is this. Say I did 9 divided by 2 using a single backslash. It should give me, as you can see, 4.5, right? So this is the actual value. Now let's see what happens when I do 9 double backslash 2. It will give me 4, which is the largest number lesser than or equal to 4.5. That is also a whole number. So this is what we call floor division essentially. Finally, we also have, if we want to raise something to the power of something. So if I want to do say 6 raised to the power 3, so I would use double asterisk, and this is how I would do it. It will give me 216, as you can see. If I wanted remainder between the division between two different numbers, I will use the percentage sign. So if I wanted the remainder of the division between 7 and 3, this is how I would do it. I get the answer 1, as you can see. So the next category of operations are logical operations. The first one is the logical AND operation, where we use the operator AND. Alright, so let's see what we mean by this. So as we know, the AND operation returns the value true if both the operands are true. So let's actually do this for an example. Let's give this variable the value true and this the value false. Actually, it should be done like this, true, false. So now think of it like 1 and 0. So 1 and 0 is obviously 0, right? So if I did A and B, I should get the answer false or 0, because I'm doing true and false. So it's like doing 1 and 0. So if you see this, I should get the answer false. If I change this to true as well, now if I do this, I will get the answer true, as you can see. The next logical operation is the OR operation, where, logical OR is if either of the operands are true, then we should get the answer to our OR operation as true as well. So in this case, obviously, if I did OR over here, it will naturally give us true. If I change this to false, it should again give us true, and it will only give us false if both are false, as you can see here. Now it's false. The next operation is the logical NOT. It's done by using the NOT operator. So in this case, the value that we get is true if the operand is false. So let's take A. As we know, A is false over here. So if I did not A, I should get the answer true. But if I change this to true, now if I do not A, I should get false, as you can see. So this was the logical operations. Let's move on to the next set of operations, that is comparison operations. So there are a bunch of them. Let's go over them one by one. If I want to check if two operands are equal, so if I did x is say equal to 2 and now y is equal to 3. If I want to check if they are equal, I will use the double equals to sign. And if they are equal, I will get the value true. If they aren't, I'll get value false, as you can see, since x is 2 and y is 3. As you can see, x and y are not the same, so there's false. They are not equal. If I change this also to 2, now I will get the answer 2. The next comparison is the not equal to, or where we use the exclamation sign. So over here, the result of this is true if x and y are not actually the same. So I should get false over here, as you can see. But if I change this to say 5, now I will get true because x is not equal to y in this case. The next one is greater than. So if I did x greater than y, as we can see 2 is not greater than 5, I will get false over here. Similarly, there's a lesser than. If I did x lesser than y, I should get true over here, as you can see. Well, there's also a greater than or equal to and lesser than or equal to. We simply add the equal to sign here. So let's see. Now if I say x is lesser than or equal to 3, I should get true because x is 2. And if I put 2 here, I should also get true. But what if I put 1 here? Since x is equal to 2 and 2 is not lesser than or equal to 1, this is a false statement. And I can do the same thing with like this, using the greater than equal to. Now it's true because 2 is actually greater than equal to 1. And so this was comparison operations. The next set of operations that we can do in Python are assignment operations. We've already seen a whole bunch. We've already been assigning values to variables. We've been doing assignments throughout already, but let's go over them and see some of the assignment operations. So as we already know, the equal to operation is assigning everything that is on the value on the right hand side of the equal to sign to what is on the left. So if I did a is equal to 5 plus 6, it will assign the value 5 plus 6 or 11 to a. Let's check what's in a. As you can see, it is 11. There is a plus equal to sign, and what this does is, so for example, if I did say a, now since a is 11, let's create another variable called b and call this 5. Alright. So now if I did a plus equal to b, what this will do is it will add b to a and then store it in a. So let's see what this does. Once I do this, now let's check what's in a. It should be 5 plus 11. As you can see, 16. So this a plus, so this plus equal to sign is essentially the same as doing a is equal to a plus b. It's essentially the same thing. They're both the same. There's a similar thing for this, the negative or subtraction as well. Minus equal to. So now that a is 16 and b is still 5, of course, if I did minus equal to b, now I'm subtracting the value 5 from 16. So I should get a is equal to 11 again, as you can see here. And this is the equivalent of doing a minus b. A is equal to a minus b, I mean, as you can see. So the next similar like assignment operation, let's create a is equal to say 6 in this case, and say b is equal to, I will say 2. Alright. Now if I do a star equal to b, what this does is it multiplies b to a and then assigns it back to a. So if I see what's in A now, it should be 12, as you can see here. Similarly, there is similar thing for subtraction as well. So if I did A is equal to 6 and B is equal to 2, if I did for division. So if I did a division symbol and the equal to sign, and then if I give B, what it will do is it will divide A by B, or 6 by 2, and it will assign that back to A. So my value in A should be 3, as you can see here, 3.0. Obviously, this is a single backslash, so this is a float division. The resultant of a single backslash is always a float. I can do the same thing with a double backslash. So let's see, if I did A is equal to 7 now, and then B is equal to 3. Now, if I did a double backslash equal to B, now it will do the same division, but it will do a float function. So it should give me 2 in this case. If I did the same thing with a single backslash, just to show you the difference between single backslash and double backslash division, in this case it will give me the value around 2.3 or something, a float basically, 2.33, as you can see here. Then there is the modulus. You can use the modulus sign as well with this assignment. Say A is equal to, say, 5 now, B is equal to 2. Now if I do a percentage symbol equal to 2, B, it should give me, it will assign the, it will take the modulus in both sides and then assign it to the left hand operand. Now let's see what's in A. As you can see, it did A divided by 2. The modulus symbol is basically the remainder of the division between two objects. So in this case, it will divide A by B and then give me the remainder and then put that remainder back in A. And as you can see, that the remainder of 5 divided by 2 is 1, and we get that over here. Similarly, we can also do exponential. So if I have A is equal to, say, 5, B is equal to 2, and I want to raise A by, if I want to raise the value of A by the value of B, and then store that back in A, this is how I would do it. So it should be 5 to the power 2, which is 25, as you can see here. So this is assignment operations. So finally, we move on to two special sets of operators. One is the identity set, identity operators, and the other is the membership operators. Let's look at the identity operators. So when we talk about identity operators, what we mean is the is and the is not operator. So what the is operator does is it checks whether two operands have the same location in the memory, essentially. This does not mean that it does not check for whether two objects have the same value, and this is very important. So let's look at this. If A is equal to 1001 and B is equal to 1000 plus 1, alright? If I did A is equal to 2, this is an equality check. Are they the same values? True. Now if I say A is B, let's see what happens. As you can see, it's false. This is because this object and this object are not the same, and this is what the is operation does. We can confirm this by checking the ID of A. The ID of A gives us some value like this, and the ID of B gives us, as you can see, a different value. So the two objects are not located in the same place in the memory, as we have seen using the ID function, and that is what we check through the is operator. And the is not is essentially just the opposite of that. So that is the identity operator. Now the membership operator is used for checking whether something is present in a sequence or not. So let's create a sequence. I will create a list to show in this example. My list is 1, 2, and 3. Basically simple list with 3 integer objects, 1, 2, and 3. I will check whether, now say 2 in A. So is 2 in A? If it is, it will give me true, as you can see. Is 5 in A? It should give me false because 5 is not in A. And the not in operator is just the opposite of that. It checks the other condition essentially. So this is the membership operators in Python. In this video, we will be looking at the math module in Python, and we will look at some of the math functions that are associated with this module in Python. So starting off, what is this math module? Well, the Python math module is an important library or a feature that is designed to deal with mathematical operations. This math module is part of the basic Python installation, so you don't have to install this separately. To use this math module, all you have to do is import this module, and this is how you would do it. You just do import math, and this will import your math module for you to use in your programming. And in the course of this video, I will be showing you certain concepts surrounding the math module, such as what are the constants that come with the math module, some of the arithmetic functions, the logarithmic functions, power functions, and even trigonometric functions that we can do using this math module and the functions inside the math module. So starting off, let's look at some of the constants that are part of this. So as you can see, the standard constants that are available in this module are pi, there is tau, there is Euler's number, NaN, which is a special, it's a programming specific concept, and infinity. So let's look at these one by one. So starting off, our first constant is pi. Pi is, as you know in maths, it's the ratio of a circle's circumference to its diameter, and pi is an irrational number. You know the value of pi is 3.14 something. Since it's an irrational number, we cannot define it in terms of a specific fraction, but it can be approximated to the fraction 22/7. So how do we access this? Pi constant is as simple as this. Once you have imported maths, the maths module, all you have to do is do maths.py, and it will give you the value, as you can see. So as you can see, the value returned to us is a float. This is important to note. And the number of decimal digits, the number of digits after the decimal point that we can see here are 15. And this is like a by default thing for Python, that if you call the pi constant, it will give you the value of pi correct up to 15 decimal points. So an example of where we can use this thing is, say, we have the radius of a circle, 3. It can be in any units, 3 meters or whatever you want. And you want to find out its, say, circumference. So as we know, the circumference of a circle is 2 pi r. So if I had to find the circumference of a circle in my code for some application with the radius 3, all I would have to do is use the formula 2 pi r. And to call the value 2 pi r, instead of specifically writing 3.14 something, I can just use this function math.py over here, and then I can enter the r. As you can see, it will return me the radius, as you can see. So moving on, the next constant that we will talk about is tau. Tau is similar to pi. In fact, tau is the ratio of a circle's circumference to its radius. Pi is the ratio of a circle's circumference to its diameter, and tau is the ratio of a circle's circumference to its radius. It's important to note this difference. So because of this definition, tau is always 2 times the value of pi. This is by definition. And much like pi, if you call the tau constant from the math module, it will also return you a float number. And to find that, this is the function that we use, or this is the syntax. So as you can see, this is actually 2 times the value of pi, 6.283, and even this is returned correct up to 15 places to the right of the decimal point, and this is by default. Next constant is the Euler's number. The Euler's number is it's one of the most widespread constants used in the world of in the scientific community, in the mathematical community. You will be using the Euler's number probably a lot as if you move into data science or AI or something like that. So what is the Euler's number? It is the base of the natural logarithm. If you know what the natural logarithm is, it is used to calculate rates of growth or rates of decay. And as with numbers or constants like pi and tau, even the Euler's number is an irrational number with infinite decimal places. The value of the Euler's number, in short, it's denoted by the small letter e. So this value of e is usually approximated to around 2.718. So how do we call this constant? Is simply as math.e. This is how we do it. So you get this value. Again, this is also a float, and it's correct up to 15 decimal places. So the next concept that we will be talking about is infinity. Now infinity it's more of a mathematical concept, and this is very important to note because infinity is not really a number. There is no number called infinity. It is used to define something that is infinitely large or infinitely small. So positive infinity is something that is higher than any known number to us, and negative infinity is lower than any known number to us. So this is the concept of infinity. And how do we call this function? Well, let's see what happens when we call the math function, math constant infinity. So this is how we do it. And as you can see, it will return us this, it might look like a string to you, but this is actually a special type in Python, which is not a string. This is also a float. It's a type of a float. In fact, this infinity value, it's like a special data type. It's a special data type that you can consider as an equivalent to a float, but it's not a typical float that we know, like 3.14 or 2.71. The value of math.inf will give us INF, and this INF is actually not a string, so we can confirm that over here. As you can see, when I check the type, you see it's actually a float. In fact, this was recently added in Python 3.5, a special type known as math.inf. It returns this INF data type, which is the equivalent to a float. So this is how we use infinity. If you wanted to get the value of, say, minus infinity, all you would have to do is math.inf with a minus sign preceding this constant, and you will get minus INF. Now let's check if the concepts or the properties of infinity are maintained. Like a positive infinity is greater than any number that we know, and negative infinity is greater than any number that we know. So let's just confirm this. So I'll take math.inf and I will do a check. Is this greater than, say, some really large number? Something that comes off the top of my head immediately. Okay. So let's see if this is true, then this is conceptually correct. And as you can see, it is true. In fact, I can change this number to anything as large as I want. This will be true because infinity is larger than any number that we know. And similarly, if I did minus math.inf, and I checked some very small number, a very, very small negative number. So just consider some minus 10 to the power something, right? This should also be true. Sorry. It should be smaller sign symbol. This should also be true because I'm checking minus infinity. It's smaller than any known number to us, and it is true, as you can see. So it's very also if you did something like, so let's say if we do let's add something to this. It's a number, so we should be able to do arithmetic on this. Let's actually see what happens when I add, say, 10 to positive infinity. It actually gives us the same value back, infinity, because intuitively we know that infinity plus anything is still going to be infinity, right? And this is exactly what Python does for us. Even if we add a number to this math.inf or the infinity constant in Python, it will still give us the same value, the same data type of INF or infinity. Similarly, if we subtracted something from the negative of math.inf, let's say minus 100. So if we subtract something from minus infinity, we're technically still minus infinity itself. So this will again give us minus INF, as you can see, and this is absolutely what we need, and this is a very, very interesting feature in Python. Finally, the last constant that we will discuss is the NaN, or the not a number constant. So this is not really a mathematical constant. There is no constant in maths called not a number. This is a computer science related concept that it's used to denote invalid inputs, or it's used to indicate certain places where, say, a variable that should have a number it's been corrupted for whatever reason, and it now has a text or a symbol, and our code throws an error. Then in these cases where Python expects a number from us or from your code and it does not get it, it will throw you a NaN value, and this is usually used in cases where you have errors in your code. So again, just to check like what this constant, how to call it, this is how you actually do it, math.nan, and it will give you a data type called nan. Also, much like the infinity constant, let's see what's the type of this constant. Again, it might look like a string to you, but of course this is not a string. This is a numerical concept, and as you can see, it's still a float. So this is like it's another special data type that was created for specifically this case, where it's the equivalent of a float, but it's not really the typical float that we associate with. So this was constants in the math module. So our next topic will be arithmetic functions that we can do in the using the math module. So some of the common arithmetic functions that are available to us are factorials, the ceiling operation, floor operation, there's permutations, there's combinations. You can find the greatest common divisor, or the GCD, and the LCM, or the least common multiple, and you can truncate numbers. So let's look at them one by one. So starting off with the factorial operation. The factorial operation is done using the factorial function, as you can see here. Actually, it's defined like this, math.factorial. Alright, so now what we pass in between the parentheses will be what we calculate the factorial for. As you know, factorial is always for a positive integer, and the factorial for, say, a number 10 would mean 10 times 9 times 8 times 7, so on until the number 1. Obviously, factorial is only defined for positive integers. It is not defined for negative values, or it's also not defined for decimal values. So let's look at an example. So as we know, so let's say we pass maths.factorial for 6, and let's see what's the value. So this is exactly what we expect. So we expect the value of 6 times 5 times 4 times 3 times 2, that is actually 720. Let's see what happens when we pass 0. This should give us 1, since we know 0 factorial is 1. Now let's see an error case where we pass, say, minus 5. As you can see, this will throw us an error because factorials are not defined for negative numbers. Now moving on, so the next function that we'll talk about is the ceiling function. So the ceiling function is defined using math.ceil as you see here. So again, we pass the number that we want the ceiling for in between the parentheses. So what is the ceiling function? It gives you the it gives you the smallest number that is greater than or equal to what we pass over here. So for an example, if I gave you 6.6 and I asked you, okay, what is the ceiling function for 6.6? It should give you 7, because 7 is the largest integral value that is greater than 6.6 or equal to it. Obviously, if you give the ceiling function for an integer, it will give you the integer itself. So let's look at an example, 7.8. So this should give me the value 8, as you can see here. Let's look at another negative number. So minus 12.3. An integer that is greater than minus 12.3 is minus 12. The smallest integer that is greater than minus 12.3. And this should give you 12, as you can, minus 12, as you can see here. A similar function is the floor function, which is defined like this. Again, the floor function, what it does, it gives you the greatest number that is smaller than whatever value we pass between the parentheses. So if I gave it 2.3, it should give me the value 2. Again, if we pass integers, it will just give us the integer itself. Again, just to reiterate, this ceiling and floor functions, they give you integer values. So the floor function will give you the largest integer that is smaller than what we pass over here. So let's look at 6.7. So the largest integer that is smaller than 6.7 is 6. And as you can see, this is our answer over here. The next function that we will look at is the truncate function. The truncate function is defined using this. Truncate is very similar to what we have seen. This is how we define the truncate function. It is very similar to the ceiling and floor. In the truncate function, what we do is we pass a decimal value, a float number, to the between the parentheses, and what we get back is the number without the decimal component. So only the integral component. So if I gave it 7.8, for example, it will give me only the 7 part. It will return me only the 7 part, and it will chop away the 0.8 part. If I gave it minus 12.3, it will chop away the 0.3 part and give me only minus 12 back. So let's look at an example. 8.9. It should give me only 8, as you can see here. Say I did minus 8 or minus 6.9. It should give me minus 6. So you can think of truncate function as it does the floor function for positive values and it does the ceiling function for negative values, because it rounds down and rounds up respectively for positive and negative values. So now let's look at the next set of arithmetic functions. Let's move on to permutations. Permutations are defined using this. As you know, so in between the parentheses, I have to pass two values, n and k. So I have to pass an n and a k. The k has to be lesser than or equal to n, because the permutation, as you know, is the number of ways in which we can permute from n objects, k different objects. So what this is permutation of n and k is n factorial divided by n minus k factorial. So if I pass, say, 10 and 6, it will give me the permutation of 10 and 6. So let's look at what's the value. As you can see, it's this very large value, 151,200. Similarly, there is a combination function, and this is combinations and permutations are used a lot in probability. So if you're going to move into that sphere, which you will encounter a lot in machine learning AI, you will be using these functions quite a bit. So the combination function, again, you pass an n and a k. Again, the n should be greater than or equal to this k. What this evaluates is n factorial divided by n minus k factorial times k factorial. So again, this is a mathematical concept. So let's look at the the combination of 10 and 6. So as you can see, it gives me 210, which is the combination of 10 and 6. In the arithmetic function section, are GCD and LCM. As we know, GCD is the greatest common divisor, LCM is least common multiple. So as of the newest version of Python, in Python 3.9, the math module gets these two new functions that were very lately added, actually. Since I cannot show you that because I don't have the absolute latest version of Python on my system, but using the math.gcd function, this is the function, and in between this, what we would do if we had the latest version is we would pass two numbers, or as many numbers in fact, and what this function would do is find the common divisor amongst them. So if I gave these, say for example, if I gave these numbers, it would give me the value 10. Similarly, the LCM function, again added in Python 3.9, finds the common multiple amongst whatever we pass over here. So if I passed, say, 20 and 30, this will give me the value of 60, which is the LCM of 20 and 30. So again, these are it's something neat that if say you have Python 3.9 or if you have Python 3.9 or after that, you will have access to these functions as well if you when you import the math module. So that was for the arithmetic functions. Let's move on to the next section, which are power and logarithmic functions. So let's start off with the power function. There are multiple ways you can actually do a power function in Python. So you can do something like this, which is the equivalent of 2 to the power 3, or you can use the inbuilt module math, and you can use the POW or the power function, this is how you do it. And if I had to do same 2 to the power 3, I would just pass 2 and 3 as arguments like this, and it should give me the value, as you can see, 8 over here. What if so there's actually one more function, which is simply the POW function, and this is not part of the math module. It's a function not part of the math module, but it's still part of the base Python. You can use this as well, and you can do the same thing. POW 2 and 3, it should give you the value 8 again. Now you might ask, what's the difference between these two functions? Well, it's not much. For at least in a beginner standpoint, it's not that much. Just note that the math.power function is slightly computationally faster than the simple power function. So yeah, moving on, the next topic would be the next function that we'll discuss is the exponential function, which is defined like this. Again, exponential function is again e to the power something. So if I did exponential of 3, this would give me e to the power 3. So as you can see, oh, of course, I did not define the module beforehand. So math.exp, now when I do this, it'll give me some value, which is basically Euler's number or e to the power 3. So this was the exponential function, and let's look at an example. So we will look at the example of rate of decay, and we will use the this function in that example. So the exponential rate of decay is used to calculate the amount of radioactive elements that is present in a substance after a certain amount of time. So the expression is something like the initial amount of radioactive elements that were present right at the beginning times the exponent of minus 693 times t for time divided by the time period, the half-life time. So let's just write it down to make it simple. So again, as you can see, so this will give me the remaining amount of radioactive elements, right? So let's write down remaining. Let's assign this to a variable remaining. So the initial, again, initial is the initial amount of radioactive elements. So let's give it some value, say 100. The time, let's assume it's 10 years. And let's say the half-life is around, I don't know, let's give some value, say 3 or something. Again, this is, the details are not important. So this will, I'm using the math.exponential function over here, as you can see. And for these values, now when I check what's the value of remaining after I calculated it, it's something. So it's basically what this tells me is that I started off with 100 units of some radioactive element. And in 10 years, this is what is left. So yeah, so this is how we would use, say, the exponential function in a particular example of ours. So next type of again functions are logarithmic functions. So let's look at some of the logarithmic functions that are part of the math module. So a basic log function would be written like this: math.log. In between this, I would pass the number that I want the log for. By default, if I just pass one number, it will calculate the log of 8 to the base of e. As we know, e is the Euler's number. So let's see what it does in this case. It gives me some value. What if I wanted to specify a particular base? Well, I would pass a second argument in this case. I want to find the log of 8 to the base 2, and this should be the value 3, as you can see over here. There are two specific functions that are also provided in this math module, that is log2. What this will do is again I have to just pass one argument, and this will automatically find the value of the log of 8 to the base 2, as you can see here. Similarly, there is a math.log10 function. If I did this, I will find the value of something here to the base 10, as you can see. So this was logarithmic functions. Then finally you have the square root function. So how would we use the square root function is math.sqrt. Again, we pass what we want over here. If we want the square root of, say, 49, this should give me the value 7, as you can see. Finally, we move on to the final set of functions that we can do using this math module. They are trigonometric functions and they are hyperbolic functions. So let's start off with some of the trigonometric functions. As we know, we can do sine, we can do cosine and tan, some of the basic functions. The way we would do it is math.sine. In between this, this is to calculate the sine of a particular angle. And this angle must be passed in radians. This is very important to note. We do not pass it in degrees, but in radians. So if I say passed sine of 3.14, as we know 3.14 is an approximation of the value pi. Sine pi is supposed to be, in fact, it's supposed to be 0. So let's see. We get something close to 0. Again, since this is an approximation, it won't give us the exact value. Similarly, we can use math.cos to find the value of a particular angle. If you want to find the value of the cos of a particular angle, we can use the tan function in case we wanted to find the tan. Similarly, we have the next set for arc sine and the arc cosines of angles. So to find the arc sine, for example, we would use a sine. For arc cosine, we would use this. And for arctan, we would use this. The next set would be hyperbolic functions. Again, hyperbolic functions are basically the sine and the cosine and the tan calculated not circles but on hyperbolas. Again, the details you don't have to know the details. You should know that if you wanted to say, for example, find out the hyperbolic sine of an angle, we would use math.sine h, and we would pass what we want in between this. Similarly, if we wanted to find the cosine, it would be cos h, tan, it would be tan h. And if we wanted to find the inverse of the hyperbolic inverse, what we would do is use a. So we would use a tan h. If we wanted to find the hyperbolic inverse of sine, we would use a sin h. And similarly for cos, it would be a cos h. In this video, we will learn about conditional statements. And we will learn about how do we create these control structures where we have these conditional statements. We will learn about the keywords that we use in Python to create a conditional statement block, the if keyword, the elif keyword, and the else keyword. We will also learn about indentation and its importance in Python. So let's get started. So the basic syntax, if you will, for a if statement in Python consists of the keyword if, followed by an expression, as you can see from this pictorial. There's an if statement, there is a expression, there is this block of code, which if you can actually see is slightly indented to the rest of the code. And then we have the rest of our code after that. So what we're looking at is this. So this is our if statement block. Now let's break this down. So what is this expression that we're speaking of? An expression in this context is a Boolean expression which evaluates to a true or false statement. So when we are speaking about the if statement, we have an expression, and if this expression evaluates to true, then we execute everything below the if statement. Otherwise, we skip that portion. As you can see, if this statement is true, we execute this statement or these statement blocks. Otherwise, if it's false, we move on to the next statement block or the beginning of a new statement. So let's look at an example to further understand this. Let's take this if statement over here. As you can see, in this if statement, I have this expression 50 greater than 30. So what Python is going to do now is it's going to check whether 50 is greater than 30, and it's going to check it in a Boolean context. If this is true, then we can move on to the next portion, which is this. But if it is false, then we will skip this. So let's see what happens over here. So since we know that 50 is indeed greater than 30, this is a true expression, we move on to this block of code, which is saying that print 50 is indeed a larger number than 30. So let's see if this actually gets printed. So as you can see, we get this, the result, which is, this is a true statement, and we get our print statement getting executed. What if we gave a false expression over here? So let's look at what happens if I gave a false expression. Now I'm checking if 50 is lesser than 30, which is a false statement. So if it's a false statement, we do not move on to this portion of our if statement block, and we directly skip. So if I have to execute this, you will see nothing gets executed. And in fact, my print statement is just not executed because we never entered this, because our expression over here was indeed false. So yeah, this is how a basic if statement block looks like in Python, and this is how how we move on to how we check for the truthfulness or the falseness of a particular expression in the if statement. So moving on, let's move on to the topic of indentation in Python. So as you can see, this if statement is an example of a control structure. So without defining what a control structure is in detail, control structures consists of these conditionals or loops or iterations, if you will. So all of these control structures involve heavy indentation. So what does an indentation mean? Well, what if I gave you an example? Say I gave you some variable called age, and I wrote 20 over here. Now, if I gave you an if statement saying if age is greater than 10, now it's very important to note that when I'm defining an if statement, I need this colon. Otherwise, this if statement is not defined. So this colon is important anyways. So now I'm checking this expression if age is greater than 10. Now, what is this? What happens if age is greater than 10? Now, what if I want Python to do something only if age is greater than 10? Well, how do I tell Python that there is a piece of code or a section of code that I want executed only if this condition is met? Well, this is where indentation comes into play. So if I want this line, this person is an adult. Again, this is some random line where I'm assuming age is pertaining to this adult, alright, or this person. So if I have this variable age where I write this number 20, which denotes the age of some person, and I'm doing a check if age is greater than 10. Actually, let's be specific here. Well, the adult age for most people is 18 in most countries. So let's see if age is greater than 18. Now, if I'm doing this check, I want to print this statement only if this person's age is above 18. So how do I tell Python that I only want this statement to be executed only during this if this condition is met? Well, this is where indentation comes into play. And as you can see, exactly as you can see, this portion of the code is slightly indented compared to the if statement. So when this condition is met, then only do we move on to this. If this condition is not met, we move on to whatever the next section of code will be, like whatever code that we have after this if statement. So let's see. So since this condition is actually met, as you can see, this print statement is actually executed. So this is the importance of indentation. Now we will see as we learn more about if statements and else statements and elif statements, how indentation plays a key role in defining what we want as an output when a certain condition is met. Alright, so for now, it's very important to understand that this is how indentation is used in Python. In other languages, we might use, we probably don't use indentation. In fact, popular language, the C language, does not use indentation at all. But some languages, and Python is probably the trademark language for indentation in programming. So you might say that, so different people have different opinions on indentation. the general consensus is that indentation helps make the code look very presentable and very readable, and this actually is one of the facets of Python programming, is the indentation and the easy readability of it. Anyways, moving on. So what if we have multiple conditions in our code, or in our if statement block that we want to see? So let's create this list, or let's actually just copy this example that I have written over here. As you can see, what I'm doing in this piece of code is I have a list X where I have this integer 50, I have two strings, cat and apple. Now I want to check a bunch of things. So I want to check if 60 is an X, and I also want to check if the string cat is an X, and I want a final sort of, like, if none of these conditions are met, I want something to happen. So how do we do that? Well, we start off our if statement block with the standard if keyword. Alright. Now if we have one more condition that we want met, then we can use the elif, which is kind of a short form for else if. So we use the elif keyword. So what Python reads is it checks this condition, then it will check this condition. And then finally we have this else keyword, and else is a keyword used in our block to tell Python that if none of our earlier expressions have been true, then do what is in the that is within the else keyword, that is indented within the else keyword. So again, we don't pass an expression for else, because else is we only reach this else statement in case all of the earlier conditions have not been met or have come to be false and not true. So let's look at this particular code example. So we have a list of 50, cat and apple, and my first expression that I'm checking is 60 in X. So this is how we check actually. So if 60 and X should be read as is 60 in the list X. So is this 60 in the list X? Well, actually no, we don't have the object 60. So this part is not executed. We move on to the next condition. Is the string cat in X? Well, actually it is. The string cat is indeed in X. So we move on to this statement block, which is within the condition that is met, which is print cat is in list X. And you will see that none of the other statement blocks will be executed because we have met our condition over here. So if I execute this, as you can see that the print statement cat is in list X is what is actually executed. And we do not execute this obviously because it is false, and we do not even check, or we do not even move on to this statement because, well, we have a condition met over here. So it's one thing that is important to note is that we can use as many elif statements to check for as many conditions that we want to check for, but it's very important that we only use, and if we are using, that we only use one else statement and only at the end of our block. Okay, so moving on. Now I'm going to show you a very neat example about how Python actually does its these condition checkings. So it's very important to note that once a condition is met, none of the other conditions are even checked for. So we do not even consider the next statements, and we directly leave this if statement block. So let's look at this example over here. Now in this example that I have over here is where I've stored the string cat in X. Now I have three conditions that I'm checking. I'm checking is 50 greater than 60. I am checking if the value of X is indeed cat, and I'm checking some random expression 1 divided by 0. This is not even a check. This is literally just checking if 1 divided by 0 is true or false. And as we know, we cannot divide anything by 0. So let's see what happens when I execute this statement. Now typically if I wrote 1 divided by 0, Python will throw me an error because 1 cannot be divided by 0. That is an erroneous statement. So let's see what happens when I do this actually. As you can see, I have a statement being printed, but I have no error even though I gave an erroneous statement in 1 divided by 0. Well, now you might ask, why is that so? Well, it's simply because I have actually never reached this condition. I have not even, Python has not bothered looking at this, because if you actually see, there is a condition previous to this over here, which is met and which is true. So we move on to this block, we execute this block, and we forget about the rest of the code. So we don't actually get to this erroneous statement, which is an interesting thing, and which is an example that I have shown to show you that once a condition is met in an if statement block, we do not look at any of the further conditions that are being checked. Okay, so finally, I have one small topic that I would like to share with you is the conditional expressions or the Python's ternary operator. Now, this is slightly different to the if statement that we have talked about up until now, in the sense that it is not a control structure. So what this actually is more of an operator that defines some expression. So let's see what I am trying to say over here. So as you can see over here, highlighted is the syntax for what I'm trying to talk about, this ternary operator. So let's look at this example and let's see what I'm trying to do over here. So I have this variable age, alright, and this age is 26. Now just read this statement. X is equal to adult if age is greater than 18, else child. Now I could have done an elaborate control structure with an if statement, then an indentation within that if statement, and then I could have written else and then another indentation, and I would have written another statement over there. But instead of that, I have used this operator to assign a particular value to the variable x. And this what value I'm assigning to x depends on if this condition is true or false. So as you can see, the condition says is age 18, greater than 18. So if this is true, then I assign this particular string. If it is false, then I go on to the else statement and I assign this. So since age is 26 is greater than 18, I should assign the string adult to x. And as you can see, if I execute this and check what is an x, you can see adult is indeed an x. So this is a very neat, a very readable, and a very it's a better looking way to perform simple else, simple if and else statements where you don't want to create a whole if else statement control structure block. So yeah, this was the ternary operator. Finally, we make a short note on the pass statement in Python. So the pass statement or the pass keyword is a place where is a placeholder of sorts. So what if I had an if statement and I'm writing a piece of code, but I don't know what to do with this if statement. So if a statement is correct, if a statement is true, but I don't know what to do if this statement was true, how do I tell Python, well, let's just keep it a hold for now, and I might put something into this block later in the future? Well, I would use the pass statement. So if I had this, say this some condition again, if I'm checking age is greater than 18, but I don't know what to do with this, I would just simply use this pass statement. And this basically does nothing. It's like a way to create a placeholder where maybe in the future I might write some sort of a print statement or some sort of a different function or something else within this indentation. So, but in the meantime, like currently I don't have anything to place over here, so I just leave it with a pass statement. So this is a way where you can use a pass statement in if and else statements or if and else control structures. In this video, I will introduce you to the concept of iterations in Python, and we will be speaking in specific about the indefinite iteration in Python, otherwise known as the while loop. So let's look at what an iteration means. An iteration is executing the same block of code over and over, potentially many times. A programming structure that implements an iteration is called a loop. Now in programming, we have two types of iterations, definite and indefinite iterations. And in this example, we will be speaking about indefinite iterations. Indefinite iterations in Python is the while loop, where we use the while keyword to define an indefinite iteration. So let's look at the basic syntax. As you can see, this is the basic syntax where we have the while keyword followed by an expression and again the colon, and below that is something indented. Again, we encounter indentations just like in if-else statements, a set of statements where what happens here is, following the while keyword, we have this expression where this expression is evaluated in a Boolean context. Again, we check if this expression evaluates true or false. And if it is true, we execute all the statements or the statement block that is indented below this while statement. This is another example of control structure, much like if and else statement blocks, where we use a lot of indentation. So let's look at a basic example now of while loop. So let's copy this example and let's see what this does. So I have a variable n where I am assigning it a value 0. This is called an initializing process. And it's very important to note that most while loops consist of an expression which contains a variable, a control variable, which is usually initialized prior to starting the loop. And then this control variable is typically modified somewhere within the main loop body. So in this case, my control variable is n and I am initializing it by assigning it the value 0. So let's move into the loop now. So the loop has this while keyword, as you can see, followed by an expression n lesser than or equal to 5. Now what this is an expression which is going to check if it's true or false. Is n lesser than or equal to 5? And as long as this expression is true, we will continue doing whatever is indented below this while statement. And what is below this while statement is a print statement, first of all, which says value of n is, and it basically prints the value of n in that particular iteration. And as you can see, this compound assignment where we add the value of n by 1 and we assign it back to n. So what this is, let's see what this does actually. Let's execute this and see what this does. Important to note, the value of n again is initialized at 0. So this while loop will keep going on until the value of n remains lesser than or equal to 5. So as you can see, I have the execution of this particular block of code or this while loop where I get the multiple different iterations of this print statement that you can see here. The first iteration, it says value of n is 0. Then it says value of n is 1. What I'm doing is I'm writing the value of n multiple times, and each time the value of n is written over here based on what iteration it is. So what is happening actually is that initially the value of n is 0, and I print the statement value of n is 0. Now I add the value of what is in n by 1. So now what is the value of n? So again we do this check. So after this first iteration, we come back, like once this whole block of code is executed, we again come back to this expression and we again check if this statement is true. So now that the value of n is actually 1, this statement is still true. So again we execute this, and that you can see over here, value of n is 1. Now again we add the value of n by 1, and again we go back here once this block is executed, and we check if this statement is true again. And as you can see, the value of n when it's 2 is still making sure that this expression is true. And this keeps happening until the value of n is greater than 5. So once the value of n becomes 6, this condition is no longer met, and finally we do not execute this statement because this expression evaluates to false, and we do not do this anymore, and we finally leave our while loop. So let's check what the value of n is just to confirm this. As you can see, the value of n is indeed 6, and that is why we have left this while loop over here. So this is an example of a basic while loop where we check for this an expression. If it evaluates to true, we evaluate everything within it. Once this is done, we go back and we evaluate this expression again. If it is again true, we again go back and do whatever is indented within it. And we keep doing this until the expression gives us false. And interestingly, we don't necessarily have to define these control variables always. We can actually use iterables, and we will learn about iterables actually in a future video. But we can use iterables, and an example of an iterable is the list. So let's look at this list and let's look at this whole block. Alright, so I created this list A, which contains 5 objects, 1, 2, 3, 4, and 5, all integer objects. And I have another variable x where I store the integer 1. Now this while statement, now it might look confusing. Now it says while A. Now what is A? Well, A is not your typical expression where you're making sure if some condition is being met or not. But this, the way you read this is while A exists. So in the context of a list, as long as A, which is a list, contains objects within it, A is true. If it does not have any objects within it, A is false. So while A, basically what it means is while A has objects within it. And if it does have objects within it, or as long as it does, we continue executing whatever is indented within this while statement. And this while statement is a print statement. Again, we we have this value x where we're doing we're printing this is iteration number, and we pass x. So the first iteration will obviously pass x is equal to 1, and then we add x by 1, and then the second iteration should pass this is iteration number 2, and then so on. And finally we have another statement within this block called the pop statement, where we're popping the elements of A. Now, as if you would have seen the video on lists, the pop statement removes the rightmost value from a list. So if I do a.pop, initially it will remove 5 from this list, and I will have the rest of them. And again, if I do pop, it will remove 4 from this list, and then you will have the rest of these. So let's actually see. We'll actually check what's left in this list each time we do this pop statement. So I'll also print the list A during each iteration, and let's see what happens over here. as you can see, what is happening out here is while A has elements, we are going to continue doing this while statement, whatever is within it. So in the first iteration, obviously we have all of it, and it is iteration number 1. And as you can see, the list contains everything. Then I pop it. Then iteration number 2, it again has elements, but it has lost its rightmost element. And this keeps on happening until the list finally has no elements left. And once the list has no elements left, this expression while A evaluates to false, and we do not execute this anymore, and we leave the while loop. And again, let's check what is in A. A should have no elements. As you can see, it's an empty list. When I checked what's in A, it's an empty list, and that is why while A returned me a false, and we did not print any further. So this is an example of using a while statement using lists. And of course, the next topic would be discussing nested while loops. And this is a broad topic. What I mean by this is that when I'm saying nested while loops, I'm actually talking about nested control structures. So we can have while loops within while loops. Not only that, we can have if and else statements within while loops. We can have while loops within if and else statements, and we can have if and else statements within if and else statements. So if you think of all of these loops, and we will even speak about for loops in another video. For loops again are a type of control structure. So all of these are control structures. While loops are control structures. For loops are control structures. If and else statements are control structures. All of these are control structures, and nesting can happen within them. And it does not matter which is the parent of the nest and then the child of the nest. You can have a while loop within an if and else statement. You can have for loops within a while loop. All of this is valid in Python, and it's one of the great features of Python that is very flexible in this way. So let's look at an example where I have a while loop within another while loop. So I'm copying this piece of code where I have this list 1, 2, 3, 4, 5, and another list first and second. Now my first while loop, I print what is popped from A. So I take A, then I pop the 0th index. So basically from the left hand side, and I print what is that. Alright. And then I have another while loop where I have this list B, and I'm doing the same thing. But this while loop is within the first while loop, and let's see what happens out here. So as you can see, my first iteration of this parent while loop causes me to pop what is the first element, which is 1. Then I do these while loops, and this is completely executed, and only then do I go back to this first one. And then I come back and do all of this again. Then I go back to this one, and then I come back and do all of this again. And that's why you can see this repetition. So I have this first iteration, and then I do the second while loop. Then I have the second iteration, and then I do the second while loop, and I keep doing this. And this is an example of a nested while loop. Okay, so our next topic in this video would be break and continue statements. Now break and continue statements are ways to abruptly end iterations in a particular loop. You can use break and continue statements not only in while loops, but you can use it also in for loops. So let's look at how we use it in while loops. And let's look at what we mean by break and continue statements first of all. Well, the break statement terminates the loop entirely. So once the break statement is found, the complete while loop that we are using is completely terminated. And the continue statement, on the other hand, terminates only the current loop iteration, and it goes back to the beginning or the expression, and it checks whether the expression or the controlling expression is again reevaluated, and it is checked whether the loop will execute again or terminate. This pictorial that you can see here actually emphasizes, or it shows the difference between break and continue. So I have this while loop and I have an expression. Alright, I have a bunch of statements, and I have a break command over here, and I have a continue command over here. So if I encounter the break command, it will not execute any of this. In fact, it will not execute this while statement at all, and it will move on to the next piece of code that we have. But a continue statement, if a continuous statement is encountered in a while loop, will not completely break away, but it will not execute the rest of the statements in that iteration, only these two, but it will go back here, it will check this expression again, and again we will do this all over again. So this is this small difference between the break and continue statements, but both are used to abruptly end an iteration in a loop. So let's look at an example of how we use the break statement. So I will use this example where I have initialized some controlling variable n to 0. My first loop will check whether n is less than or equal to 5. If this is true, then I will print this statement. Then what I'm doing over here is I am incrementing it by 1. Now in my earlier example using the similar example, I had no, this part was not there. So what you got was, I was printing the value of n. So it was printing as value of n is 0 and then 1 and then 2 and then 3, 4 and 5. But over here I've included I've nested an if statement, and within that I put a break statement. And this if statement is checking if n is equal to 2. So once n is 2, I move on to this and I do the break statement. So let's see what happens now. As you can see, so when I've executed this, I don't get the whole value of n is 0 and then 1 and then 2, 3, 4, 5. I stop at 1, and that is because once n is equal to 2, I actually do not execute this while loop again. I do not go back and execute print value of n is 2 now. In fact, I break from this whole while loop, and my while loop terminates right then and there. And that's why you only get these 2 iterations, value of n is 0 and then value of n is 1. Okay, so now I'm going to show you a neat example of what happens, or what is the difference between a break and a continue statement. Okay, so let's go back to our initial example where we're printing this value of n is 0, 1, 2, 3, 4 and so on. But I've added one more statement where I print hello at each iteration. So let's see what happens when I do this. As you can see, it will print hello after each of whatever I was doing already. Now let's introduce our break statement first of all. So when I do break, well, let's go back to this if statement. If we check this condition, then we break. Let's see what happens now. As you can see, something interesting has happened where we have this first iteration completely being executed, but the second iteration kind of stops where there's no hello, and that is because we have broken from this while loop before the second iteration's hello was printed. Let's see the difference between a break and continue now. So now I have this continue statement instead of a break. Let's see what happens here. As you can see, it seems familiar to our first example where we did not have any break or continue. But there is a small difference that I want you to catch, and that is very important about this continue statement. So as you can see, the first iteration has value of n is 0 and then hello. Then value of n is 1, but there is no hello. And this is because once this condition is actually met, we do not move on to this statement, but we go back to this expression and we evaluate this expression. And then once we evaluate this expression again and it's found to be correct, we do everything the same again where we print hello. But except for that one step where this if statement was met and we did continue, and this following statement was not executed. And that happens only for one iteration, and that is when n is equal to 2. And as you can see, that is what happens over here. In one of the iterations, we miss a hello, and that is the difference of the continue statement with the break statement. This video will be an extension to that topic where we will be looking at 3 examples where we are using while loops along with other stuff like say if and else statements. So our first example will be where we calculate the factorial of a number. In this example, as you can see here, we are first going to ask the user to enter a particular number for us. Now this number is supposed to be an integer. Once we have this integer, we store it to a variable called number. Now we have this, you can say this variable called FAC which stores 1, and we will see how we are using it later. Now we know that the factorial of 0 is 1. That's how it's just defined. So we have an if statement checking whether our entered number is 0, and if it is 0, we say that the result is 1 or the factorial is 1. However, if we enter a number that is greater than 0, we must calculate the factorial for this number. And that is what we are going to do in this else statement block over here. Now in this else statement block, we have a while loop. In this while loop, the condition is checking while number is greater than or equal to 1. So as long as this condition is true, everything within that while loop will be executed. So as long as number is greater than or equal to 1, we are going to execute these 2 lines. Now what do these 2 lines do? Let us see. So the first line takes the variable FAC where we had the number 1 stored, and we are going to store FAC times number into it, number being the number that we have inputted. So in case, for example, we entered 8, then what this line will do is 1 into 8, and it will store that back into FAC. Now once that is done, we move on to the next line where we are decrementing the number variable by 1. So if we have stored 8 or we have entered 8 into our input, it will become 7. Now as we know, 7 is still greater than or equal to 1. So this condition is still being met. And then we do this process again, where we are going to multiply FAC. This time FAC stores the value 8, and we multiply times the new number, which is 7 now. So we do 8 into 7. And then again we decrement this. Also, once we do 8 into 7, we store it back into FAC. And we keep doing this, where we keep multiplying 8 times 7, and then we decrement the number variable by 1, and then we check this condition again. So what ends up happening is, we are going to keep doing 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And once we are at 1, again when we do this decrement operation, the number variable will store the value 0, and then this condition will no longer be met. So number will be 0 and this condition will be false, and we can move out of this while loop. And then finally we store the result into a variable called result, which stores the result of 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is of course if we did enter 8 when we were asked to give an input. So let's see this in real time once we execute this. So I'm executing this. The first thing it asks me is to enter a number. So let's say I enter my number 8, as I was speaking about 8. Alright, now that I have entered 8, as you can see, the result that it gives me is factorial of 8 is 40320, which is correct, and you can check this for yourself, where it will show you 8 times 7, or 8 factorial is basically this number. Okay, so now in our next example, we will be looking at how we can generate Fibonacci numbers. For this example, we will be using bunch of if and else if statements along with a while loop. So let's look at this piece of code where we are actually doing this. So as you can see, the first part of the code is basically an input statement asking us how many Fibonacci numbers we would like to generate. And then the user would be asked to give an input, which is stored as an int into a variable count. Now in this if-else statement, the first if statement checks whether what we have entered is 0, in which case we just store an empty array in the variable called fib. Next, if our entered integer is 1, we just store the value 1 in this array called fib. If our entered number is 2, we store 1 and 1 in the array fib. All of these are different sets of Fibonacci sequences. This obviously an empty array shows that, well, there is no numbers to be generated in this sequence. If we have 1, we just print the first number of the Fibonacci sequence, which is 1 itself. If it is 2, we print the first two numbers, which is 1 and 1. Now, the actual calculations happen when we say we want a Fibonacci sequence for more than 2 numbers. Now, in that case, we move on to this block. In this statement block, we initialize the fib variable with the first two Fibonacci numbers 1 and 1, and we store in this array. Now, we are going to do a while loop within this, and in this while loop, we're going to keep executing this statement block as long as this condition is met, or this condition is true. And what this condition is it's checking this variable I, which we have initialized as 1 over here, and we're going to check whether that is lesser than count minus 1, count being the number that we have been asked to input. If the statement is true, and as long as the statement is true, we will be executing this statement block, which is basically us appending this expression into the array fib. Now what this expression is basically, it's going to keep adding each subsequent numbers, and we're going to store each subsequent numbers back into the array fib. So in this case, if you see, what the first step will do is it will take the value at the first position of the array fib, and it will add it to the value at the 0th position of the array fib. And both of these values, since they are 1 and 1, when we add them, we get 2, and we append that to fib. So now our fib will look like 1, 1, 2. Then we increment this by 1, and what we do is we do the same process again. So in the next step, what we would do is we would do 2 plus 1. So we would get 3. Now this would keep going on until this condition is met, or basically until the numbers that we actually want to generate in our sequence. So let's execute this, and let's see an example of what happens. So it asks me how many Fibonacci numbers I would like to generate, and I will say I want the first, let's say 6 Fibonacci numbers. So I execute this. As you can see, this gives me the first 6 numbers in the sequence, which is 1 and 1 and then 2, which is basically 1 plus 1, and then 3, which is 1 plus 2, and then 5, which is 2 plus 3, 8, which is 3 plus 5. So if we wanted more numbers, we would just enter over here. Like say if we wanted the first 10 numbers, it would give us the first 10 numbers in the sequence, as you can see here. Now in our next example, what we are going to do is we are going to write a program which takes 2 digits that represent the dimensions of an array. For example, if we want a 3 by 3 array, we will enter 3, 3, and we are going to generate a 2-dimensional array in which each of the elements of the array are basically the row times the column position of that particular element. And what I mean by this is, say we have a position I, j on the array. The value of the element at that position would be I times j. So for example, if I'm looking at something at the 3rd row and the 5th column, or say the 3rd row and the 3rd column, for example, the value of the element would be 3 times 3. And if I'm looking at something at the 2nd row and the 4th column, I am going to do 2 times 4. So let's see how we can do this using code. So if you look to the right over here, I have a piece of code where I'm going to where it asks me to input 2 numbers, 2 integers to represent the dimensions of my my sample array. Now once we have done this, we are going to store these dimensions in the inputs in a variable called input string. So obviously when we enter say 5, 5, that will be stored as an int in this particular string or this variable. What we want is, we want 5, say we entered 5, 5, we want 5 as a separate integer and the other 5 as another separate integer. And that is what we do in this particular statement, where we're going to split up our input string based on the comma separator, and we're going to store the first part of that string into the 0th position of dimensions, which is an array, and the next dimension in the first position in this particular array. Now we are going to store the number of rows as row number, and that is the 0th position of this array, and we're going to store the number of columns as the first position of dimensions, or whatever we've mentioned in the input. So now we have this our results array called multi-list, which is basically what our final array is going to look like, and we're going to store it into multi-list. And in this example, we will be using for loops to do this, or to create this particular array. So as you can see here, our first we have initialized our multi-list, saying that we're going to have only zeros in our sample array. So initially, once we have initialized this array, all multi-list will contain is a, say for example, we have inputted a 5 by 5 array. It will have basically a 5 by 5 array with all elements as 0. And that's what this line does. Once we have done this, we are going to move on to the for loop portion, where we are actually going to create our array that we want. So as you can see, our first for loop is going to say for row in range row number. So obviously range will generate an iterator which can be iterated over, and since it says range row number, and say the number of rows that we entered were 5, what it's going to do is it's going to create an iterator containing the value 0, 1, 2, 3 and 4. So for row and range, it will basically row will take the value 0, 1, 2, 3 and 4. And a similar thing is going to happen in this nested for loop, which is within this, where we're going to again create an iterator using this range function and for the column number. Once we have this, we're going to do the simple process of multiplying the value of the element based on its position. So if it's at the position 3, 4, we're going to store the value 3 times 4 into that particular position of the array. And we're going to do this for every position, which is what happens in these two for loops. We're going to first go by each row, and then within that we're going to check each column, and we're going to perform these calculations. And finally we print our result. So let's look at an example. Now I'm going to say I want a 3 by, let's say a 2 by 4 matrix. So let's see what the results will be when I give this as so what I'm saying is I want 2 rows and 4 columns. Now as you can see here, it might not be very clear to you right now, but what you can see here is this is the first row and this is the second row, and each row contains 4 columns. So these are this is my final array that I get. So what you can see here is this is the 0th position, and the or you can say this is the first row, first column, first row, second column. And since Python is 0 based, so this is actually the 0th row and this is the first row. So as you can see, this value basically is 0 times 1. This value is 0 times 2, 0 times 3, 0 times 4. And over here it is 1 times 0, 1 times 1, 1 times 2, 1 times 3. So similarly, if I did, for example, a 5 by 5 matrix, what you will get is 5 rows now, 5 rows and 5 columns. And for example, like this particular value is 1, 2, 3, or 0, 1, 2, 3. So 0, 1, 2, 3 and the first column. So this is 3 times 1. If I took this value, this is like the 4th row, for example. 4th row times the 0, 1, 2, 3, third column. So this would be 4 times 3, which is 12. So, and each value of this has been generated in the similar process. So this is an example of how we can use for loops for a particular exercise that I have shown you right now. In this video, we will be covering the topic of definite iterations using for loops in Python. So starting off, we know that there are two types of iterations in programming, definite and indefinite. We have already covered indefinite iterations in the form of while loops. Definite iterations, on the other hand, are done using the keyword for, and the basic syntax or the standard syntax for a basic for loop in Python is as you can see over here. We have this for keyword, we have some variable, we have the in keyword, and we have this iterable, and we of course define this control structure with the colon, and then indented we have this statement block. So once this for loop has started, we execute all of these statements within the statement block as part of the for loop iteration. So yeah, let's to understand like how for loops work exactly, let's look at the concept or meaning behind what we call iterables and iterators. So think of it in a stepwise manner. Alright, so in Python we have different objects that can be used as iterables, and an iterable is basically some object that it's a collection of other objects. So think of your lists, think of dictionaries and sets. So all of these are essentially collections of objects. So once we have these collection of objects, we can create an iterator out of it. How do we do that? Is we use the iter function. So for example, if I passed this list A through the iter function and I store it in some variable iter underscore A, and I see what is iter underscore A, it is actually a list iterator at some random memory location, which we don't really care about. Similarly, if I gave a tuple and I did the same thing, I will create a tuple iterator. And in the left, if you can see over here, I've done the exact same functions with sets and dictionaries as well. So I'm creating iterators out of these iterables, so as to speak. Now, what is an iterator? Well, an iterator is an object that yields values successively. So if my list contained 5 values or 5 objects, an iterator of this list will yield these values one after the other. And that is kind of how, or that is the basis for which we create loops. Let's see what we exactly mean using this, using another function that we call the next function. So the next function keeps moving from object to object within an iterator. So since I've created this list iterator, let's just do it once again. So as you can see, I've created this list iterator iter underscore A. Now with this iter underscore A, what I'm going to do is I'm going to use this next function. What next function does is, starting from the leftmost object within this iterator, I will keep yielding, or I keep producing the values. So let's just see what happens when I do next when I do next for this particular variable. It gives me this object first. Now let's see what happens when I do it again. Now it gives me the object second. What if I did it again? It gives me third. Now if I kept doing this, it will keep giving me the different objects that were initially stored in A. That is first, and then second, third, fourth, and fifth, one after the other. So let's actually perform that. Now I get fourth. Now I get fifth. Now a natural question is, now that I've exhausted all of these values, what will happen if I perform the next function again? Well, let's see what happens. I get an error, and this error is the stop iteration function error, which basically is telling me, look, you have exhausted all of the objects that were initially present in this list A, and you cannot keep doing the next function anymore. You cannot keep going further. So yeah, so this is what the next function does when it comes to the concept of iterators. Alright, so now we've learned two things. What is an iterator and how do we create an iterator out of different collections of objects like a list or a tuple. And we've also learned how to use the next function. Now let's let's come back to our for loop that we started off this video with. So our for loop again, let's consider our for loop over here. As you can see, some for loop with the objects again 1, 2, 3, 4 and 5. Alright, this is a list. Now I'm going to do for x in a print x, and let's try to see what happens when we do this. Okay, as you can see, when I have executed this, it gives me 1, 2, 3, 4 and 5. So first of all, let's look at this for loop. In this for loop, I define a new variable x, and then I say for x in a print x. And what's happening? Well, in each iteration, I'm printing whatever the value of x is at present. So in the first iteration, it is the first object 1. In the second iteration, it is the second object 2, then 3, 4, 5. And then finally, on its own, this for loop knows that, okay, now once I have exhausted all of the objects within my iterator, I can stop doing this for loop and I can move on with the rest of the code. Alright, so think of it like a 3-step process, a for loop in Python. The first step is it calls an iter function to obtain an iterator for whatever we pass over here, this iterable. Second step, it calls the next function repeatedly in each iteration, alright, to keep getting the next item from the iterator. So it gets 1, then it calls next, then it gets 2, then it calls next, and it gets 3, and then 4, and then 5, and so on. And then finally, the third step is the termination step, is when after we do the final next, where we get this error, as you can see, the stop iteration error or exception. Finally, this tells the for loop function or the for loop that, okay, we have reached the end of our definite iteration or the end of our definite for loop, and this is where we must terminate our loop and then continue with the rest of the code. Alright, so this is how a for loop works in Python. Now it's very important to note that whatever we have discussed when it came to while loops, such as nesting of while loops and nesting of other control structures, is also applicable in the case of for loops. So if I had a for loop within another for loop, that is perfectly fine. If I had a while within a for loop, that is perfectly fine. So all of these are valid statement blocks that we can do. And again, for loop is another control structure, and so we must follow the concept of indentation when it comes to writing our statement blocks within a for loop. Okay, so now I'm going to speak about, in specific, I'm going to speak about something called the range function. That is quite, you could say, it's used in other areas of programming, but it's widely used in Python. I mean the for loop in Python. What I mean by this is that this range function is very important for the for loop, and we will see why. Okay, so let's look at one of the examples of using the range function. So what does the range function do is, if I give range 5, let's see what it does. It gives me range 0 to 5. What this basically tells me is that this will create an iterator that contains integers from 0 to 5. So it will contain the object 0, 1, 2, 3, 4, and 5. And we can use this as an iterator. So let's look at this. I have range 5. Let's store this in x. Okay. Now let's do a type just to see what happens when we do type x. It should give me the type of range, as you can see. And this is a type of an iterator in Python. Now let's see what happens when I do for I in x print I. Okay, let's see what happens. As you can see, it prints the number 0, 1, 2, 3, 4. An important caveat when it comes to the range function is when we say range 5, it creates an iterator from 0 to 5, but it contains the objects 0, 1, 2, 3, and 4 only. It does not contain the object 5 itself. Okay, this is something that is very important too. So once again, I use this range function to create an iterator of 5 objects from 0 to 4, 0, 1, 2, 3, and 4. I use that in my for loop, and that is what you are seeing here. Now let's use this range function in the context of something else. For example, let's see. So I had my earlier list A, right? Look at my list A here. So you can see list A contains these 1, 2, 3, 4, 5 objects. Okay. Let's see what length of A is. Length of A is 5. Okay. Let's use the range function on top of the length of this list A. And this is like, I can't show you an example right now without any context, but this form of using a for loop is widely used in Python programming. You will use it so much in data science. You will use so much in machine learning and AI. I cannot tell you. This is a very important, like, sort of for loop expression. So you have for, let's say, I in range len a. Let's see what's going on here. First I do length of a, that gives me 5. Then I do range of 5, that creates an iterator between 0 and 4, right? When you do range 5, it gives you an iterator of 0, 1, 2, 3, and 4, as we saw earlier. And this is what we're doing over here. We have created an iterator out of the length of a list. Now when I do print I, it should give me again 1, 2, 3, 4. 0, 1, 2, 3, 4, of course. So as you can see here, it will give me 0, 1, 2, 3, 4. And this is a very neat way of using the range function on top of the length of a particular collection of objects. In this case, we're using the list A. This is something that you will use a lot. So I would recommend that you get used to this form of creating a for loop as well, using the range function. Also, of course, you can use break and continue statements as you have in the case of while loops. It works exactly the same in the case of for loops, wherein the break statement will abruptly stop the for loop completely and we will move on to the next piece of code, whereas the continue statement will break that particular iteration and then we will resume with the next iteration. So yeah, that was break and continue statements in for loops. Finally, I would like to show you something about how to use dictionaries as an iterator or as an iterable when it comes to for loops. So let's create our dictionary. Let's go. We have a dictionary already here. In fact, let's create this dictionary. Again, we'll store it in A. Okay. So I created this dictionary A. All right. So I have dictionary A. What I'm going to do is I'm going to pass it through the iter function, as you can see. And now I'm going to just, for the sake of showing you, I'll show you that it is actually an iterator of type of a specific dict key iterator type. All right. So now let's do something on this. So as you can see in this dictionary, I have the key first that has the value 1. I have the key second that has the value 2. I have the key third that has the value 3, and then fourth for 4, fifth for 5. Now, a good question would be, when I do iteration or when I do a for loop on top of this A, well, what is it going to pick up? Is it going to pick up first? Is it going to pick up the keys like these? Or is it going to pick up the values? Or is it going to go one by one? Key and then value and then key and the subsequent value. Let's see what actually happens. So let's do for I in iter underscore A print I. Let's see what is the iterations happening upon using this. So as you can see, we're using the keys. So by default, when we do this, when we create an iterator out of a dictionary, we use only the keys as our iterator elements or at iterator values. But of course, like if you wanted to use values, all you would have to do is pass a dot values over here. And if you remember from a dictionary video, this a dot values gives us a list of, or it gives us essentially a list of the values in our dictionary. So when we pass this to the iterator, iter function, and we create an iterator out of it, let's see what happens over here. Now let's see what is iter underscore A. You can actually see it's now the dict value iterator at a particular memory location. So it's not the dict key as we saw earlier, it's a dict value iterator. So now that we have this dictionary value iterator, now let's print what are our iterator elements. And as you can see, now we are printing values and not the keys. So this is how this is basically two different ways of iterating through a dictionary, one through keys and one through values. In this video, we will be doing a small exercise on if statements. Now in the previous video, you might have already seen some of the basic concepts surrounding if statements. However, in this video, just to drive home the point or the purpose of an if statement, we will be doing a small exercise. So let's first revise some of the concepts of an if statement. So a basic if statement can be something like this. We have a small condition where we're checking if a variable x is greater than 5 or not. And if it is greater than x, we print a statement over here. So if this condition is met, we print this statement. Else, we move to this statement block. Now our variable x has the value 5. Now since x is not greater than 5, what this will do is, it will check this statement, and since this will be false, we skip this statement block and move on to this statement. So as you can see here. Similarly, we can do something where we are checking multiple statements. We use the elif statement in such a case. So now in this block, we are checking in one of the conditions we're checking is if x is equal to 5 or if x is greater than 5. And then finally, if both of these conditions are not met, we say else and we print whatever, or we do whatever is in this particular statement block, which is a simple print statement. So as you can see, x is indeed is equal to 5. So this is the block that will get executed, as you can see here. Now another example are nested if statements. So nested if else statements are if else statements within if else statements. So let's look at an example. As you can see here, we have a string stored in a variable called orange quality, and the string is fresh. Now we have an integer, or a float in this case, 4.0 stored in orange price. Now our first statement is checking whether orange quality, the variable orange quality, is it equal to the string fresh. Now within that, if this statement or if this condition is met, we do another check where we're checking what is the price. Is it lesser than 5? If it is, we do this block, else we execute this block. Finally, if our initial statement or initial condition is not met, we move on to this else block. Now when I execute this, what should happen is I will enter this block because this is true, and finally I will enter this block because this condition is also true. So I should have this printed. I will buy 5 dozens, as you can see here. Now let's move on to our main exercise for this video. So this was all just a revision. Now we're going to use some or all of these concepts in a sample project or a sample exercise for your further practice. So in this exercise, what we're going to do is we're going to request the user to enter a number between 1 and 20. And our code is going to check whether this number entered is an even number or an odd number. So as you can see, there are 2 sets of checks that we're going to do in this code. The first check is going to be whether the number that is entered is between 1 and 20 or not. And if it is not, we have to say it's an invalid number. But if it is entered between 1 and 20, we have to move on to the further checks, which is whether it is an even or an odd number. So let's see how we do that. So in this piece of code, what we start with is a print statement saying, please enter a number between 1 and 20. And then we add an input command. This input command will open a box where we can enter whatever number that we want to enter. Now we use this int keyword to make sure that whatever we have entered into the input box is stored as a int data type in the enter num variable. Once we do that, our first if statement is going to check whether the entered number is greater than or equal to 1 or lesser than equal to 20. And lesser than equal to 20. So both of these conditions have to be met. If this condition is true, then we have a valid input and this statement is printed that we have entered a valid number. And then we move on to the rest of the statement block within this if statement, which is another set of if and else if statements. If our number is not between 1 and 20, we move to this block and this block prints that we have entered an invalid number. Now, once we have, say, entered a valid number, we move on to this block, this if elif statement block. Now what this block is checking is whether the entered number is an even number or not. Now as we know, an even number is divisible by 2 and leaves the remainder 0 when divided by 2. So this is what this check is doing. If this check is true, that means our number is even and we get printed that our number is even. The other check or the other if statement is checking whether it's an odd number, and that means when we divide by 2, we should get the remainder 1, as you can see here, and we get printed your number is odd. So let's execute this and see what happens when we enter a number. Now it's asking me to enter a number. Let's say I enter 17. Now that I have entered 17, as you can see, it's a valid number that I have entered, and the code is telling me that my number is indeed odd. Let's look at some other, what if I entered something else here? Let's say if I enter 16 now, since it's an even number. As you can see, 16 is also a valid number as it's between 1 and 20, and my number is even, and the code checks for that. Let's see what happens when I enter an invalid number. Let's say 25. Now when I enter 25, as you can see, it says I have entered an invalid number. And in this case, what has happened is, this condition itself is not met, and I have moved on to this statement block. So to give you a breakdown as to how our code has executed this, let me show you an example for the number, say 9. When I enter 9, the first check that happens, of course, is this check, whether it's a valid number or not. And since it is between 1 and 20, we move on to this block. And in this block is checking whether our number is divisible by 2 or not. And since it is not, it will leave a remainder 1, and we execute this block, which says our number is odd, as you can see here. In this video, we are going to learn about the topic called file handling. Now, file handling is basically needed because most of the times when we are handling large and different types of data in Python, or in general, we cannot store everything into a variable, and we will have to use files. Now, there are two types of files that we are going to deal with. They are binary and text files. So binary files are some of the files that most of the files that we commonly encounter, like document files, image files, video files, etc. Now, all binary files are encoded in a particular format, and they cannot be read by a normal text editor. And we would be needing certain specific softwares for specific files. Text files, on the other hand, do not have any specific encoding, and they can be opened in the normal text editor itself. And they are like XML, CSS, HTML files, and so on. Now, there are 4 main operations that we can do in Python on files. They are open, read, write, and close. There are certain other operations as well, though, like rename, delete. So some of the most basic operation that we can do is obviously creating and opening a file. And the syntax is, as you can see here, where we use the open command, and we give a file name, and we give a mode, and we store that in a particular variable. Now, a mode is basically telling Python how to handle this opening. So we can have a read-only mode, which is done by this letter R, a write-only mode, which is done by letter W, and there are a bunch of other modes, such as read or write mode, which is done by R+. And we are going to see them as we encounter them. Now, it's important to note that what I just mentioned is for text files. If we are going to do, for binary files, we're going to do this file handling, then we would be using the letter B in front of whatever we were using in the case of text files. So if we were doing a read-only mode for opening a binary file, we would be using RB. And if we were doing read and write mode, read or write only mode, for a binary file, we would be using RB+. So basically just adding the B in the case of binary files. Let's look at a basic example. When we want to open a particular file, we are going to open, like in this example, I'm going to open some file called filehandling.txt in a read and write mode, read or write mode, and I'm going to store it in FO. So this is as simple as it gets. Similarly, if I wanted to do it for a binary file, since I'm using a binary file, I will use the letter B as well in the mode. And that's how you do it here. Now let's look at different ways in which we can read from a file. And there are 3 commands that we can use. We can use the read command followed by an optional number of characters. We can use the read line command followed by an optional number of characters, and the read lines command. So this optional number of characters is denoted by n over here, and basically it's telling us how many characters we want to print. So let's look at a simple example of where I'm going to print something called, so I'm going to take this and I'm going to do a print on top of this. So I've opened it and I've stored it in my file, and then I'm going to do a method or a function called read, and I'm going to say, like in this example, just read the whole thing. So as you can see, my file that I have opened has all of these lines. This is like the whole file basically. But now what if I wanted to open only the first 5 characters of this file, which is basically this? Well, in that case, let's open this once again. Now let's do the same read command, except we will give the character number, which is 5. As you can see, it's only printed 5. Now let's do a print read command and try to read the whole thing again. And you will notice something very interesting. Now when I do the read command, you can see it's kind of picked up from where we left off from our previous command. And that is the nature of how Python handles files. So if I wanted to again take the cursor back in such an example, I will have to open this again, and then I use this read command once again to get back to where I started from, as you can see here. Now another command that we can use is the read line command. So let's once again open this over here, and now we're going to use the read line command over here. So what read line command is going to do is each time we use this command, it's going to go one by one and read each particular line from this file. So in first case, it will take artificial intelligence, then data science, big data, and so on. So as you can see, if I execute this, it first takes artificial intelligence. Now if I did this command again, it will say data science. Next time if I do it, it should say big data, as you can see here. Okay. So this is the readline command. Now within the readline command also we can enter characters, and that will tell us basically that we want these number of characters from the next line. So if I want the first 6 characters of the next line, I will say 6, I will enter 6 here, and it will give me the first 6 characters of this particular line, which is the next line that is to come, as you can see here. Now another way in which we can print whatever is there in our file line by line is by using a for loop. So again, I'm going to open this file, I'm going to store it here. Now I'm going to use a for loop saying that, well, for line in my file, and what this does is basically at each iteration, it's going to take each line and store it in this variable that we enter over here, which is called line itself. And we're going to print that. At the end of the loop, what we'll have is all of the lines have been printed one by one. And another thing that we can do right now is, say we want to read a particular line. Say I wanted you to read the 5th line of my file. I can use this technique where I just say, okay, I'm going to store 5 in this variable called line number, and I have this another variable called current line, which I'm going to initialize with 1. And what I'm going to do is I'm going to do the same loop where I'm going to say for line in my line, but I'm going to add a condition saying that only if current line, when it's equal to line number, am I going to print the line, and then I'm going to break out of this whole thing. And at the end of each loop, I'm going to say current line is going to be incremented by 1 until basically these two variables are equal. So when I do this, I get my result, which is machine learning, which is the 5th line of whatever file I had. Now we're going to move on to the topic of image file handling. So we saw how we handled and we saw certain operations around text files. And text files are obviously something that we're going to use a lot. But we are also going to be using files such as images a lot. And let's look at certain examples and certain use cases around image file handling. So my first step is going to be importing a bunch of modules and packages. Now the details of these modules and these packages are not important as of right now because they will be covered in a future video. But just keep a note of some of these packages such as let's say NumPy and the image package. So once I've done this, let's move on to my example. So what I'm going to do is I'm going to store certain file locations in 2 variables. So it's basically 2 strings. I've attached the this prefix R to say that this is a read-only sort of a prefix. So the next topic that we're going to be handling is image file handling. Now we have already seen many examples pertaining to text files. So text files are obviously something that we're going to be using a lot. But image file handling is something very important as well. And we're going to see certain operations that we can do around image file handling. So starting off, I'm going to import a bunch of packages and modules. What these packages exactly are and what these modules exactly are right now not that important to you right now, but it's something that will be covered in a future videos. It's important to just keep note of what these are, such as NumPy and image. So once I've done that, what I'm going to store is I'm going to store 2 particular file locations in 2 variables, location 1 and location 2, and I've prefixed them with R just to say that these are raw strings. So once I've done that, I'm going to use the image from the image package. I'm going to say open, and I'm going to say open from this particular location and this particular location, and I'm going to store these images in IM1 and IM2 over here, very similar to a normal text file opening. Now once we've done this, we can access certain properties of this image using, say, format, which tells us the format of the file. It identifies the source of an image. And if the image is not read from a file, it is set to none. We can also see the size of the file using the size attribute, and we can see the mode, which basically defines the number and names of the bands in the image and also contains the pixel type and depth. Certain common modes are like L for luminescence, RGB for true color images, and CMYK for pre-press images. So let's look at them. So when I access this, you can see my first file is of JPEG of this size and an RGB format image. And my second image is another JPEG, slightly bigger image, and again RGB. Now we can also, of course, display these images, and to do that, we can use the PLT. Again, PLT is supposed to stand for matplotlib.pyplot. It's a particular package that again, you don't need to know the details of right now, but this is how we would do this. So I'm going to use a bunch of commands and methods such as figure and subplot and then IMShow. So once I have done this, as you can see, both of my images, with this being IM1, this being IM2, have been produced on the screen, as you can see. I can also use display, this display function followed by the name of the file, and this will simply display my image, as you can see here. Now I can obviously save a particular image using the save function, which is as simple as just doing this. So I'm going to save the image as im_save.jpg over here. Now if I wanted to crop an image, I can do that as well. So I stored the dimensions that I want cropped in the form of a tuple, as you can see here, and I'm going to pass that tuple to the crop function, and I'm going to apply that on top of im1, and I'm going to store that to region. Once I've done that, as you can see, so basically what I've done is I've cropped this image based on whatever I've passed here, and I've stored it into region. And now if I wanted to see what was actually in that crop, I can just do the IMShow function, and I'm going to pass the particular cropped image, which is denoted by region, as you can see here. And you can see my cropped image is basically a left portion of this whole image has been cropped out, and I have produced it over here. Now I can also use the copy function. It's a simple basically copy. You use the copy function and it copies an image onto another variable that you have assigned. And when I use the IMShow function, I'm going to show you the copied image, which is basically the same. Now we can do the transpose operation as well. So let's see what we have done here. So in this transpose operation, so in this basically I've done a bunch of operations such as rotating by 90 degrees, rotating by 180, rotating by 270. And finally, once I've done with all of these multiple operations, I'm going to show you the final output, which is basically a certain transposed image like this, which is basically the result of whatever I have done before this. So this is it for this video on file handling. I have shown you two slightly more comprehensive examples on text files and even certain examples on image files. However, we can use file handling in different libraries pertaining to file handling for audio files and even for stuff like PDF files. And this is just only the beginning, and I'm sure you will encounter a lot of different use cases, different examples as you continue learning Python programming. This video is going to be the first of a part of a series on object-oriented programming. So to start off with, let's try to understand and get an introduction into what is object-oriented programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. Whereas its behavior, or functions for that matter, would be like accelerating, gear change, braking. Similarly, if I give you an example of a dog as an object, we could consider the properties of the dog as its weight, or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. Classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now obviously, to define a class we need a keyword. Well, in the case of classes, we use the class keyword followed by a name for that class. So in this case, my name is circle. Now, after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now you can see over here a bunch of def keywords followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these we have like 3 dunder methods over here, and we have one user defined method that we will get to. So this first method that you see here is the init method or the initialization method, and this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I pass, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. repr is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user defined method. User defined methods are methods that we define, and these are like tasks that we define on our own. So in my user defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now if you notice here, before in every method, I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also the function of the self keyword is basically telling Python that, any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional, we don't really need it, but basically the first attribute of any method is basically what is the instance that the method is invoked upon. So if I say self, I'm telling this particular function that okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, str was It's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1, and this is invoked by the print function. The print basically invokes the dunder str function, which does all of this. Now in the next line, we say print c1.getArea. So this is going to print the value of the what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance, our radius is 2.1. So the getArea function should do pi times 2.1 square. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, anytime that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1.getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1.radius. Now before we move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a dunder method. It's followed and it's preceded by double underscore, as you can see here. Now if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods, and this basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now instance, the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now let's move on to class variables. So now, as we mentioned earlier, all the attributes that are created inside the init function are instance specific attributes, and the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class Circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now if I created another instance over here called C2, and if I check its ID, well, it's something different now. So if you see, each instance basically has a different memory location in our memory. And each instance this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are usually actually declared with the at class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called my class. I'm going to use this at class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of the whatever class we have and whatever we pass in the attribute name. So in this case, I'm going to invoke this method using the class name itself. I'm not going to use an instance name because I have no instance in this particular example. And since this is a class method, it can be invoked using the class name itself. So I'm going to pass Rakesh, and let's see what happens when we do this. As you can see, the first print will basically give us the information of the class itself. It's saying that the class is called my class, and the second print statement is basically a string saying hello from the string name my class with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class my class in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like at class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called my instance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method, which is declared using the @static method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. A static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I've created my instance and I'm going to say dot hello. It should basically print hello world. That's all. In this video, we will continue that discussion on OOP with inheritance. Inheritance is used to describe the relationship between two classes, wherein one class takes the methods and properties from another class. In this relationship, we have something called the base class or the parent class, from which we will derive all or some of the properties and methods. And the class which actually derives these properties and methods is known as the derived class. So you can think of the derived class as a specialized version of a base class. To explain what inheritance is in a basic way, I will show you an example where I'm creating a cylinder class, which is going to be a subclass of the circle class that you might have encountered in the earlier video on OOP. So what we're going to do is create a cylinder class that is a subclass of circle, where we're going to get the attributes radius and get area from circle class, and we're going to add the attributes height and get volume to the cylinder. So right off the start, you can see we have our class circle that you might have seen in the earlier video. So this class circle has the familiar initialization where we are supposed to enter a value for a radius that gets stored in self.radius. Now we also have a description string, which basically is a dunder method that returns a string when we invoke the print command on a particular instance. And we have the getArea method as well. Now if we move on to the cylinder class, you can see that I'm defining this class with the class keyword with the cylinder name, but you can see that I have added a parenthesis, and within it I have mentioned the name of the superclass that I want the cylinder class to be a subclass of. So this is how we actually define a subclass in the most basic way. You enter the name that you want, and you enter the name of the superclass that you want the subclass to be a subclass of in parentheses right after the name. Now next, if you move on to the dunder initialization, the initialization is very familiar, except now we have another attribute for height, which has a default value of 1, just like the radius. So this basically means that we have an option of entering 2 different attributes for our cylinder instances. Now if you see here, there's a line which says super.init. Now this is like, this is a command which we use to invoke the superclass's initializer. So anytime we create an instance for cylinder, we also want an initialization for the circle method as well as a part of our cylinder instance. Next, you can see that much like how we stored the radius attribute in self.radius, we're also storing the height attribute in self.height. Now even this cylinder class has an str method to return a particular string if we use the print function. And finally we get on to a new method that we have defined only for the cylinder class called getVolume. Now if you see the getVolume, it returns us basically the volume of the cylinder that is being described in the particular instance, for which we enter the height and the radius. So if you can see here, what we've basically added extra is a height attribute and another method called getVolume. And the other parts of the circle superclass, such as radius and getArea, are also going to be a part of cylinder, even though you do not explicitly see them anywhere here. And we will see how in the form of an example that's coming up. So let me just execute these classes. Now that that's done, I'm going to create an instance for cylinder. I'm going to store it in cy1, and I'm going to pass 1.1 for the radius and 2.2 for the height. And once that is done, let's just print to invoke the str method. And as you can see, the str method basically tells us the information that it's a cylinder with radius 1.1 and height 2.2. So now let's print what is the value we get when we use the getArea method. Now it's important to note getArea was not explicitly defined in the cylinder subclass, but it's a method that is a part of the circle superclass. And we can see that we can actually access methods that are part of the superclass simply by accessing any other method. So if we use the .getArea, you can see that we get a value for the area of the cylinder. So this area is basically the area of the circle face of the cylinder, the top or the bottom. Now let's invoke the subclass specific method, which is the getVolume method, in a similar manner. As you can see, just by invoking this method, we get the volume as well. Now, if we want to see what is the radius and the height, we can just do a simple print statement followed by cy1.radius, cy1.height, and it gives us both of these values, as you can see here. Now over here, what I'm going to do is create another instance of cylinder, but I'm not going to pass anything for radius or height. So basically, it's going to take the default values for radius and height, which was 1 and 1 respectively. So once I print, this statement is basically going to print the str method, or whatever we stored in the str, which is basically the description of the object followed by what is its radius and height. This method will give us the area, and this method will give us the volume. So once I execute this, as you can see here, this is what we get, and this is what we expect as well. So now in this example, what I'm going to show you is now I'm going to go back and I am going to create another instance for circle. Now this is the superclass, of course, and I'm going to give it, and since the superclass has only one option, one attribute that we can enter, which is for the radius, so I pass 3.3, and I'm going to print what happens when I just print this instance. It's going to basically give us whatever was a part of the str method. After that, I'm going to print isInstance. This is basically a check on whether C1 is an instance of this class circle, and next I'm going to check if C1 is an instance of its subclass cylinder. Now when I execute this, you can see that this is what this is the str method that gets printed. But if you see here, you can see that it says C1 is indeed an instance of circle when it says true over here. But when we look at the next line, is C1 an instance of cylinder? It says false, and this is obviously because a superclass object is never an instance of a subclass object, whereas vice versa it would be true. Now in the next part of this video, what we're going to do is look at the different types of inheritances in Python. So there are basically 5 types of inheritance in Python. There is the single inheritance, there's multiple inheritance, multi-level inheritance, hierarchical, and hybrid inheritance. So we will go one by one and see each of these examples. Starting off, we have the single inheritance. This is simply where we have one base class and one derived class from that base class. So this is just simple single inheritance. And in this example, you can see I have a class called country where I have a method that I have defined called show country, which is basically going to say print this is India. It's basically going to go print this every time we invoke this show country method. Then we have a class called state, which derives from the superclass called country, where we have a method called show state, which is going to say print this is state every time. So you can see I created an instance of the class state, and through that instance I can access the superclass and the subclass methods over here. Next we have the multiple inheritance, and this is when a derived class contains more than one base class. So let's look at an example to understand this. So if you can see here, I have a class called student with 2 methods defined called method 1 and method 2. In method 1 we can pass 2 attributes, SN, SNO, or I think this is supposed to be like an ID, I guess, like SN number, and we have S name. So this is basically 2 attributes we can pass that are probably descriptors for a student. And in the next method you have basically 2 print statements which says student number, and then they will print the student number, and it will also print the student name. Next we have a class called marks. This is also so these 2 classes are basically what our super classes are going to be, and we're going to derive a third class from these 2. So this second class is a class called marks, and we have 2 methods again. One method is called set marks, which has the option of putting in 2 attributes, M1 and M2, both representative of the 2 marks, and we store them in self.mark1, self.mark2. The second method is put marks, which is going to print the marks, namely mark 1, and then it's going to tell us how much marks are there in the first subject, for example, and another print statement doing the same thing for the second subject, or mark 2. Finally, we have a third class called result, which derives from 2 classes, marks and student, as you can see here. In my parentheses, I've passed in marks and student. Both are super classes, and our class result is going to derive from both of them. This is an example of multiple inheritance. And within this class result, I have 2 methods specific to this derived class called calc, wherein I'm going to basically calculate the total marks of the total marks, which is basically the addition of mark 1 plus mark 2, and then I'm going to have another method called put total, which is going to print me what is the total. So if you can see here, I have created an instance of this derived class called result. I'm storing it in R. Then I'm going to access method 1, which is obviously a method from the first superclass called student, and I'm going to store, okay, so his name is, I guess, Lucky, and he has 60 marks. Secondly, then I'm going to do our set marks, which is the method from the second superclass, which is going to set the marks respectively. So you have Lucky student, and his ID is 60, and he has got 50 and 60 marks respectively in, say, the first 2 subjects. And finally, I'm going to access the derived class method called calc. So this is going to do the sum. Finally, I'm going to also do our method 2, which is going to print our student number and his student name. Next, we're going to have put marks, which is going to tell us the what are the individual marks for mark 1 and mark 2. And then finally, we're going to print the total marks with put total. So once I execute this, you can see here it says student number 60, student name Lucky, marks 1 is 50 as I had written here, marks 2 is 60 as I passed here, and then total is 110, which is basically 50 plus 60. Our next type of inheritance is called multi-level inheritance. Now multi-level inheritance can be assumed as where you take a superclass, let's call it A, and you derive a class B from that class A. Now what if we derived a class C from B, and we kept doing this? So until, say, a class E. Now each of these steps is in its own an inheritance, but this whole relationship can be described as a multi-level inheritance. So let's take an example again. So this time I've defined a class called student, where I have defined 2 methods called set stud and put stud, or you can call it set student and put student. In my first method, I have 2 options of adding 2 attributes. Again, this is the student number, this is the student name. In my second method, I am going to print what is the student number and what is the student name. Finally, next we have another class called marks, which derives from the first class called student. This has two methods called setMarks, where I'm going to again get the option of adding two integers for m1 and m2, which is going to represent mark 1 and mark 2. And finally, I have putMarks, the method which is going to print mark 1 and mark 2. Finally, I have another class called result, and this, if you see, this derives from marks. Now, if you see this relationship, you'll notice result derives from marks, whereas marks itself derives from student. And this is an example of multi-level hierarchy. And even as a part of this third class, we have its own methods called calc and putTotal. Calc will calculate the total as we had seen earlier, and putTotal will basically print that total. And we're going to do a very similar operation. We're going to create an instance of this third class result and store it in R. Then we're going to do we're going to set the student details, his student number and his name. We're going to give him his marks 50 and 60. We're going to calculate what are the total. We're going to say, okay, now put the details of what is the student's number and name. We're going to also display his marks, mark 1 and mark 2. And finally, we're going to display the total marks. So let's execute this. And if you see, it's basically the similar operation that we did earlier. But the only difference is, in the earlier example, our third class result was derived from marks and student together. So this was an example of multiple inheritance, whereas in this example, the result class derives from marks and marks itself derives from student. So this is an example of multi-level inheritance. Finally, we have, penultimately, we have as our fourth example of inheritance called hierarchical inheritance. Pardon my mispronunciation, it's hierarchical inheritance. So in this case, a base class basically will contain more than one derived class. So let's look at an example of what we mean here. So I have a class called 1 where I have defined a method called display, where what I'm going to do is I'm going to store self.x is equal to 1000 and self.y is equal to 2000. Then what I'm going to do is I'm going to print a statement saying this is the method in class 1. And I'm going to say, after that, I'm going to print another statement saying value of x is self.x, which is going to be 1000. Then I'm going to have another print statement saying value of y is self.y, which is going to be 2000. Finally, next I have another class called 2. This is going to derive from class 1, as you can see here. And in this class 2, I have defined another method called add. And in this method add, what I'm going to do is I'm going to first print a statement saying this is the method in class 2. And then I'm going to actually print the result of x plus y, which is 1000 plus 2000. Finally, I have another class called 3. And this is also deriving from 1. So if you notice, we have one parent class called 1. And from this one parent class, we're going to derive two different subclasses called 2 and 3. So this is an example of hierarchical inheritance. Now in this class 3, what I've done is I've defined a multiplication method. What I'm going to do is print, first of all, I'm going to print this when I invoke this method, that this is the method in class 3. Finally, I'm going to say, I'm going to print the result of x times y, which is 1000 times 2000. So if you see, I am going to create an instance of 2 and I'm going to create an instance of 3 and I'm going to store them in T1 and T2. Now since T1 is an instance of 2, so I can access its methods add and I can access its methods display. So I'm going to use T1.display, and even in T2, since it's a class, it's an instance of class 3 and this also derives from class 1, I can also access its method display, but now I cannot access add, but I can access multiply. So if you see here, I access add through T1 instance, since add is a part of class 2, whereas multiply is a method in class 3. So I access it in its respective instance, which is T2. So if you see here, now once I execute this, what you will get is basically the results. So first of all, it will basically display the method from class 1, which is the display method. It will display the values of x and y. And since I've done this twice from two different instances, it will basically show a repetition over here. Finally, I've done the addition, and since this is a method in class 2, it is going to say as much, that this is a method in class 2, and then it's going to say x plus y is 3000. And now multiply is a method in the third class, so it's going to say this is a method in class 3, and it's going to tell me what is the multiplication result. Finally, we have what is called hybrid inheritance, and this is a combination of multiple plus multi-level inheritance that you saw earlier. So let's again understand this through this example. So we have a class called student, where we have a method called setStudent. Again, two attributes we can pass here for student number and student name. Next, we have another method, part of the class student, called putStudent. So this will print us the student number and student name. Next, we have a class called marks, and this marks inherits from student. So we have a method in class marks called set marks, where we can pass two attributes for mark 1 and mark 2 respectively. And as we had seen earlier, we also have a put marks, which will display the marks for marks 1 and marks 2. We have a class called practical. This practical is basically another superclass. If you see here, since this does not derive from anything, it is a superclass on its own. And what it does is it has two methods, get practical, and we can pass an attribute for p1 here, and we store that in self.p1. And then we have an attribute for put practical, which will print us the practical marks, whatever we passed for this attribute in p1. Finally, if you see, we have a class called result. Now in this result, we are going to derive from marks and practical. But if you notice here, marks itself is a subclass of student. So this is an example of multi-level inheritance. Whereas since result derives from marks and practical both, it is also an example of multiple inheritance. So if you notice here, this is an example of multiple and multiple level inheritance, which is basically what we call hybrid inheritance. And as we had seen earlier, this result class will have a calc method to do a total of the marks. In this case, mark 1 plus mark 2 plus the practical mark p1. And we have a put total method, which is basically going to print us the total. So now we're going to create an instance of this result. And through this instance of result, we're going to first invoke the parent class method called setStudent, which is the second level parent, basically the student class setStudent method. So we're going to setStudent here. We're going to say 60 is the student ID and name is Ash. Then we have setMarks, which is again the second level parent, which is a student class, where we set the marks. Finally, we access this getPractical. Now, if you notice, getPractical is part of the practical superclass. So in this, we store the third subject of the practical marks 100. Then we calculate the total and we put first the student details, then we put the individual marks, then we put the practical marks, and finally we enter what is the total. So let's execute this. And if you notice, you will see here student number is 60, student name, and all the basically whatever details we wanted is shown over here. In this video, we will continue our discussion on object-oriented programming with the topic of polymorphism. Now, the term polymorphism in OOP refers to the ability of an object to adapt the code to the type of data it is processing. Polymorphism is one of the key concepts of Python, and it is also a built-in feature of Python. An example to get us started on polymorphism would be how we use the plus operator. We use the plus operator not only for arithmetic additions, but we also use the plus operator for stuff like string concatenations or joining two lists together. This example, where we are able to use the plus operator for different operations, is an example of polymorphism. To show you what I mean, I have basically done a simple addition operation here, where I'm adding two variables, number 1 and number 2. When I do it on integers, it basically adds 1 plus 2. Now when I use it on two strings, str1 and str2, which contains Python and programming, two separate strings, and when I use the plus operator on these, you can see what it does here. It forms one string containing both of these individual strings. So this is basically the plus operator showing polymorphism, and is one of the simplest occurrences and yet most common occurrences of polymorphism in Python. Another example of polymorphism would be through the length function. The length function in Python is something that we use a lot and over multiple data types. Depending on the data type that we use the length function for, we get a different value or a different sort of information from the length function. Now, if you see here from this diagram, when we use the length function on a string, it gives us the length of the string. When we use the length function on a list, it gives us the number of items. Whereas if we use the length function on a dictionary, it gives us the number of keys. So this is, well, another example of how we have polymorphism in a function. Now what we're going to do is look at the different techniques through which we can enable polymorphisms in our code. Our first example that we are going to look at is through method overloading. Now, method overloading in its traditional sense, where we can have a method with the same name, more than one method with the same name in the same class, is not exactly possible in Python. So if we have multiple methods with the same name in a class in Python, which may differ in types and number of arguments, are not allowed and not supported in Python. In fact, if we did something like this, where we created a method with different say types and number and arguments, but having the same name in the same class, then what Python will do is it will only recognize the last defined method, and it will not recognize any of the earlier methods with the same name. But we can simulate polymorphism through method overloading by using default arguments in a method. Now, for example, what I'm going to show you here is an example where I have a method called sum. Now, by default, it has three attributes that you can pass through this method. A does not have a default value, B does not have a default value, but if you notice, C has a default value 0. So this is a simple example where I'm going to show you that the sum method is going to be used in two different cases. In one case, we're going to simply add two numbers, and in another case, we're going to use the sum method to add three different numbers. So we have this class overload demo, within it a method sum, and I have three attributes. A and B are supposed to be given by the user since they do not have any default values, whereas C has a default value 0. So if you see here in my first case, I first of all created an instance called OD for the class overload demo, and what I'm going to do is I'm going to store the value of the sum of 7 and 8 in the variable sum. Now, if you see here, I have not passed a third argument. So what this method is going to do is it's going to take the value of C as 0 by default. So it's basically going to do 7 plus 8, and it's going to give us the sum for 7 plus 8. And in the next instance, I'm going to give three arguments, 7, 8, and 9. So now C will be replaced by 9 instead of 0, and then I'm going to get the sum of 7, 8, and 9. So in this is not a very commonly used thing, but it's basically a method just to show you that we can actually simulate method overloading in Python by using default arguments. So I've basically shown you how the same method sum has been used to do the addition of 2 digits, and then in another instance is doing the addition of 3 digits. It might look very similar, but you'll basically notice that by having this third attribute C have a default value of 0, I have induced some form of polymorphism through method overloading. Now, the next way that we can induce polymorphism is through inheritance, which is called method overriding as well. Now, method overriding gives us the ability to change the way or change the implementation of a method in a child class which is defined already in one of its superclasses. Now, if there is a method in a superclass, the method having the same name and same number of arguments in a child class, then the child class method is going to override the method in the parent class. So what we do is when a method is called with the parent class object, the method of the parent class will be executed. Whereas if we call the method using the child class object, the method of the child class will be executed and it will override the method in the parent class. So the appropriate overridden method is called based on the object type, which is an example of polymorphism. So let's look at an example to understand this. So we have a class called person, and we have defined what we're going to define. The initializer is 2 attributes which we have to pass called name and age, and we're going to store them in self.name and self.age. Now we have a user defined method called display data, where we're going to print if this display data has been called through the parent called person. If it's going to be called through the parent class object, then we're going to print in parent class display method, and then we're going to print the name and age that we have entered. Now we have another class called employee, which is going to be a derived class on person. So it's going to it's also going to have an initializer, and this constructor will basically what this initializer will have is it'll have an constructor for the superclass, where we're going to do this the same initialization that we do in the superclass, but we're also going to store another attribute called ID in self.employeeID. And if you see here, we also have another method called display data, which is the same named method from person. But now if you see in display data, I have almost the same information. I'm going to print the name, I'm going to print the age. But if you see the first statement, I'm going to say, if I'm going to call this method from the employee object, then I'm going to say in child class display data method instead of in parent class display data method, to say that basically I'm invoking this method from the child class object. And I'm also going to print on top of the whatever I'm printing before, I'm also going to print the employee ID. So if you see here, I have created an object called person, which is an object of the class person with the information of name John and age 40. And then I'm going to display this. Now next I'm going to create an object called emp, which is the child class employee object, which is going to now have the same information of John for the name and age 40, but now it's going to have an employee ID. And then I'm going to store this in emp, and I'm going to display the data for this child class object, and we will see the difference in how the display data is differing from the earlier case. So when I execute this, you see in the first case it says in parent class display data method. So this display data has been called through the parent class object, and I'm only going to show the information of name and age. Whereas when I invoke this method from the employee class object, it's going to say it's going to specifically say that it's a in child class display method, and then I'm going to say the name, age, and also the employee ID over here. So this is the difference between how display data has been used in its parent and its child class, and this is basically the example of method overriding. Now our next example of polymorphism is going to be through operator overloading. And operator overloading is the ability to overload the operator to provide extra functionality in addition to its real or core operation. And operator overloading is also an example of polymorphism, as the same operator can perform different actions. The earlier example of where we use the plus operator for different operations is an example of operator overloading polymorphism. Now when is operator overloading required? Well, anytime you want an operator to perform a different function for you in your custom objects, you would basically do operator overloading. Now an example of this would be what I'm going to show you below. So if you see this class called point, it has an initializer where I'm going to store two attributes x and y in self.x and y, and in self.x and self.y. Now I'm going to create one object called p1 where I'm going to create point 1 and 2. So you can think of this object as basically like a coordinate, x coordinate 1, y coordinate 2. This is one point, and another point called x coordinate 3, x coordinate 4. I'm going to call that p2. Now I want to print p1 plus p2. Alright. Now if I try to execute this, you will notice an error. It says unsupported operand types for plus, point and point. This basically means that plus does not know what to do when it's given an object of this type. It has no idea what to do. Whereas what we want it to do is add the x coordinate from this point and the x coordinate from this point. So we want it to do 1 plus 3, and we also want it to do this y coordinate plus this y coordinate, or 2 plus 4. And then we want to print basically like something like 4, 6, or the addition of the 2 points, or the vector addition of these 2 points. So this is what we want this plus operator to do, but the Python does not have any inbuilt feature for the plus operator, and we are going to have to basically do some operator overloading to create a polymorphism on this. So let's see how we can do that. So to do that, first of all, we have to understand that all operators in Python have internally defined methods to provide functionality for these operators. The operator, or the special method to provide functionality for the plus operator in Python, is the add method. And whenever the plus operator is used, we are basically internally invoking the add method. So these sort of internal methods that provide functionality for the operators are part of a bigger class of methods known as magic methods. And these magic methods are automatically invoked whenever its corresponding operators are used. So if we want to change the operation for the plus operator in this example, we are going to have to use the add method in this case. And since it's a magic method, magic methods are also are basically what we saw earlier in the form of dunder methods. So magic methods are going to be invoked using double underscore, a prefix and suffix to it. So similarly to how we defined an init method or an str method, we are going to also invoke the add method using the same double underscore before and after its name. So now let's see how we're going to do this. So if you see this class, I have now my class point, and I have the same initializer where I'm going to store x and y. Now I am going to define on this add magic method, I am going to override the normal functionality of plus, and I'm going to give it a very specific function where I'm going to say for two different objects, you're going to add its the first part or its so-called x coordinate with the other x coordinate, and the y coordinate with the other y coordinate, and you need to return this to me in the form of a similar object. So now when I pass 1 and 2 and 3 and 4, it should return me 4 and 6. As you can see here, I have basically done what I wanted to do by operator overloading. I have changed, or I have overloaded this plus operator using this add magic method, and I have created a new functionality for this add function for these 2 points, 1 and 2, 3 and 4. Now I'm able to add 1, 2, 3, 4 in the way I wanted to. So now that you saw how we did operator overloading, I'm just going to show you a list of similar magic methods for different operators that we are familiar with. So the plus operator already we've seen has the add method. Then we have the minus operator with the sub method. And similarly, we have for all of these operations such as multiplication, division, we have its respective magic methods. These magic methods are again prefixed with 2 underscores and suffixed with 2 underscores, and they are also called dunders in Python. So this is how we would do operator overloading in Python for whatever operator we want. Similarly, we can do this for like comparison operators and for unary operators as well. So look at this example now where I'm going to overload the multiplication or the asterisk operator. So I've again defined a class called point. I'm going to define an initializer where I'm going to store some attribute x in self.x. Now what I'm going to do is I'm going to overload the multiplication operator where I'm going to basically allow the this asterisk operator to multiply two objects from, like, for example 12 and 5. Usually I can just do a normal 12 times 5, but in this case my object is slightly different. My 12 is being passed through an object of a class called point, and 5 as well in another instance of the same class. Now when I want to multiply these class instances, like the multiplication operator does not perceive these class instances to be integers. So by default it would not be able to multiply what we want to multiply. But when we define or we overload the multiplication operator within our class, it's now able to understand what to do using the attributes of these classes in its respective class instances. So it's able to say, okay, so I want this attribute from this particular instance P1, 12, and I'm going to multiply it with the attribute 5 from instance P2 whenever I say P1 times P2 or P1 asterisk P2. So when I execute it, it will give me 12 times 5. Similarly, I can also do this for the greater than operator over here. So I have a class called person where I'm going to define an initializer where I'm going to pass name and salary and store them in self.name, self.salary. The GT method is basically the greater than method, magic method, and it's going to we're going to use this to overload the greater than operator. And now again, using this greater than operator, I'm able to basically say object 1 greater than object 2, and I'm basically able to check through this, and if object 1 is greater than object 2, it will basically tell us if it is true or false, or basically whatever like we want to know. So basically the print statement will check for object 1.name, and it will say earns more than object 2.name if in case object 1 is indeed greater than object 2. So when I execute this, you can see here, my first information says John is earning 4,500 of some units, Natasha is earning 6,000 of some units. So it will say John earns more than Natasha. Well, it's false because object 1 is not greater than object 2. So since 4,500 is not actually greater than 6,000. And this is the check that I'm doing by overloading the GT operator over here, where I'm returning the Boolean value of what is greater, self.salary or other.salary. Self being the first object in any comparison. So if I'm basically any comparison, if I'm doing, say if I'm doing 5 greater than 6. So what the GT will do is this will be the self object and this will be the other object. So this is what I'm doing over here. I'm checking self.salary with other.salary in the form of these objects. And it's basically the same way that we are able to do 5 plus 5 through these class instance objects that you saw earlier, or 12 times 5 that you saw earlier. So this is all examples of operator overloading in Python. In this video, we will be taking a brief introduction into what is a function. So a function in Python is a group of related statements that performs a specific task or tasks. Now, functions help break our program into smaller and modular pieces of code. And it's very good and very convenient to use functions to make our code organized and manageable, especially as our overall program grows larger. It also helps us to avoid repetition and makes the code reusable. So let's look at the basic way of defining a function. So this is a basic function that I'm calling fun_name. Alright. Now the rest of the function, or whatever the task is going to be performed by this function, will be written over here with an indent, of course, as a standard when it comes to Python. So I'm going to define this one something in double quotes. So don't worry about what this is right now. This is a doc string. Don't worry about what this means, and I'll explain it to you just in a short bit. Alright. Now the rest of the statement, the rest of it will obviously be what this function will do. Let's include a simple print statement. Alright. Let's done here. And let's call this. So of course, now once you define the statement function, to call the function, you just have to use its name like this. This is how you call a function. So as you can see, when I call this function, it should print the statement hello. Now let's look at some of the like what happened over here. So we've used the keyword def to define a function. We give it a unique name, which makes it with which we uniquely identify this function. And also, once we've done this, we can give this function a particular header. It's called a doc string. So what this doc string is basically something that we include in triple quotes over here, just after the def keyword. And this is like a brief. We can use this to give a brief, give brief information into what our function is doing. So we can say this is this function performs addition, this performs subtraction, or whatever, like some basic information as to what our function does. So we can use a doc string for that. Of course, this is an optional thing. This does not have to be, we don't have to include this as well. Alright. But for the sake of this, let's just keep it here. After that, of course, rest of the function will contain whatever tasks we want to do with it, and that will be indented. Finally, we can also include a return keyword. And what the return keyword does is, at any point you find the return keyword in a function, you immediately leave the function and you go back to where this function was called. Okay. So now let's see. Now there's also one more important component of defining a function, and that's parameter. Now if you've noticed over here, within these parentheses, I did not include anything. This is like an empty parenthesis, opening and closing. What if I said if I included some a and b over here? So what this means is, whenever I call this function, I need to pass two parameters, a and b. These can be like strings or numbers or whatever. But now it becomes almost mandatory that I pass these two things for my function to work. So let's define a function where I'm going to add a and b. So instead of this print statement, let's do this. I create a variable c, and in that I'm storing a plus b. Alright. And then I return c. So you can use a return, and you can return certain like variables along with the return statement. So I'm saying not only return from this function, but also give an output or return an output called c, which is the addition of a and b. Now how do we use this? Well, now instead of just calling the function like this, I'm going to include parameters. So I'm saying pass 2 and 3 to function name, where 2 will take the place of a and 3 will take the place of b. Alright. What will happen now is addition will take place and we will get returned the result. So let's see what happens now. As you can see, 2 plus 3, and I got the addition of 2 plus 3, and it returned me 5. So yeah, this was like a basic usage of a function and parameters. So of course, we can, if you want to know like what the doc string of a particular function does or says, you can use this statement. So let's say it's very important to like just keep a note in your while you're going through this or while you're learning that whenever we use some sort of a function which has double underscore, right? This is like a built-in command provided by Python within the Python library itself. So these are like built-in commands to check certain details. So I want to check what is a doc string, and this is how I do it. So let's do print. Let's print what is the doc string over here. This is a doc string. So this is basically what I wrote over here. I can change this to this, like this does addition, for example. Alright. Now this will say this does addition when I execute this line. So this is the way to check what is a doc string. Anyways, so now that you have seen a basic function or two basic functions that I defined for you and how we use them, what a parameter is, let's look at another concept that we call scope and lifetime of variables. So scope of a variable is the portion of the program where the variable is recognized. Alright. Now a parameter and a variable that are defined inside a function are not visible from outside the function. This is a very key thing. So if we define something within the function, we can only use it within this function, and we cannot use it once the function has already been executed, so as to speak. these variables and these parameters have what we call as local scope, since they are only recognized within a particular function. Now, the lifetime of a variable is the period throughout which the variable exists in the memory itself. And it's very important to note that lifetime of variables that are defined inside a function are as long as the function executes. Once we return from a function, whatever we have defined within it are destroyed. So when we use a function, it will not remember the values of a variable from a previous iteration of a function call. So let's try to understand this example or this concept using certain examples. So out here I have defined a function where I'm going to create a variable my underscore var, my variable, and I am going to store the value 10 in this, and then I'm going to print. So whenever I call this function, I will always create this variable, I will store 10, and I will print the value of this. Alright. Now, what I'm going to do is, I'm not only going to create this my var inside this function, I'm also going to create a variable outside. So you see there, now you might be confused as to, okay, how is the behavior going to be? Because outside the function, I have created my var with a value 20, but inside the function, I will always define my var as 10. Okay. Now I'm going to print. So what I'm going to first do is, I'm going to execute this function that I created initially, where I store the value of 10 in my var, and then I'm going to print the value of my var that was present outside the function. Let's see what happens. You can see two different things happening. So when I execute this function, it prints the value inside the function as 10. But when I print the next line, which says, okay, now get the value of my var, it actually prints a value of 20. And this is a very key concept, because what's happening here is when I initially call my function, within this function, it creates a variable called my var, and it prints the value as 10. And the moment my function has been executed, it destroys this variable. And the variable which contained the value 10 is of course now destroyed, and all we have is the my var that contains 20 from the outside. And when we print that, we get its respective value as 20. So you can also think of it like this. The my var that is present inside this function is different to the my var that we create outside. So the scope of the my var within this function is local only to this function. And once the function is executed, that variable is destroyed. Alright. Now let's look at another case, or the other side of this case, where say we're dealing with variables that have a global scope. How do we deal with them? So let's create a variable called myvar. Alright. And I say I store 100 in this. Alright. Now if I define a function, I've stored myvar. Let's say I define a function. Define underscore, say again, same name, where what I'm going to do in this is I am going to print the value of whatever is there in myvar. Okay. So let's do print, value of variable is value stored in variable is, okay. Let's myvar. So let's see what happens when we do this. Let's call this function fun underscore name. Let's see what happens here. So as you can see, the value, I stored a value 100 in myvar and I've called it inside the function. And this is because since I've defined it outside, I can use it inside as well. Now what if I try to change the value of this variable inside the function though? So let's see. If I did this, and now if I try to print, let's see, is this allowed? No, it's not allowed. In fact, I get an error. It says local variable myvar reference before assignment. And without going too much into detail, what it's saying is that the variable inside over here is still local to this function. And I have not defined this myvar as a global variable. So I cannot make changes to it within this function right now. And to change that, I can use the global keyword. What if I did global over here? So if I did global, and now if I said, okay, global myvar, and I declare this variable as a global variable. Now if I do this, now if I do the same incrementation, now let's see what happens when I'm trying to do this. You see, I get the value 101. This is exactly what I wanted. And that is because I've defined my variable to be a global variable within this function. So I can, in fact, make changes to it within this function. So this is how we use the global keyword and global variable. Also, just to make a quick note, there are three types of functions. the three types of categories in which we can divide functions. First one being built-in functions. These are the ones that are built into the standard library of Python. The other is user-defined functions, that is the ones which we define ourselves. And the third type is called anonymous functions. They're also known as lambda functions, and this is something that we're going to cover in a separate video. Now let's talk about the arguments that we pass in Python. So there are four types of arguments that Python user-defined functions can take. First one being default, the other one is required, then there is keyword, and then there is variable number of arguments. So the default argument is when, say, if I defined a function fun underscore name, and I'm saying a comma b, right? But what if the user has not say I want a default value of a and b each time when I use this function. So in the case where if say I don't pass a value for a and b, like this will always be used. So I can just say a is equal to 2 by default and b is equal to 3 by default. And then within this function I will say c is equal to a plus b and then return c. So I do this, and if I say fun underscore name, and in case I don't pass any arguments here, let's see what happens. By default I get the answer 5 because by default a is 2 and b is 3. But this is not fixed and I can always change this by passing my own values here, 5 and 6, and in this case I should get 11, as you can see here. Now the next type is required arguments, and when we are defining a required argument, we just simply do not use the equal to sign for the parameters over here, and this basically it makes it so that now anytime we call this function, we have to pass something over here. So now if I try to pass like this, I won't get a default value. Then that's because well, there is no default value and it needs an a and b. So I have to pass it a 3 and say 4. Now it should give me 7, as you can see. The next type of argument that we'll be talking about are the variable number of arguments. So let's look at an example here. So what I'm doing in this particular example is I'm defining a function called mySum, where I'm passing some parameter called myIntegers, and I'm doing something out here. And what this does is, it will take the values of a particular collection of objects, and that's called myIntegers. And each value, I'm going to keep adding it to each other, and I'm going to result a particular sum. I'm just going to result the sum of whatever is there. So in this case, what happens is I'm creating a list 1, 2, and 3, which contains 1, 2, and 3, and then I'm going to print the summation of whatever is there. So it should give me 6. Now, the problem in this case is that each time when I'm going to perform this function, I have to create a separate list where I'm going to store these objects. But what if I do not know what exactly I'm going to pass here? What if I don't know if it's going to be a list of objects or what is it going to be exactly? Well, in that case, I can use a variable number of arguments. So it's like a variable keyword argument. So what we use here is a specific way of passing keywords, and we do it like this. So I say define my underscore name, and I use an asterisk. Now I give it any name. This can be args, this can be integers. It doesn't really matter what this is, but this is the key, the asterisk here, and this tells us that whatever we pass here is now we're supposed to create an iterable out of this, and then we can perform whatever task we want. So let's just since I've already created one here, let's see how I'm going to use it in this case. So as you can see, I'm creating a particular variable argument function over here, and I'm doing the same task. I'm just going to keep performing I'm going to add whatever I pass over here. But now when I'm calling this function, I don't need to create a separate list as I did over here. I'm just passing all the numbers that I want to in the form of it's pretty much like a tuple. So I'm just passing these numbers here, and what this function is going to do is going to create an iterable out of this, and then we're going to iterate over it. As you can see, that's happening over here. And I can keep I can just keep so since I've done it for 1, 2, 3, and 7, the summation should be 13 in this case. I can add another number here just explicitly, just like this, and you can see the value will change. And that's because this is a variable argument method of creating a function. Now the fourth type of function arguments is the variable keyword argument. So let's look at what is the keyword argument now. So I have defined a function here called the concatenate function, and let's see what I'm going to do with this. So in this, I have passed a keyword argument. I've said that, okay, this is going to be a keyword argument function, and what I'm going to do in this is I'm going to create a blank string, and what I'm going to do is I'm going to add or I'm going to concatenate certain strings that I'm going to pass to this function. So in this example, I have passed Python and is and cool and an exclamation mark, all separate strings. And what I'm going to do in this function is I'm going to join them together. And I'm going to create one whole string out of it. Let's see what's the result. Python is cool. So of course, like, if I had to add something else, like Python is say, cool, and say, I just wanted to say hello and say one more string. I can add it just like this. I don't have to like define a fixed number of arguments. I can pass any number of arguments I want. And this works exactly the same as variable. In the only difference is instead of positional arguments, we're using keyword arguments over here. Hello, bye. Like this, it doesn't really make sense, but just to show you, as you can see. So this is how we use keyword arguments. In this video, we will be learning about exceptions. Exceptions are errors that are raised during the execution of a program. When an error occurs, Python generates this exception that can be handled, which avoids our program from crashing. Python has many built-in exceptions. However, we can create many user-defined errors or exceptions as well to catch whatever errors we're looking for in our program. So when an error occurs, Python interpreter raises an exception and stops the current process. And it passes it to a calling process until the exception is handled. And if this is not handled, the program will crash. Some of the built-in exceptions are like IO error, in the case when a file cannot be opened, or import error, Python cannot find the particular module being imported. And there are so many similar, exceptions that are built in Python for the appropriate cases. Now, before we move on and see how we raise these exceptions, let's look at the difference between an exception and a syntax error. So for that, I will be using an example where I will be dividing something by the number 0. Now, of course, this is not possible. So let's see how Python handles this particular problem. Well, it raises what we call a zero division error. And this is an exception that is built in Python whenever we try to divide something by 0. Now let's look at the difference between this exception and a syntax error. So this is the same statement, except I'm going to add this extra bracket, which does not make sense syntactically in this. Now, if I try to execute this, as you can see, we get a different type of error known as the syntax error. And it says the unmatched closing bracket. So this is what a syntax error looks like an extra bracket or a comma that basically makes the line unreadable to the interpreter in the first place. So the interpreter doesn't even get to the point where it needs to figure out that there's something being divided by 0. It doesn't even get to that point because it finds this extra bracket and it cannot execute this line at all. So that is like the difference between an exception and a syntax error. Alright, now for our first case of how we raise or how we handle exceptions, let's look at the keyword raise. So for this example, what I will be doing is I'm going to take this variable x, alright, and I'm going to store a value 10. And what I'm going to do is I'm going to check for a condition. If x is greater than 5, then I'm going to raise this exception using the raise keyword like this. And in case this condition is met, if x is actually greater than 5, I want this particular message to play out in my exception. So let's see what happens when I execute this. As you can see, the exception is raised because x is indeed greater than 5, its value is 10, and the error message says as so, that x should not exceed 5, the value of x was 10. So this is an example of how we can raise an exception. And as you can see, when a condition was met, the program comes to a halt and an exception was raised. Now let's look at another type of handling exception, where we use the assert statement. So when we use the raise command, we waited until an error occurred and our program crashed midway, right? What if we want to check if a condition is met? And if this condition is met, then the program can continue. But if the condition turns out to be false, then we want a particular error, namely the assertion error exception, to be thrown to us. So we can use the assert command in such a case. So in our example, we will be checking whether the system that we are working on is actually Linux or Windows 32. So let's see. First of all, let's import a library called sys. This is it's a library where we can access system information. One of the modules in that is one of the functions in that is the platform. It basically tells us what system are we working on. So we're working on a Win32 system. Okay. So let's use the assert keyword. All right. Now we're going to check if Linux is what we are working on, and in case it is not, then we want an error message, and this will be the error will obviously be an assertion error because we are using the assert keyword. So this is how we use the assert statement. And if we execute this, as you can see, we get the assertion error because sys.platform contains Win32 and not Linux. And so we got this assertion error. So if we change this to check for Windows system, we won't have any error when we execute this, as you can see. So this is the example where we use the assert statement. Another way of handling exceptions is by using the try and except block. So this is probably one of the most common ways of handling exceptions in Python, where we use a try keyword and an except keyword. Now within the try keyword, as you can see here, we have a chunk of code which we're going to check. And if everything is fine in the try keyword, then this is perfect. So we don't need to move on to what we call the except part of the try and except block. But if say there was an error in the try block, then we move on to the except block where we're going to run the part of the code in the case we find an error in the try block. So first we check the part of the code that is under the try block, and if there is an error, we move on to the except block and we run that part of the code over there. And in the except block, that is where we handle our whatever error that might get thrown our way in the try block. Okay, let's look at an example at how to use this technique. So I have a basic function out here. All right. It's defining a function called Linux interaction. What this is basically doing is that when I call this function, I want to do an assert check. I'm going to check if Linux is the system I'm working on, and if it is not, then I want this error to be thrown. Okay, and so yeah, let's see what happens in the case. And if this assert statement is actually passed, then we will move on to this statement. So you could look at it like this: when I call this function, it will first check for this assert statement. In case something wrong happens and we get an assert error, then we do not move on to this line. So we only get this printed. But if this assert statement passes, then we move on to this line and we get print doing something. Okay, so let's see. Now I'm going to call this function out here. Let's see what happens here. As you can see, I get an assertion error because obviously this is a Windows system and not a Linux system, and I get this message. Okay, now let's see what happens when we use it in a try and except block. All right, so now I have a try block over here in which I am going to try this function, Linux_interaction. If in case I find an error, I immediately jump from the try block into the except block. Now you see the slight difference in how we handle this. Like what happens. So as you can see, when we use the function explicitly, we directly went to what we call an assertion error. But when we use a try and except block, we will not use the assertion error because we are leaving the try block immediately and we're going to go into the except block where the only thing we're doing is printing the statement. As you can see, we are not on Linux, found some error. Okay. Now what if we wanted to catch the error within this function itself, which was the assertion error? And we can do that explicitly like this. So now what I'm doing is I'm going to try, all right, and it's going to catch an error in this, right? So now in the except block, I'm going to say the assertion error that we found in this function in the try block, we're going to use that in our except block. So as you can see, we're going to print that assertion error. It'll basically print this statement. Function can only run on Linux systems. As you can see here, function can only run on Linux systems. Function can only run on Linux systems. And the next part of the thing was the Linux interaction function was not executed. Okay, so this is there's a key, something very important happening here. When we use this assert statement, the whole program is actually getting executed, right? But when we're using a try and except block, we are immediately jumping on, like the moment we catch an error, we are immediately jumping onto the except statement. And all the handling of the exception is done in the except block and not in the try block anymore. So we have to think of it like this, that the try block is only to check if a particular piece of code is does it have any errors or not, and in case it does, then all the handling that we do is in the except block of this particular statement. Now let's look at another example. In this example, I'm going to try opening a particular file. Now this file does not exist, so I will get a file not found error, and this is a built-in exception. And I'm going to catch that and I'm going to print that error over here in the except block. Alright, so as you can see, file not found, and whatever error I have, I printed over here. Alright, so this is another a file not found error that we caught in our try block, and we're handling it in the except block. Now let's combine both of the examples where we use this Linux interaction and we also try to open a particular file, and we try to do both things in the try block. And since both of these contain errors, let's see what happens when we have multiple errors in a try block. So as you can see in my try block, I'm not only doing this Linux interaction, I'm also trying to open a particular file that does not exist, obviously. So now you might think, will I get 2 exceptions? Well, let's see what happens when we try to execute this. So it's important to note that in our except, we have an except for catching a file not found error, and we also have an except for finding the assertion error that is part of this Linux interaction function. So since both of these are erroneous statements, they will throw exceptions. So now the question is, will we get both of these except blocks, or will we get both of these exceptions? Will we get only one of them? Will we get the first one? So let's see what happens. So as you can see, my error statement is very much like the assertion error that we had done as part of this Linux_interaction function. Function can only run on Linux systems. The Linux function was not executed. So as you can see, that is the one that has been caught, and for some reason the file not found error has not been caught. And this is because this is a very important feature of the try block. The moment we find the first error in our try block, we immediately leave and we do not execute any of the further statements, and we jump into the exceptions and we handle it using the except blocks. So the moment an error was found in this function, we did not execute this part of the statement and we directly jumped into the respective exception. That was the assertion error exception. So this is a key takeaway. So some of the other key takeaways when it comes to exceptions is a try clause is executed up until the point where the first exception is encountered. And in the except clause or the exception handler, we determine how the program responds to this exception. We can have multiple exceptions and we can differentiate how the program responds to each of these. And it's also very important to not use except clause on its own. It's very important not to use a bare except clause. Now finally, before we conclude this topic of exceptions, let's look at the else and the finally clause. So the else clause is used when we want to execute a particular piece of code in the case where we have no exceptions or no errors found. So let's look at this. Just like we had the Linux interaction function, I'm going to define a win_underscore interaction. And this is going to check whether our system is Windows or not. In case it is not, then we get this error message. Alright. And in case it is a Windows system, we print this in the case of when we call this function. So let's again use our try and except statement. Only in this case, we will be using an extra else clause. So we first try this function. In case there's an error, we catch it as an assertion error and we print that error. But if there is no exception, then we move on to the else statement and we print this. So as you can see, we have actually moved on to the else statement and we print this line executing the else clause. And that is because we have found no exceptions over here. So again, it's key to remember that the else clause is used whenever we want to execute a particular statement in the case where we do not find any exceptions in the try block. The finally clause is used when we want to execute something regardless of whether we have an error or an exception or not. So no matter if an exception is raised or if it's not raised, we want this finally block to always get executed. And let's look at let's look at an example of it being used. So I have this block where I'm doing a lot of things. The first thing that I'm doing is I'm going to check for this Linux interaction function, which is going to check, of course, whether it's a Linux system or not. This is I'm doing the try block. Now, if I catch an error, that I want to handle it by simply printing the error over here. And in the event that there is no error, then I will move on to the else statement and I will try this particular block of my statement, which is again that where I'm trying to read a particular file that does not exist. And it's very important that you note that within the else block, I have another try and except block, and this is perfectly legal and it's perfectly valid in our program. We can do this. So think of it like this. I'm first trying this. If I have an error, then I do this and I don't execute this. But if I don't have an error, then I execute this whole statement, which contains its own try and except block. Alright. But regardless of whether I get an error here or not, I will always execute this portion of my statement or under the finally clause. So let's execute this. As you can see, of course, the error is raised in this try block. So we move on to the exception, and that is what is printed over here. And after the exception is done, we move on to the finally. We of course skip this else block because the exception was actually raised. So after that is done, we move on to the finally block where we print this particular statement. Well, that was it for an introduction into exceptions in Python. I hope you learned something from this. And of course, this is just the beginning. Exceptions are something that you would probably encounter a lot, especially when you're beginning. And it's something that you will learn to extensively work with. And that will also help you improve in your programming. In this video, we will be covering the topic of iterators. Now, an iterator in Python is an object that contains a countable number of values, or it's a larger object that contains a countable number of sub-objects. An iterator is an object that can be iterated upon, and what that means is we can traverse from each value and we can manipulate or perform certain functions or operations and tasks using each of the sub-objects or values within this larger collection called iterator. Now, when we're looking at it technically, an iterator is an object which implements the iterator protocol in Python, which consists of the methods iter and the method next. So to begin with, let's look at a simple iterator. We're going to see the example of a list where we're going to traverse through the objects of a list using the for loop. So we have objects 1, 2, 3, 4, and I'm going to print each of these values one by one, as you can see here. Similarly, we can also do the same thing for another iterable known as the string, where we can go character by character, again using the for loop, as you can see here. Another example of an iterable in Python is the dictionary. So let's say I have a dictionary where I have two key value pairs. Key X, which contains the value 1, and key Y, which corresponds to the value 2. Now, when I'm going to do a for loop through this, by default, I will be traversing through the keys X and Y, as you can see over here. And of course, the other types of iterables in Python are like sets and tuples as well. Alright. Now let's look at what this iterating protocol is in Python. So first of all, we take an iterable. It's an object that contains, it's a collection of objects that contain sub-objects. And when we use the iter function, it creates an iterator out of it. So we can, one by one, we can traverse through each of the objects, and we can manipulate each of the objects that is contained in this. And anytime we want to move to the next object, we use the next function. And when we have finally completed all of or we've manipulated or traversed through each of the sub-objects, we encounter the stop iteration exception, which tells us, okay, there are no more objects to be manipulated or iterated upon. So as an example, I will create a list where I will store the values, some simple values, integers 1, 2, 3, 4, 1, 3, 4, 5. Okay. I'm going to create an iterator out of this where I will use the iter function. And I'm going to say let's say this is called my iter. Okay. And I'm going to use the iter function as I had mentioned, and I'm going to pass my list in this. Now, if you see what is my iter, it should be a list iterator at a particular memory location. Now let's use the next function to keep going through whatever is there in this. So of course, the first object should be 1, as you can see. Now when I look at the next, it should be 3, then I should get 4, and now I should get 5 as I use the next successively. Now since I've reached the last of my objects in this collection, now the next time I use this next function, I should get a stop iteration exception that is raised, as you can see here. So this is the basic iteration protocol in Python. Now you might have already gone through the for loop video, and in that I have spoken in quite a bit of detail as to how a for loop performs this iterator protocol and how it creates an iterable object out of, say, a list or a tuple, and how it internally performs the next function, and it breaks out of the for loop once it encounters the stop iteration exception. So for loops are they're very, very similar to your standard iterator, and they use pretty much the same protocol for its functioning. Now, let's do a basic comparison of what is a basic comparison between a generator and an iterator in Python. So in generator, we use a function. We define it using the def keyword, and we define it under one function to create a generator. Whereas in the case of iterators, we use two separate functions, the iter function and the next function. The generator makes use of the yield keyword, whereas the Python iterator does not. In generators, we save the states of the local variables each time we use the yield keyword, and we pause the loop temporarily. Whereas in iterators, we do not make use of any local variables. All we need is an iterable like a list to iterate upon. We may use any number of yield statements in generators, and we do not use yield statements in iterators. Generators are not memory efficient, whereas iterators are very memory efficient. So this is like basic comparison between generators and iterators. In this video, we will be covering the topic of modules in Python. Now, a module in Python, to put it simply, is basically a Python file that has functions and classes written into it and is saved with the .py extension to specify that it is indeed a Python file. A Python program can use one or more modules, and modules can have one or more functions. They basically help us organize our code, and instead of having one long Python file, we can have several files or several modules. Now, modular programming is the process of breaking a large event or task into smaller and more manageable subtasks, and we call these subtasks basically modules. Now, individual modules can be grouped together like building blocks to create a larger application. There are several advantages to modularizing code in a large application, and we will be going through them right now. So first of all, there is simplicity because instead of focusing on a big problem or big task, we can break down the problem into smaller portions of modules. Now, maintainability of code is much better through modules because they are designed to create these sort of boundaries or clear demarcations between different problem domains. There is reusability in the sense that once we create a module, we can use it in different parts of the code or even different applications itself. There is also scoping, and what this means is modules typically define a separate namespace, and this helps us avoid collisions between identifiers in different areas of a program. Functions, modules, and packages are basically all constructs in Python that promote code modularization. You might have already come across or gotten an intro into functions. In this video, we will be going through modules. In another video, we will also cover the topic of packages. To import a module, we use the import keyword. And in this example, what I'm going to show you is a simple function or a simple operation of importing the OS module. This is short for operating system. And as the name suggests, we can perform system tasks through the functions and methods that are part of this OS module. So simply executing this statement will import this module onto our program for us to use. Now, if we wanted to see all the functions that are present in a module, what we have to do is use the dir function. So if we print the dir OS function, it will print us basically a directory of all the functions that are present in the OS module. As you can see here, all of these are basically names to different functions that are part of the OS module. Finally, moving on, another function commonly used with modules is the getCwd function. And what this does is it will give us the current working directory that we are working upon right now. So if I execute this, it will tell me what is the directory that I am currently working upon right now. As you can see, C notebook dir/temp. If we wanted to see all the files in a particular directory, what we can do is use the listdir function followed by giving a path. By default, if we do not enter a path inside the parenthesis, it will basically give us all the files in the current working directory, which in our case is temp. So if I were to execute this, it basically gives me a list of all the files that are presently there in the directory that I am currently working upon. Now, a basic step is creating a Python module. The simplest way to create a Python module is basically creating a Python script with whatever functions and tasks that we want and methods that we want inside whatever module, and saving it with a .py extension. So in my example, what I'm going to do is I have already created a script in Notepad, and I've stored it with a .py extension that contains these four functions: add, subtract, product, and division. I've basically used this code and I've stored it in a .py script, and I'm going to be using this as my as a test module for this particular example. Now, how do we import a module? Now, once that I have created a script, in my example, it will be called mycalc.py, and we've stored it in our directory. To import the module, all we have to do is use the import statement. So if I have to import mycalc, all I have to do is say import my_calc, and now my calc has been imported. So we can use the import statement, or if we want to import something particular from mycalc, we can do from mycalc import. Now we can, whatever, like for example, if we wanted the add function, we can basically just say only add, or if we wanted add and subtract, we can say add and subtract, for example. So this is basically by using from, we can say that we want something from something, but only parts of it. We don't want everything. We can also use from mycalc import, and we can say asterisk to basically say import everything that exists in mycalc right now. So this is another way of importing something from a module. Now to access contents in a module, we have to use the dot operator, and I will show you how right now. So what I'm going to do is, in my example, I'm going to import mycalc as calc. So now since this is the original folder or the original module, but I'm going to give it a shorthand name so that I can easily use it in my code and I don't have to type out my_calc every time. So now I'm going to import this as calc. So anytime I have to refer to a particular method or function inside this script or this module, I will just use this placeholder, this variable name. So now I have two variables, a and b, and I'm storing 20 and 30 in them. So my first what I'm going to do is basically 4 operations. I'm going to print the addition of a and b, and then the subtraction, multiplication, and the division of these two numbers. And each time to do this operation, I am going to use the add function that is present in the mycalc module. So to do that, I have already imported mycalc as calc. All I'm going to do now is invoke these functions using the dot operator that we are already familiar with. So I'm going to say calc.add, and then I'm going to pass these two arguments or these two variables to say that I want to add these two. And similarly, I'm going to do it for subtraction, multiplication, and division. As you can see, these are the results of my tasks. Now, if I had to do a directory operation on the module calc, it will basically give me a bunch of inbuilt or dunder methods that are already a part of any Python script by default, such as built-ins. So if I execute this just to show you what happens when I use the dir function, it will basically give me all the functions that are part of this Python script. So these double underscores that you see are basically denoting magic methods or dunder methods, and these are like inbuilt methods as a part of the script. And if you see here, add, division, prod, and sub, these are the methods that we have defined earlier on in our script ourselves. Now to go slightly deeper or in more detail into what happens when we do a module search, let's actually look at what happens. So what happens is when, for example, we execute the statement import mycalc as calc, as we did over here. So the steps that actually take place are the interpreter executes the above statement and it searches for this Python script in a list of directories assembled from these following sources that you see here. So it takes the directory from which the input script was run, or the current directory, if the interpreter is being run interactively, which is the case right now. Secondly, it will list all the directories contained in the Python path environment that you set up, that you can set up or you can change later on as well. And this format for Python path is OS dependent, of course, but it should mimic the path environment variable that we see in Windows systems. And then the other source or the other directories is basically an installation dependent list of categories configured at the time Python is installed. Now the resulting search path that is accessible in the Python variable system.path, this is basically obtained from a module named sys. So if I imported this sys and I did sys.path, now these are all the directories that we are going to look for when we want to search for any particular module. So if I'm doing import mycalc or import OS, it's not only going to look at the current directory that I am working on, it's also going to look at all of these directories that have been set up as you could say directories or paths in the system.path. In this video, we will be covering the topic of packages. Now, what if we developed a very large application in Python that contains many different modules, and we have so many different modules that have similar names and functionalities, and they're all kept in or dumped in the same location, that it becomes very difficult to track these modules? What if there was a way to organize and access these in a much simpler and more organized manner? Well, packages allow us to do just that. Packages are a hierarchical structuring of the module namespace using dot notation. And this is the same dot notation that we use when we want to access methods or functions that are part of other classes or modules. So let's look at certain examples to understand what we mean. So I have a directory called pkg. This can be basically treated as what we call a package. Now in our package, we have two modules, mod1.py and mod2.py. And what we're going to store in mod1 and mod2.py are the follows. So I'm going to define a function called foo, and I'm going to print this particular statement, mod1, and then I'm going to basically say foo. And then I'm going to say in class foo, I'm going to have an empty pass command. Similarly, I'm going to define a function called bar in mod2.py where I'm going to print this statement. So basically mod1.py has a simple function where I'm going to print this statement, and mod2.py has a simple function that I'm going to print this statement. And I'm going to store them in mod1 and mod2.py respectively. And these two modules I'm going to store in the directory pkg in my local folder. Now I've already done this, so we can already get to working with this. Now if I wanted to access these particular modules from the pkg folder, I can simply use the import command and use the dot notation. So I can say pkg.mod1. So this will import the mod1 module from pkg folder. Similarly, I can do the same thing for the mod2 module from the pkg folder in the same line. So now that it's been imported, just simply execute this, and this imports whatever we needed. Now, if we wanted to perform a function that was a part of mod1.py, we can just extend the dot notation and use the function as over here. As you can see, it performs this print command, whatever it was supposed to do. Similarly, I can invoke the function that was part of the mod2 module by extending the dot notation to it in the same way. Now, another way that I can I can import a package is by directly importing the package itself by using import pkg and not accessing any of the specific modules within it. Now let's see what happens when we do this. So just for this example, what I'm going to do is I'm going to restart the kernel so that the pkg modules that were already imported get cleaned away. So we see what happens when we execute this on its own. Now if you see, I have imported this. Now let's see if I can access my mod1 and mod2. Now if you see here, it's throwing me an error. And this is because simply using the import command on a particular package only imports, you could say, the package namespace, but it does not actually import any of the modules and files that were part of this package. So if I wanted mod1 from this package, I would have to actually say import pkg.mod1 directly. And I cannot simply say import pkg, and Python will not import everything that is part of a package on its own. I have to specify it myself specifically. Now I'm going to create, and I'm going to show you another type of importing from a package using the star operator. So I have this package pkg once again. Now I'm going to store 4 different modules within this package: mod111.py, mod222.py, and I've already done this, so you don't need to bother about seeing me doing it right now, because I've already created these files. And what I've done is within mod111.py, I've written this statement and I've stored it in the Python script. Similarly, I've created another Python script called mod222.py, and I have basically written this in the code. And I've similarly done this for mod333.py, and I've done another for mod4.py. Now, once I have done this, I've stored these Python scripts into my package or pkg package. So now what I'm going to do is I'm going to execute this command. If you see this, from pkg.mod333 import star. So once I execute this, now I'm going to say print directory, and print directory basically will tell me all the functions that exist in my current directory. If you see here, there's this baz function that was a part of mod333 module. Now if I change this, and if I imported mod111, and if I did the same thing, you will see foo has now been added as a part of this directory. And these are all functions that were part of these different modules where I'm importing from. And that is what the star function does. What the star function will do is it will basically tell Python, okay, so the statement is saying from pkg.mod111. So it's saying that, okay, look into this directory or this package and find this module. And in this module, import everything that exists inside it up until this point. So this is another way of basically importing files or functions from a particular package and a particular specific module within that package. So yeah, this was a very brief video on packages in Python. The conclusion being that packages are basically an organized way of storing many different modules that we might have created in a very large application. And these modules can be accessed using the familiar dot notation that we have used in other examples, such as methods when we were working with classes and objects. In this video, we will be taking an introduction into the concept of generators. So Python provides a generator, which is like a function where we can create our own iterator. In a generator function, we use the yield statement instead of the return statement that we use for standard functions. So let's look at a simple generator first of all. So out here, I have defined a generator called myGenerator, where I'm doing there are three functions or three tasks that I'm doing. First one is when I'm printing the first item and I'm yielding a value 10. then I'm printing second item yielding 20, then I'm printing last item yielding 30. So let's see how do we use this. Now, since we know myGenerator is the function, it uses the yield keyword. Every time we use the next keyword, we will keep getting what is next in this function. So let's store the generator in mygen. So now we have stored the iterator in this function variable called gen or gen. Now let's see, when we do next and we use gen, what happens? So the first task is performed, or the first iteration is performed, where we get this, the first yield command is done. Alright, let's see what happens when we do next again. Next gen. Now, as you can see, we get second item and we get 20. Let's do it for the next, let's do it once more, since there is one more task, there's one more iterable inside. You can see this. Now, a valid question is, what will happen if we do next gen again, since there is nothing after this? Well, let's see what happens. We should get an error. As you can see, stop iteration error. This is another built-in exception that happens when we have reached the last object of an iterable. So we get a stop iteration error. So now a key difference between a generator and a function is that when we execute a function, the moment we hit the return statement in a function, or when we execute a function, like whatever variables that were stored inside are lost and they're destroyed unless they were defined as global. And the function is completely done executing and we leave the function completely. Whereas when it comes to a generator, when we hit the yield function, we don't actually completely leave this function. So the first time the yield is found, we get 10, but the generator remembers its position inside this function. So the next time we use the next, we actually move on to the next iterable, and then we move on to the next iterable. So you can think of a generator as it sort of has memory, if that makes sense. It's a way to create iterables in Python or create iterators in Python. So to understand what the difference between the yield command and the return command does, let's take the same function. Alright. And let's put a return over here after this particular, the second yield. Okay. Let's do the same thing. We say gen is equal to my generator, and let's start doing next gen and seeing what's there. So the first yield will be standard, first item 10. The next one is going to say second item and then 20. But now if you notice, there was a return I put over here. So technically when I did the second next, it's not only yielded 20, but it's also executed this return function or this return statement. So let's see what happens if I do next again. As you see, I have gotten the stop iteration seemingly earlier than I did before. And that's because I have used the return function and return statement. And what that's done is that we've completely left this function, so as to speak, and there is nothing next, so as to speak. So we get the stop iteration, and that's the difference between yield and return. Now in the next example, I'm going to show you how we use a generator function in place of the for loop, or for a for loop. So let's take this, what I have over here, and I have defined a function called getSequence up to x, and what this will do is basically it will keep printing the printing numbers up until whatever we have entered in place of x over here. So if I said, say, sequence is equal to, let's copy this, all right, and say I want sequentially, I want every number up until 10. Well, not including 10, of course, because Python starts with 0, right? So let's do this, and now let's see. So the first number will yield 0, and now if I did this again, it should give me 1, 2, and I can keep going until I will stop at the value 9, as you can see here. So 8, 9. Now I should get the stop iteration error. because that we have reached the end of our iteration. So this is a way of using generator functions for for loops. So another neat example where we're going to use a generator is in the case of Fibonacci numbers. So let's use it. Let's see how we can generate a Fibonacci series using generator. So I've defined a Fibonacci function called Fibonacci where I'm passing max. So max is basically the max value that I want, like up until where I want the sequence, right? So this is basically the code which will return me the subsequent values of my Fibonacci sequence. So let's pass this to fib and say I want all the Fibonacci numbers until 10. So I will pass 10 over here. Let's see what happens when we do next fib. Well, it should start with 0. Then when we do this again, we get 1. Then we do 0 plus 1. It should be 1. Next number should be 1 plus 1, which is 2. Then we should have 2 plus 1, 3. And then 3 plus 2, 5. Then 3 plus 5 should be 8. Now 8 plus 5 is 13. And since 13 is greater than what we passed for our max value here, now when we try this, we should get the stop iteration error, as you can see. In this video, we will be learning about the concept of list comprehension. Now, list comprehension it's a neat way of creating a new list based on values that are already there in an existing list. So you can think of it like creating a new list using a much shorter and cleaner syntax compared to what you might traditionally be thinking. So let's go through some examples, and through those examples we will see how list comprehension makes creating these new lists much simpler and much easier for us. So in our first example, we will be creating a new list which will contain fruits that contain the letter A in their name. So we already have a list of fruits over here, as you can see. It has apple, it has banana, cherry, kiwi, and mango. Now we want to create a new list which has only the fruits that have the letter A inside them. So apple would be one of them, banana would be one of them, and mango would be one of them. So traditionally, if you look at this piece of code, this would do what we want to do, but this contains a few extra lines. But yeah, it does do what we want to do. Now what if there was a way of doing the same thing by just writing one simple line of code? And that exists, as you can see here. So I take the same list. Now this is where you need to follow. So now my new list is equal to, so I'm creating a list over here, as you can see. Now within this list you have this line. This is what we call a list comprehension. So as you can see, it says each fruit for each fruit in fruits if, now it's checking for the letter or the character A inside each fruit. And what this each fruit is, that we're checking each object in this list one by one. So first, in the first iteration, each fruit will contain the string apple. Then in the next iteration, it will contain banana. And in each iteration, we're going to check if it contains the character A. And if it does, then we store that each fruit in the new list, as you can see here. So if I execute this line, you see my result is the same. I have my whatever I wanted. And this was a much cleaner way of writing or creating this new list. Let's look at some other examples now. So my next example, what I'm going to do is I am going to iterate through a string. So I have a string. It can be anything. In this case, I am using a string called human. Alright. So I have a string called human, right? Now I want to store each character of this string into a list that we call h_letters. So if I use the for loop, this is how we would do it. If I execute this, as you can see, the list contains h and then u, m, a, and then n. Now what if I wanted to do the same thing but by using list comprehension? So what I would do is, let's create a list over here, h_letters, and so as we know, list comprehension will you just basically need one line. In this case, it'll just be like this. Now this is my string. Now let's see, when I check what's in h letters, let's see what is the output. So as you can see, I have the output as what I needed. So this is a much cleaner way. Let's go through some more examples now. Now we can do more list comprehensions. We can even use, so we've already seen one case where we checked for the character A. We've seen a case where we went through, where we did a sort of a loop through a string. We can also use list comprehensions in conditionals. So let's look at an example where we use the list comprehension with an if statement. So what if I wanted to store, say, the first 10 even numbers? So this would, this is an example that I'll be using. So in my list, I want to store the first 10 even numbers. So this would be a way to do it. So I have in range 20. So what this is going to do is X is going to take the value of 1, 2, 3, 4 and so on until 90. It'll actually take it from 0, 1, 2, 3, 4 until 19. So when we do range 20, we're creating an iterable where we're going to loop through or iterate through the values 0 to 19. So if I do this, and this, what this statement does is basically it checks if it's divisible by 2. So if this is equal to 0, that means we have an even number. And if this condition is met, that means we store the X into our number list. So let's see what happens when we execute this. This should contain 0, 2, 4, 6 until 18. So this is the first 10 even numbers, as you can see. So this is a neat way of using if statement. We can also use an if else statement. So what if I'm checking each, okay, so I'm going to create another list, and in this list I'm going to basically see if each of my numbers are the even or odd, the first let's say 10 natural numbers. So let's write this statement down. So I want it to be even in case the I that I'm checking, I being every number between, like say the first 10 natural numbers, as I said. Now let's check if it is divisible by 2. Well, if it is divisible by 2, of course it's going to be even, right? Else, we say that it is odd. And then we check for I in, say, the first, let's say the first 20. Okay. So now when we do this and we check what's in the list. So as you can see, the list contains like even, odd. It's basically saying the number 0 is even, then the number 1 is odd, then number 2 is even, and so on and so forth. So this is an example where we used the list comprehension with if-else statements. So another neat thing that we can do with list comprehensions is that we can use it along with functions. So let's look at this function. In this example, we have a function called double x, where we define this double x, this double function to take an input, to take an argument x, and what we return is the square of the argument. So let's use this in our list comprehension. So what we do over here is that we're checking, what we're doing is for every x bit in range 10. So we're taking the value 0, 1, 2, 3 until 9, and we're passing it to this function double x, and we're going to get the square of them, and we're going to store that in a list, as you can see here. Let's call this list x. Let's just call this list, let's call it y. So now let's see what's in y when we check. It should be 0, 1, 4, 9 and so on. So wait, let's check again. Does this square? No, this is actually 2 times. So let's make it square, as you can see. So you can see 0, 1, 4, 9 for the first 10 numbers, 10 natural numbers. Now what I've shown you is obviously list comprehension, but we can also do set and dictionary comprehensions. In fact, set comprehensions work exactly the same way as list comprehensions. The only difference is the set comprehensions will make sure that there are no duplicates inside the set. So you can't have like duplicate items, which you can in the case of list comprehensions. So let's just take a look at an example. So here in this example, what we're doing is we're going to check. So we have this string that we're storing in the variable text, and the string is something like life finds a way. So whatever this is. Now what we're going to do is we're going to iterate through this string character by character, and we're going to check if we're going to check for vowels essentially. So we're going to see if the character A, E, I, O, or U is present in the string, and if it is, we will pass it into our set. Now if you look, you will find there are multiple I's, right? And there are multiple A's as well. So if we did this through a list comprehension, each time that we find a vowel, it would be added to our list. But since this is a set, and sets do not allow duplicates, so you will only have one copy or one particular object for each of the vowels. So of course, now set comprehension is defined using curly braces, so let's keep that in mind. So now if I check what's in this, I will see A, E, I, and U. Even though there are multiple A's or multiple E's or I's and U's, since this is a set, we don't have duplicate copies of any of these. So this was just a small example for showing you set comprehensions. Similarly, we can do the same thing, this comprehension for dictionaries, and we call it dictionary comprehensions. The only thing that we have to worry about when it comes to dictionary comprehensions is that we have to define a key when it comes to this. So let's look at an example. In this, what we're doing is, again, dictionary comprehensions are also defined using curly braces, just like sets, except in this case, we will define a key, and that separates it from a set comprehension. So in this case, what we're doing is that I'm checking, I'm going through a list of numbers from 0 to 9, right? This is what the range 10 function does. And what I'm going to do is, I'm going to create a key, which is going to be like 0, 1, 2, 3. And the value of each key would be its square, as you can see here. I'm doing I times I, or just to make it a little more clearer, as you can see, I'm doing I square over here for every value from 0 to 9. So what I should get is like a dictionary where the first key is 0 and the value of that key should be 0 as well, because 0 square is 0. Then for 1 it will be 1, and then for 2, 4, and then 3, 9, 4, 16. So let's see what happens. As you can see here, this is the result that I wanted. So just to summarize, let's go through some key points to remember when it comes to list comprehensions. So it's obviously an elegant way to define and create lists based on existing lists. It's more compact and faster than normal functions and loops. But we should also keep in mind that we shouldn't write like very complicated list comprehensions, because the idea of a list comprehension is to be user friendly. And also it's important to note that every list comprehension can be written in the form of a loop, but every loop cannot be written in the form of a list comprehension. And that is probably a very key point to remember. In this video, we will be learning about the concept of regular expressions. Now, a regular expression is simply a sequence of characters that defines a search pattern. For example, if you see this example here, you can see a symbol called the caret followed by P and then 5 periods, then an N and a $sign. And what this regex pattern does is it's searching for a 7-letter string that starts with P, ends with N, and has 5 characters in between. Let's look at this example now. This is a regex pattern that is looking for a 5-character string that starts with A, ends with S, and has 3 characters in between. Now, if we had to match this with this string, with these strings as our test strings, the first one would not match because it's a 3-letter string and we're looking for a 5-character string. The second one would match because it's a 5-character string that ends with an S, starts with an A, and has 3 characters in between. This will not match because what our pattern would do is it would find the first S, and it would find that the string itself starts with an A, and it would say, okay, there are only 2 characters between this first S and this A, and it would assume that this is actually just a 4-character string. To actually identify 2 consecutive S's, we would have to do something special, and what we would have to do is what we will see later on. So again, this is the same example. Since this is case insensitive, capital A is perfectly fine when we're searching for this, and it will also match. This is obviously 2 words, and it's not a 5-character string, so this will not be a match. Now, the regex pattern or the regular expression module in Python can be imported using this statement, import RE. Now, once we've done this, we can actually use our regular expression tools and methods to do pattern recognition, character recognitions, and to identify different sequence of characters in our strings. Let's try to understand a bit more in depth about regular expressions now. So what you're seeing here is one variable called pattern, which stores something that looks like a regex, and another variable that stores our test string called abis. Now what we're going to do is we're going to use the match method of this module re, and we're going to check whether this pattern or whatever we are trying to search using this regex is in fact, does it match with our test string. And what we're trying to look for is, if you see here, very similar to what I just showed you, a 5-character string that starts with A and ends with S. So if you see our test string, it indeed is a match, and when we use this this command, we should get a perfect match. So we should basically, it should say that search is successful if I execute this, and this is what it does. Now if I change the test string to this now, you will see that now this is no longer what we are looking for, a 5-character string with A and starting with A and ending with S, and you will see that the search will be unsuccessful, as you can see here. Now let's try to understand what exactly do we mean by when we use these special symbols, like for example this caret or this dollar symbol. These are, by the way, known as meta characters, and now we're going to look into all the or most of the different meta characters that are used in regex. So to put it simply, meta characters are simply characters that are interpreted in a special way by the regex search engine. Now here's a list of meta characters. Let's go through them one by one. Now the square brackets. Square brackets simply specifies the set of characters that we wish to match. So we want to match some combination of A, B and C. It can be 1A, 2A's, 3B's, 4C's. We are not looking at a specific pattern. We just want to know if A, B and C exists in any form in our string. So if we used it on A, the string A simply, we would find one match because the letter A is found here. AC would match twice because we have A and C present here. In this string, Hey Jude, we will have no matches because A, B and C, none of them are found here. And in this weird string, we will have actually 1, 2, 3, 4 and 5 matches. So we would have 5 matches for this this bigger string because we have 5 instances of A, B or C. Now let's use re.match to actually search for this and to see if we have our particular whatever patterns that we're looking for. Now in this input string, this is just some example string. I'm going to test this. I'm going to match whether my pattern that any of A, B and C, is it actually found in this. So let's see what happens when I use re.match for this. So the format, the syntax is simply the regex pattern and then comma whatever test string that we have. So let's see what object gets created when we try to do this. As you can see, it's none. Even though you might be wondering, like I can see an A over here, I can see a C over here. re.match actually gives us the result none. Now, if I try to do it on this test string, which is slightly different, instead of the film Titanic was released in 1998, what I'm saying here is all film Titanic was released in 1998. Now let's see if the R match works or not. As you can see, it actually does return. When I execute this, it returns us an object called re.match object with a span 01. The span 01 is basically telling us that we have found a match between the 0th and the first character, which is basically this character A, which is what it has found. And it's saying that the match is indeed the character A from amongst these options. So what this is basically telling us, and what this means actually, is that the re.match method will only find matches if they occur at the start of the string being searched. Once there is a space in our bigger string, it will not search for whatever comes after it. So what happened in the first instance was, it was actually only searching for matches in this particular word in my larger string. And since it found no match, it basically gave us the result none, which was not the case in the second example because it found a match immediately in the first letter A. Now, if we want to actually check the whole thing, what we would be using is the re.search. As you can see here, the re.search method will actually check the whole string, and it will return us the first instance where it finds a match. Now let's see, this is the test string now, and we're searching again for we're searching for A, B and C, any of these in our test string, but we're going to use re.search and not match. So now if you see, it returns us, when I execute this, it returns us a match object again But this time it's saying the span of 9 and 10. Now the span of 9 and 10 actually exists over here. This is the 9th character and A itself is the 10th character over here. So what this basically is telling us that the 10th character is where we found a match, which was the letter A, which was the first instance of either A or B or C in this whole string. And this is basically how re.search works. It will not only search the beginning of the string, but it will search the whole string and return us the first instance of wherever we find. Now, what if we wanted to find out all the instances wherever A, B, and C were found and not just the first instance? Well, in that case, we would be using the method findAll over here. So when we use findAll, it will actually return us each and every case where it found A, B, or C. And you might not, it won't tell you the exact position, but it will tell you like, so if I execute this, you can see it gives us a list with A, C, A, and A. And what this basically means is it was looking for the characters A or B or C, and it found A first, and hence this for the first item in the list. And then it found a C, and then it found two A's successively. So this is actually how findAll works, where it will actually find all of the instances of our regex pattern. Now that you've seen how the square brackets work and how the re.search and re.match and re.findAll methods work, now we're going to go through all the other meta characters that we saw above. So the period. Now period matches any single character except the new line. New line is basically /n or a break. Now if you look at this picture, what it's going to do is this expression basically saying that do we have two characters, like sets of two characters in our string. So this is a single character string, and obviously a single character string is not a double character string. And this expression, this double dot, is basically asking us, do we have two characters present in our string? So if I had to match it with this A, it will obviously be a no match because A is one character. If we checked it with AC, it is a match because A and C are two characters. A, C, and D will also give us only one match because it will find A, C, and then it will leave D as a single character. But when we check A, C, D, and E, or this string in particular, it will find two matches because it will consider A and C as one of the matches and D and E as one of the matches. So below is basically what we're doing. Basically the same thing, we're just using re.search for each of these different examples. So if you see when I use findAll on A, C, D, E, and when I'm searching for a two character match, you will see that it will return me A, C, and D, E, as you can see here. And similarly for something like this, it will return me again, whatever like two character patterns it finds successively. So the next symbol, the next meta character is the caret symbol that you've seen earlier. Then the caret symbol is basically used to check if a string starts with a certain character. So if you look at this picture, we have two expressions that we're going to check over here. One is one is checking if A is the beginning of a string, and the other one will check if A is the beginning of the string, but is it followed by B or not? So when we check this, what you can see is the first string will be a match because it's only the character A, and it will match here as well because this string starts with A, but it will not match here because this string starts with B. Now if I look at this particular expression, you can see that this is going to search for if the string starts with A and is followed by a B. So it will match in this case because it does start with A and is followed by a B, but it will not match in this case even though it starts with an A because it's not followed by a B. So out here is basically us using the re.search to basically find these patterns. The next symbol that we will come across is the dollar symbol. So the dollar symbol that you can see here is used to check if a string ends with a certain character, and we've already seen how this is used in one of the earlier examples. So this is going to check basically this expression will check if the string ends with A. So this string is basically the character A, so it will match. This also ends with A, so it will match. And this particular string does not end with A, so it will not match. And we are going to do that using the re.search over here. So as you can see, it finds a match in the first character itself here. In this case, it finds a match in the last character, but in CAB, there is no match, so it returns us a none. Another example is of the meta characters is star. So this is the symbol for star, and what the star basically is used is for checking if there are 0 or more occurrences of the pattern to the left of it. So now if you see here, what this will check for is there any form of M and A that occurs before N? And it's very important to note that the N has to follow the A in this case. So let's look at these examples and what will happen. So if I checked it with M and N, this is actually a match because N is followed by 0 occurrences of M and A, which is, it might seem a little weird, but it is technically the truth, because the star symbol doesn't check for the existence, it just checks for if N occurs, it must occur after an A, or the A should not be there itself in this particular string. So as you can see here, the N occurs after an M, and it's fine because there is no A. Now you will see when it will not work. So M, A and N is obviously fine. M triple A N is also fine because N follows an A and there's an M here. This, however, main will not match. Now why? Even though we have M and A and we have an N, you see the N is immediately followed by an I. N follows an I immediately, or the N is preceded by an I immediately. And this is a no match because the strict condition in the search is that N must precede an A if the A exists. Again, in woman it will match because N follows an A over here. We're just going to use the re.search for these examples that we saw over here in terms of code using the re.search, as you can see here. Finally, we have the next meta character, which is the plus symbol. Yes. So the plus symbol matches one or more occurrences of the pattern left to it. Now this is very similar to what we saw earlier in terms of the star, except now in the plus, the key difference is we're looking for one or more occurrences instead of 0 or more occurrences that we were looking for in the case of star. So when we say one or more occurrences, now we need what is there to the left of the plus sign. A 0, no occurrence of it will not be allowed or will not cause a match. So let's see now what we're going to do here. We're going to use the same expression, except we're going to replace the star with the plus sign. So now what we're going to say is, okay, we need M and A, at least one occurrence followed by an N. All of these conditions have to be met. So again, if we took the first example, M and N, this time it will be a no match because there is no occurrence of an A over here for preceding the N. So it's a no match. M, A and N is a match because, well, this is perfectly fine. M triple A and N is also perfectly fine. But if you look at M, A, I and N, much like earlier, the N is preceded by an I and not an A. So there is no match. And again, woman is perfectly fine. And we basically execute the same thing through the search function in this piece of code. The next meta character is the question mark. The question mark symbol matches 0 or 1 occurrences of the pattern to the left of it. So let's see what this does. So now we saw the star which was 0 or more occurrences of the pattern to the left of it. We saw the plus, which is 1 or more occurrences of the pattern to the left of it. Now we will see the question mark, which is 0 or 1, only 0 or only 1, and not 0 or more or 1 or more, which was the previous cases, only 0 and 1 or 1 occurrences of the pattern to the left of it. Again, we're going to see the same expression, except we're going to replace the meta character with the question mark. So now let's see what happens when we match. So if you see here, M and N is a match because there is 0 occurrence of A and 1 occurrence of M preceding N. So this is fine. This is also fine because there is 1 occurrence of A and M, and then it's followed by an N. This will not be fine because now we have 3 occurrences of A, which is followed by an N. We're only looking for 0 or 1. This again, main will be a no match for the same reasons that we have already gone through, and woman will be a match again for the same reasons. And we do the same thing using the search function in this piece of code. The next meta character is the braces character. Now the braces character is interesting because what we're going to do is we're going to see if there are, the typical syntax for a braces is n brace followed by some integer n, comma, integer m, and then close braces. So what this means is we're looking for at least n and at most m repetitions of the pattern left of the braces. Let's see through an example. If you see this expression, we're looking for at least 2 and at most 3 occurrences of the character A in our test strings. So let's see what happens in the first case. We have no matches in this case because this part of the string contains only one A, and even this part of the string only contains one A. We're looking for at least 2 and at most 3. This part will contain one match, the second example, because the second part of the string actually contains 2 A's. For two repetitions of A's consecutively. But this in the third example, you can see both the strings actually contain matches. So we get 2 matches because, as you can see here, there's 2 A's here followed by 3 A's here. Now when we look at this particular string, let's look at what happens now. So what we're going to find is that this thing is perfectly fine. So we have 2 occurrences of A, but now we have 4 occurrences of A. But what the search engine is going to recognize is these first 3 A's, and it's going to see, okay, so there are 3 occurrences of A and I already have a match. It's not going to consider this 4th A in the search. It will just look at the first 3 and it say, okay, there are 3 A's and my match is fine. So again, there are 2 matches in this case. Again, we're going to use the search function initially, and you can see in each of the cases there is a match except for the first case, which is this case. Now let's see the find all option and see what happens when we do the same thing using find all. So when we use find all, it basically gives us each of the instances where the match has occurred in each of these lists. Now let's try to use a slightly more complicated example where we combine different, let's say, different meta characters, and we create a more sophisticated expression that we want to search in our test strings. So if you look at this expression, what we're looking for is 0-9. Now a dash symbol is valid in Python using regex, because what this basically tells it is that it's looking for either 0, 1, 2, 3, 4, so on until 9. Basically any of the digits. We're looking for any of the digits from 0 to 9, and we're going to check if at least 2 and at most 4 occurrences of digits, if they are there or not in our particular code. So let's see what are the matches that happens when we use it on test strings. So if you use it on this string, you can see it will find one match. This basically this particular part of the string where it says 1, 2, 3. So this is 3 occurrences of digits, so it's fine. Now when we look at this whole string, 12 and whatever this is, you will see this will not find a match here. This obviously will not, because these are characters. But if you look at over this part, it will find matches in terms of the first 4 and then 7 and 3, the next 2. 1 and 2, again, there are no matches because there's only single occurrences of digits. We're looking for at least 2 and at most 4. So if I use a find all, you will see like what all it will return. So for the first test string, what it's going to return me is, it's going to return me 1, 2 and 3, as you can see here. But now if you look at this test string, it's going to return me 12. It's going to return me 3, 4, 5 and 6. It's going to return me 3, 4, 1 and 2, but not 7, because we're looking for at least 2. And then it's going to return me 4, 5, 6 and 7, followed by 8 and 8, as you can see in this list over here. Now if we use curly braces with only one digit, it's basically telling the search engine that we want exactly so many repetitions of the preceding whatever expression that we have. So when we do this example, for example, we are basically saying that we want x followed by a dash, and the dash has to occur at least 3 times in our particular expression, and then it should be followed by an x again, which will not match in this case because there are only 2 dashes, and it will match in this case because there are exactly 3 dashes, and it will again not match in this case because there are 4 dashes. As you can see here, none followed by an object match followed by none. Next we move on to the alternation meta character. And as the word suggests, alternation is basically looking for some alternate form of A and B. So A should be followed by B, and basically this pattern has to keep going on. So in the first string over here, this pattern will not match. In the second string over here, we will have a match because we at least find an A, even though there is no B. But this is still considered a match because we did find an A at least. Over here we'll have 3 matches because we have A followed by a B followed by an A again. So if we did a regex expression for this, we would basically find these many matches for each of these examples. The next meta character is the group. Now a parenthesis is basically used to group subpatterns. So let's look at an example to understand what we mean. Now if you look at this complicated expression, what this means is that I want some form of x and z. The x and z have to occur together. But before that, what I want is some form of A following B following C. Some sort of alternation between A, B and C. So this part, as you can see here, is kept in a parenthesis because I want this whole condition to basically occur before I find an x and z. So let's look at what happens here. In the first case, we don't have a match because this parenthesis condition is not being met. X and z is preceded by a space, or basically the A and B is followed by a space. So if the space didn't occur, we would actually find a match, as you can see in the next example. Here you can see A and B occur. Basically this initial condition is met, followed by x and z. So there is one match. So it's fine for us. Now if you look at this slightly more trickier one, what you can see is we have 2 matches in this case. First an A followed by x and z, and then we have C, A and B. Now this is perfectly fine because we are looking for a B followed by an X and Z. We're looking for either of these things. We're looking for some form of alternation of these things followed by an X and Z. And we can get that over here. We get B followed by an X and Z. So you'll get two matches in this case. Now let's go through the concept of grouping constructs. Now that you've seen many meta characters, you've seen how parenthesis works. Let's look at grouping constructs. So grouping constructs break up a regex in Python into sub-expressions or groups. And this serves two purposes. One is the grouping part, which basically says that a group represents a single syntactic entity. And any additional meta characters apply to the entire group as a unit. And then there's the capturing part, which basically tells us that some grouping constructs also capture the portion of the search string that matches the sub-expression in the group. And you can retrieve captured matches later through several different mechanisms. So let's look at basically what we mean by this example over here. So if you see this expression has a plus sign. So we're looking for, as you know, a plus looks for one or more occurrence. So this will basically check for one or more occurrence of the character R only, because there's no parenthesis as in this example. So this plus is next to an R, and it's going to check for basically whether one or more occurrence of R happens preceding B and A. But if we actually put B, A and R in a parenthesis followed by plus, it will actually check for the entire string BAR, and it will check one or more occurrences of BAR together. So if you look at these two examples, when we use this on these examples, you can see that these are fine, like these matches are fine. But if I used this parenthesis, then these would be the acceptable matches. And like BARR would not be a match if I use parenthesis, as you can see here. So this is how grouping constructs work and how parentheses work. So look at some other examples. So what this will do is FOO has to be optionally followed by BAR, and BAR must exist together. And this is because we have a question mark here. This question mark symbol tells us that it should be 0 or 1 occurrences. Similarly, this particular complicated expression is checking for one or more occurrences of whatever we saw earlier. Basically, this whole thing is followed by a plus. So we're looking for this whole sequence for one or more occurrences of it. COW is simply just COW. We're looking for this pattern. And this is going to check for 0 or 1 occurrence of COW because of the existence of the question mark preceded by the parenthesis. In this video, we're going to continue our discussion on regular expressions. Now that you know the basics of regular expressions, let's continue our discussion with special sequences. Now, in an earlier video on strings, you might have encountered what is an escape sequence and how we use the / character to generate these escape sequences. And an escape sequence is basically, if you remember, something that we use to either give a certain special meaning to characters that are otherwise ordinary, or it is used to remove the special meaning that are inherently present in certain characters that we call meta characters. So let's look at what special sequences are in relation to regular expressions. So the first one we're going to look at is the \A, which is used to match if specified characters are present at the start of a string. So out here, if you can see, we are checking if the word the is present in these two strings. So we would get a match in the first case over here because this starts with the word the, but in the second case we won't get a match. And this is how we're going to check it for the same thing using the findAll function. So if you see in the first case, it returns us an object because we do find the in the beginning of the string. In the second case, we get us empty list because this string does not start with the word the. Now the next one that we'll look at is \B, small b. Now this is used to match if specified characters are at the beginning or at the end of a word. So when you use \b and then you follow it up with whatever you're looking for, it would look for those particular characters or that pattern if it exists in the beginning of a word in a string. So if you look at the first example, it starts with FOO. And in the second example, you see this portion of the string or this word is actually also starting with FOO, so it will also match. However, in this string, which is very similar to the second one, we don't have a space between A and F, and it's basically one word. So this does not start with FOO, but it actually starts with AFO, and it won't match, as you can see here. Now similarly, if we wanted to check if something exists in the back of a string, at the end of a string, we type what we want to search for first, and then we follow it with a \b. And then if you see here, it will match in this first case, it will match in the second case because this part of the string ends with FOO, but it will not match in this case because, well, we removed the space, so now this whole thing becomes the string that we're looking for, and it does not end with FOO anymore. And this is basically us just checking it through the find all function. Now the next special sequence that we will be looking at is the /B, which is basically the opposite of what we just saw. This matches only if the specified characters are not at the beginning or the end of a word. So if you see here, this is checking if FOO is not at the beginning of these strings. So in this case, there will be a no match. In this case also, there will be a no match. In this third case, there will be a match. Similarly, if we wanted to see if something does not end with a particular string, we would type that whatever pattern we're looking for, followed by a /B. And then we can use the find all function to generate us lists wherever we find such objects, find such matches in our particular test strings, like we have done over here. So the next one that we're going to look at is the \d. And this matches any decimal digit, which is equivalent to doing a square brackets 0-9. As you must have seen earlier. So if we did a square bracket 0-9 and if we did a search or a find all or a match, it would look for any of the digits between 0 and 9. So a similar thing can be done using a special sequence \d. So as you can see, there will be 3 matches in this case because 1, 2 and 3 digits exist. Whereas in this case, for the word Python, there will be no matches. So these are certain examples where we are doing the same thing using the \d. Now we have another one, which is the \D, and this is just basically the opposite. It matches for any non-decimal digits. It's also equivalent to typing a caret inside square brackets with 0-9, which, if you remember from the previous video, is basically asking us to check for anything that is not the digits 0 to 9. So this is basically, we're going to check in these two strings if there is no digits or no non-decimal digits. So if you see here, we will find 3 matches, A, B, and the double inverted commas. And in the second string, we will find no matches because this is fully just digits. Next, we have \s. Now this is matches where a string contains any white space character. So this is equivalent to doing a check for all of these. So this is like \t is a check for tab space, \n is a check for break line, and then /r, /f, /v are their own checks for different sorts of white space characters that you can see by just looking it up, honestly. But yeah, so if you simply do a \s, it would actually be the equivalent of searching for any of these white space characters that we generate. So if you see here, when we do a \s on this string, you can see that there is one space over here. So it will give us one match because there is one white space, which is just the normal space here. And in the second example, there is no match because there is no white space here. Similarly, /S now, as you might have noticed, is basically checking for a string which does not matches in a string wherever there is no white space characters. So it's basically the same as doing caret /t, /n, /r, /f, /v in a square brackets. So this is basically a simpler way of doing the same thing using square brackets and a caret symbol. So if you see this expression, \S, now we're looking at A space B. So over here, if you see, it will match for all the non-spaces. So it's going to match for A and B. So we're going to get 2 matches here. Whereas an empty string does not contain, well, it does not contain any non-white space character, since an empty string is basically a white space character on its own. So this will give us a no match. So the next special sequence that we're going to look at is the \w. This matches any alphanumeric character, which is the equivalent of doing A to Z in small and then capital A to Z, and 0 to 9 and also an underscore check in square brackets. It's important to note that the underscore is considered an alphanumeric character, hence why we include it over here. But yeah, this is this \w, small w, which basically checks for any alphanumeric character and matches it in a string. So if you see in this first case, it will find 3 matches at 1, 2, and also at the letter C. These others are not alphanumeric characters. Whereas in this string, none of these are alphanumeric characters, so we will get no match. Again, much like the other examples, there's a \W, which will check for any non-alphanumeric character, and it's the equivalent of doing whatever we did before in the square brackets, just with preceded by a caret sign. So if you see here, we have this string where we have a bunch of characters. Well, yeah, only one of them, this this percentage symbol is a non-alphanumeric character. So we will get one match over here. But in this case, in this string Python, we will get no matches because they are all alphanumeric characters. We're just doing the same thing here with a bunch of different examples using the find all function. Now the / capital Z matches if the specified characters are at the end of a string. Now don't confuse this with / small b, because the / small b checks for a string and it checks each and every word in the string individually and checks if any of the words ends with a particular thing or starts with a particular thing, but it checks each word individually. But in this case, the / capital Z will check the string only and not each word. So if you see the difference here, when you use / capital Z, it will match in this first example, but it won't match for the next two. But if you used / small b over here, it would actually match not only in the first example here, but it will also match in the second example, because it would check this word individually and it will find out that, yeah, there is a match here as well. So it would actually match in the second example as well. In this video, we will be covering the topic of closures. Now, before we understand what a closure is, we have to understand what is a nested function and non-local variables. Now, a function which is inside another function is known as a nested function. Nested functions are able to access variables of the enclosing scope. So if I define this function called outer function, where I pass some argument called text and I store that in a variable called text again, and if I create a function within this called inner function, and I want to print whatever this variable is in text, when I execute this, it will be able to access this variable because it's within the enclosing scope. So if I said outer function hey, this gets stored in the variable text, and then the inner function will print that variable, which is basically the string hey, as you can see here. Now, inner function can easily be accessed inside the outer function body, but not outside of its body. So here, inner function is treated as a nested function, which uses text, this variable text, as the non-local variable. Now, a closure is a function object that remembers values in enclosing scopes, even if they are not present in memory. It is a record that stores a function together with an environment. It's a mapping, basically, that associates each free variable of the function, which are basically variables that are used locally, but are defined in an enclosing scope, with the value or reference to which the name was bound when the closure was created. A closure, which unlike a plain function, allows the function to access those captured variables through the closure's copies of their values or references, even when the function is invoked outside the scope. So let's look at an example to emphasize on what was just said. So again, I've defined this function outer function where I'm doing the same thing. Now I've defined the same inner function where I'm going to print the same thing. Now it's very important that when I return over here, what I'm going to return is inner function, but it's not going to be a function call. This is important to create our closure. So we return inner function, but without using the call as we do over here. And what this return will do is basically to create the closure, where the inner function will remember the values of the variables stored in the enclosing scope. So now I'm going to store this outer function in an object called in a variable called my function. Now when I call this my function, you can see there'll be two things that are happening here. So once I've defined this and I've executed this, what happens out here is this function has already executed, and then I'm storing it into this. But because I've done return inner function without parentheses, I've created a closure basically. And this closure allows the inner function to remember the values that were stored in text at any point, and at every point, even after the execution of this one time. So when I execute this again for the second time over here, it will remember the value that was stored in the variable text, which is hey, which was given over here. That's why you see when I execute it for the second time over here, the first time being in this line when I'm storing it in my function, when I execute in the second time, again it will give me the result of hey. As you can see, the closures have to invoke functions outside the scope. The inner function has a scope only inside the outer function, but with the use of closures, we can extend its scope to invoke a function outside the scope. So now let's look at this code. So this code, don't worry about what's going on here. Just know that what we are doing here is we have two functions which we defined called add x and y, which will return x plus y, and the subtract function, which will subtract x and y. So now we're going to execute these. Once we're going to execute the add over here in add logger, and we're going to execute the subtract function, and we're going to store it in sublogger. So technically we have already executed these two functions, but now since I've created an enclosure, basically, if you see here, this is the enclosure that I've created. Now what happens is, when I access this function from outside its initial scope, which is basically over here, this was the initial scope. When I access it outside, you will see that it still has access to these variables x and y. So if you see here, I first of all, I've allowed the enclosing function to accept arguments of any numbers. So I can pass xy, I can pass xyz also. But if you see here, I only have a thing for x and y. So when I want to access any value of x and y, even after the execution of this code initially, I have access to these variables x and y, and that is because I've created a closure out of that. So if you see, if I do add logger 3 and 3 over here, I'm able to get the result 6. If I do add logger 4 and 5, I'm able to get the result 9. Similarly, for subtraction logger 10 and 5, I will get 5 here, and 20 and 10, I'll get 10 here. And I can keep doing this. I can keep saying add logger, and if I say 4 and 7, so if I executed this, and now I'm going to say, let's say for example, add logger, if I said 4 and 7 here. So this still has access to my variables x and y because I've created the closure, and it should give me 11. Similarly, if I did sublogger, say 30 and 15, it should give me 15 because 30 minus 15. So let's say 30 minus 16, right? So it should give me 14 because again, I have created the closure and it has access to these variables already. In this video, we will be learning about the concept of lambda functions. Now, a lambda function in Python is an anonymous function without a name. We usually use lambda functions whenever we want to create a function type object for a short period of time. A lambda function is defined using the lambda keyword. Like a normal function is defined using the def keyword, we define a lambda function using the lambda keyword. Also, the lambda function can take any number of arguments, but it can only accept one expression as a part of it. So think of a lambda function like a sort of a temporary function object that you create whenever you want to perform a particular task or object, but you don't want to give it a name, or you don't want to define a full-blown function and give it a name like that. So over here, I'm going to give you an example of a lambda function. Let's say that this lambda function takes in, let's call it x, and so you define the function, let's call it x, let's call it a lambda function using this keyword. Now we want, say, 2 parameters, right? We're saying, say, a and b, or 2 arguments, a and b. So we're going to pass 2 arguments, a and b, whenever we use this function, and we're going to perform some sort of an expression. Now let's write down a simple arithmetic expression for this. Once you've defined your arguments, just use a colon. Now over here we have our expression. So let's call it a plus b. So now we've created a lambda function called x, where we will pass 2 arguments, and the result will be the expression a plus b. A and b being the arguments we pass. So now let's print the result of let's say we pass 1 and 3. So now we should get the result 4, right? Because a plus b is equal to 4. So we've passed a as 1, b as 3. Now let's execute this. As you can see, the result is 4. Similarly, you can pass any number of arguments. So we want to call some function x, let's say lambda function. Maybe say a, b and c this time. And we want to do the product of these 3 arguments. So now when we check the result, let's say we're doing the product of 2, 4 and 6. So this should be 48. And when you execute this, you get 48 as you can see here. So these are 2 simple examples of a lambda function. Now I could have done this in a different way, where I could have defined some function x, and over here I defined that it takes in 3 parameters, and then you can define some, say, return. The function basically returns you a, product b, product c. But many a times you don't need to define a full function called x. You don't want to assign some function with this name. You just want to create a temporary or a short time anonymous function with some name just to perform a simple expression. And in that case, we can use lambda functions. That's an example, by the way. You can use lambda functions in multiple places. So let's move on now. Now, for the sake of this video, what I'm going to do is I'm going to show you how the sorted function works, and we're going to learn how the lambda function uses this sorted function, how they work together. So this will give you a clearer understanding of how we use the lambda function in our code. So to start off, sorted function returns a sorted list from the items in an interval. So you can have a bunch of, for example, numbers, and the sorted function by default will give you, will return you the list of numbers in an ascending order. Of course, you can also, using a parameter called reverse, you can return a list of numbers in the descending order. You can also do this for strings, characters. So if you give it a bunch of characters, say A, E, F, G in the alphabet, it will give you, if you use a sorted function, it will give you the characters. It will return it in an ascending or descending order depending on the parameter you give. So basically this, the sorted function, the syntax is, you use the keyword sorted, then you pass the iterable, which is basically some list or some tuple. Then you give it a key. So this key sometimes we don't need to give by default. If the iterable does not contain multiple items per object, for like if it's not a tuple of multiple objects, if it's not a list of tuples, for example, you don't need to give it a key. If it's a simple list of numbers, you don't necessarily need to give a key if you want to sort it. But yeah, a key is basically the parameter which we use to tell the sorted function that we want to sort based on something, which is going to be the key in this case. Finally, the third parameter is reverse, which basically just tells us that if we want to sort in the default ascending order, or if we say reverse true, then we will sort in the descending order. Now, let's look at some examples. So I have this list over here, and I'm going to print this list. So this list is obviously a bunch of vowels, E, A, U, O, I, and this is not in the ascending order of the alphabet, right? Like we know it as A, E, I, O, U. If I print the sorted form of this list, it should give me A, E, I, O, U, a list with A, E, I, O in the ascending order. Sorry. Yeah. So now as you can see, it's given me this list as you can see here. Similarly, if I gave it a string as you know is an iterable. It's a collection of characters. So if I use a sorted function on this, interestingly, it will give me a list of these individual characters like P, Y, T, H, O, and N, but in the order that we want it to be in, which is the ascending order, of course. So if I print this, you can see it returns me the list with each character in the order that we wanted it to be in. Now you might notice, why does P come before H? That's because this is in uppercase. So what this does is, first it sorts all the uppercase characters. Since there's only one, so it just places it in the first object of this list, and then it sorts all the lowercase characters that you see here. So yeah, moving on now. Now what if we wanted to say sort this in descending order? So we have this list, and now we want to sort this in a descending order. So in that case, we have to give the parameter reverse, and we have to assign the value true. So once we do this, now when we execute this, you can see we have the return as the same list but in the opposite order. So that's how the reverse parameter works. Now let's try to understand how we use the key function or the key parameter in the sorted function. Now, of course, if we want to sort something based on some key that we want to define, we use the key parameter. So let's take an example now. So in this example, what we have done is I've defined this function called take second. So what this does is it takes the second element of a list of tuples. So what is this list of tuples? Well, this is random. You can see this random. This is a list of tuples. So this is one tuple, this is the next tuple. And what I'm going to do is, in this example, I'm going to create a key out of every second element in each tuple. So I'm going to create a key out of 20, 40, 10, and 13. And based on these, in an ascending order, I will sort this whole list. So what my result should be is that since the smallest of the every second object in these tuples is 10, so this will be my first object in my sorted list. Then it should be the one with 13, because this is the next highest number. So then this will be the next object. Similarly, this will be the next object, then this will be the whole next object. So you see, I'm using every second element of the tuple as my key. And for that, to create a key, basically, I'm creating this function, which will basically return every, it'll iterate through all of these and it will return each of these second elements. So let's actually do this now. So what I have here is, I am going to create a sorted list, which is going to use a sorted function on this iterable, which is a list of tuples. It's called random. Now my key is going to be take second. So this sorted function is actually very dynamic in the sense, I don't exactly have to create a list directly, each of these objects present in the tuples. I just have to define I can even pass a function in the parameter for key, and it will apply this function on the iterable that we pass over here, which is random namely, and it will use this function to generate keys, generate a key out of each second element, and based on that it will perform the sorted function. So now if I check what's my sorted list, you will see that, as I had mentioned, now it's using the second object, so the second each second object of the tuple as the key. So since 10 is the smallest, this whole object is the first object. Then 13, so we have this object here, and then so on and so forth. So this is how we've used a key to do the sorting function, a key that we've defined on our own. Now similarly, we can use multiple keys as well. So just to quickly go over through this, we have this some list where a bunch of names, a bunch of tuples you can see, right? Tuples with 3 objects each within it. Each first one is always a string denoting someone's name, some student's name. The second is the marks out of 100, and the third is their age. So what we have here is, what we want to do is, we want to sort these tuples in the order of first marks, and in case the marks are clashing or they are the same, basically, we will sort by the age. So what we want to do is, we want to first sort by these marks, as you can see here, but in case they clash, for example, like say this 75 and 75, they're the same marks. In that case, we want to sort it by the age, which is 12 and 20, which is different. So in this case, we're going to use 2 keys. One for the first key will be given the highest priority, and then if there is a clash, then we use the second key. So how do we do this? Now let's define some function, like how we defined this take second function here. This will be our function that we will pass to the key. This function, basically what it does is, it gives us who has the highest marks. Now since we are creating since the key works in an ascending order, so the smallest object in a key is the first object that gets returned, right? So what we're going to do is, we're going to return the error, which is basically the difference between 100, which is the total marks, and the marks the student gets. So this is how we obtain a ascending order in our list, which is which basically is what we want, because we want the highest marks to be first. So we do 100 minus item 1. Item 1 is basically the first object of whatever iterable we pass. In this case, it would be the first objects of each tuple, which is the marks. Secondly, we want age. Age is the item 2, which is each second object of each tuple. Now, what we return in this function is like this is going to be our key now. A list of errors and the list of age. Error being the marks error, the difference between 100 and the marks you obtain. So now what it's going to do is, it's going to take the marks as the first key and the age as the second key when we pass this to a sorting function. So if you skip this, you don't have to look at this, but if you look at this now, we have the sorted list, which is going to be the result of the sorted function on top of what we pass, which is the participant list. Now we're going to use the key. We're going to use the key as the sorter function. So we're going to use the sorter function as a key, and when we print, if you see, we get, let me just execute all of this. So if you see here in this section, what you can see is, we have the highest marks first, then the second, then the third. But if you see here, there's a clash. This guy and this guy have the same marks, 75. So now what we want to do is, the guy who has the younger age should be in the first in the object. So that is how this has happened, because we've passed 2 keys, error and the age. So when the clash in error key happened, we went to the age key, and then we did ascending order on that. And then finally the rest of the objects that you can see here. So now that we've seen how the sorted function works, now let's look at how the lambda function works using this sorted function, which was the main goal of this video, right? So let's see. So now some of you might have figured out where this lambda function will be used, right? So whenever we were using the key in the sorted function, we had to define a function. and then we would pass that function as the key. So as some of you may have figured this out, what we're going to do using the lambda function is we're going to skip that process of defining a function with a new name and all that, and we're going to pass a lambda function, or we're going to use a lambda function as the key. So let's see how we do it. So initially what we've done is we've created this list. This list is a list of dictionaries that you can see. So this first object is a dictionary, second object is a dictionary. Each dictionary contains two keys, the name and the age. And the values are something like Nandini, the values for age is like 20, 20 and 19. So we have three dictionaries in a list. So what we're going to do is we want to print, what we want to do with this, we want to print these objects or these dictionaries in an ascending order of age. So obviously we want this to be first, and then this and this, because 19 is smaller than 20. So let's see how we do this. So if you go here, what we're going to do is we're going to print the sorted function, or the result of the sorted function being applied on this list. So this is our iterable. Now if you see here in the key parameter, we don't predefine a function and pass it over here. Instead we use the lambda, and this lambda function is defined in such a way. So we say lambda, it will take one argument I, and then it will return basically the age index for some I, and this I is, we're going to presume an I to be some sort of an iterable which has an index called age, and which is the case in our case, right? We have a bunch of dictionaries where there is a key in each of these dictionaries called age. So we're going to use that. And now you're going to ask, like, what is I? Well, when we use the lambda function in the sorted function, this I will basically be each object that we get when we iterate upon this list. So we're going to iterate first on this. So it's going to take this dictionary and it's going to search for the age. Then it's going to take this, it's going to search for the age. Then it's going to take this and it's going to search for the age. And each of the time it will pull out what is the value for each of these age keywords, or these age indexes or age keys. And out of these objects, so 20, 20 and 19, or these values, we're going to create a key with which we're going to sort each object in this whole list. Okay, so this is how the lambda function will work here. So let's do it. So as you can see, our sorted list now contains this object first, because 19 is the smallest age, and then this and this. Now you might see that there are two 20s. So how do we control which one comes first? Well, by default, it will just give us the result in the way we passed it in the original list. So since Nandini came before Manjeet, in the result also Nandini will come before Manjeet. But what if we wanted to sort it even more? What if we want to sort it in such a way that first we go by age, and the second key will tell us that if there is a clash in ages, we have to go alphabetically by the name. So in this case, we will create a second key. And how we do that? Well, if you go to this step, over here what we're doing is we're doing the same sorted function, but now the lambda will again take one parameter, which is I, which is going to be each object in this iterable list, and we're going to take two keys. So the first key will be the age key, and the second key will be the name. So it will first sort on age and then on name. So now if you see, the result should be that Manjeet will come before Nandini, even though the ages are 20, because M comes before N in the alphabet. As you can see, this is the result. Now if we wanted to do the same thing, but in a descending order, all we have to do is after this key parameter, we have to give another parameter called reverse. And we have to give it true. So if we did this, now you see this, or if we do it on this one, to be more clear. Now if I execute this, basically this whole, whatever result we get will be backwards now. Oh wait, I did not enter it in the sorted function. So this should come within the sorted function over here. So now if we execute this, you will see Nandini comes first, Manjeet comes second, and then Nikhil comes third. Because we've done the reverse, we use the reverse keyword as true, reverse parameter as true. In this video, we will be covering the topics of map, filter, and reduce functions in Python. Now, Python provides several functions that enable functional approach to programming. And since functional programming is all about expressions, some of these expression-oriented functions of Python are lambda functions, list comprehensions, map, filter, and reduce. Now we've already covered the topic of lambda and list comprehensions. Now let's cover the topics of map, filter, and reduce. So to start off, let's look at the map function. The map function takes in two attributes, a function and a sequence. A function is basically some user-defined function or any function. A sequence is basically an iterable object like a list or a tuple, for example, or a bunch of lists and tuples as well. So let's look at an example. So one of the most common operations that we do with something like a list is doing an operation on each of the elements in the list and then outputting a new list with the values as whatever we have modified to the original items of the list. So what if we did the square of all of these items in this list and we want to create a list based on that? So we can basically iterate through it and we can do a square function and then append those values to a new list called squared. And when we do this, for example, over here, you can see when we print squared, we should get the list of whatever square values we have for the original list. But this is slightly a bit tedious. And what if we had a method what if we had a technique wherein we could basically pass a function that we have that we want to do and a sequence on which we want to apply this, and we pass it to a function, and this function basically takes care of applying whatever operations we want to do on each element of a sequence. So this is where the map function comes in use. So let's look at how we use the map function over here. So if you look at this, I've defined a square function. So the square function basically returns, takes an argument x and returns the square of it. And I have a map function which takes the square function as one of the arguments and the list or an iterable as the second argument. So this map function creates a map object, if you see here. So let's just do it one by one. So I'm creating my list and I'm going to create my function called square, and I'm going to send this to the map function. So I'm sending this the first argument as the function that I want to do and the second argument as the list that I want to apply it on. Now let's list out all the items that are in this map object. So if you see, it creates me a list with basically the squared items, and this is exactly what we needed. And another way of doing the same thing would be just going through a for loop in each of the map objects and printing each, which would give me the same results. So if you see here, I found a very neat way of passing a function and an iterable and using the map function to apply each operation that is part of the function, or applying the function on each item in the iterable. So as you've seen, we basically passed in a user-defined function and we applied it to each item in the list. Then the map calls the square function on each list item and collects all the return values into a new list. And because map expects a function to be passed in, it also happens to be one of the places where lambda functions are appearing a lot. So let's look at an example where we do the same operation using a lambda function. So if you see here, I have a lambda function where I'm passing it as the function argument, and what this lambda function takes is some variable x or some argument x, it does its square and it returns that x. And this x is basically going to come from each element that is present in this list called items. And when we list down these, you will see it basically does the same thing for us. It creates a list with squared items. Now we can also pass, instead of passing an iterable itself, we can actually pass a sequence of functions and use the lambda function to perform a sequence of functions on particular items. So let's look at a new example, a slightly different one. So we're going to use a numpy module for this. Don't worry, we're just using it to use the square root function that is present in the numpy module. We will be learning about numpy in a later section. So we're going to import this first. And now I'm going to define three functions called square, cube, and square root. So once I've defined these, basically they're returning the square, the cube root, the cube, and the square root of some integer x. And now I'm going to create a list of these functions that you've just seen. And we're going to use a for loop, and we're going to iterate through a range from 0 to 4. So, and we're going to pass this, and we're going to say that we want to apply some function. We want to apply some function x, and we want to return that using this lambda function. Now what values this x will take is based on whatever functions we've stored in this variable called funcs or funcs. And in funcs, we have a bunch of functions called square, cube, and square root that we have defined earlier. So what we're going to do is we're going to apply each of these functions to R, and R will take the values 0 to 4. And now let's see when we print this, what values we get. So if you see here, we get a list of squares, cubes, and square roots for integers 0, 1, 2, 3, and 4. So this is another way of using the map function and lambda functions together to apply multiple different operations to a bunch of iterables. Now for our next example, what we're going to do is we're going to create a function that basically what it does is it creates the uppercase of some string that we pass to it, right? So that's what we've done here in this function called toUppercase. So let's first define this function. Now we have a print function basically which is going to print each object in a particular which is going to print each element of a particular object, and is going to at the end of it, and the end of printing, we're going to give a small space for printing a new line basically. So let's create this also, this print iterator object. Now what we're going to do is we're going to pass a string with the letters A, B, and C to this function, and we're going to map, we're going to apply the uppercase function to this string. Now if you remember, string is also an iterable where it's a sequence of one character strings. So this whole string is basically a sequence of one character string A, one character string B, and C. So we're going to, we can pass a string as an iterable to the map function because it will apply the operations on each of these characters. So let's see what happens when we do the uppercase function. We apply the uppercase function using the using mapping to this string A, B, and C. So if you see, it's created me a list with capital A, capital B, and capital C as we had expected. Because we have applied the list function to the map object. Now, in the next step, what we're going to do is, we're going to do a very similar thing. We're just going to, instead of simply mapping and creating a list out of it, we're going to store the map object in a variable called map iterator. We're going to print what type of object it is, and then we're going to print out each of the elements using the print iterator function that we defined here. So let's do this. Now, if you see, the class, the type of object is of class map, and the objects elements inside the object are A, B, and C. Moving on, let's look at now an example where we're going to pass multiple arguments. So instead of one iterable, we're going to pass multiple iterables now, and we're going to apply some sort of an operation. So if you see here, what we have done is we've created two sequences. One is a list of some numbers, and another is a tuple of some numbers. So just to show you, let me first copy this here. So if you see here, I have a list and a tuple, and I'm passing both of these, if you see, to this map function. And before that, I have defined a lambda function as the operation that I'm going to apply. And what this does is it takes two arguments, x and y, and it returns the product of both of these. Where does it get x and y from? So the x it gets from this sequence, which is a list, and it takes y from this sequence, which is a tuple. So what it's going to do is going to take x as 1 and then y as 5 in the first step, and it's going to return the product as 5. And then the next step is going to take 2 as x and then y as 6, and it's going to return the product of that, and we're going to get 12, and so on. We're going to get 21 and then 32. These values are going to be stored in the map iterator, which is a map type object. And when we use the print iterator function, it's basically going to print out whatever results we got through this mapping. So let's execute this, and as you can see, this is the result we got: 5, 12, 21, and 32, which is what we wanted. So the next part, the next function that we're going to discuss is the filter function now. Now a filter function is basically, again, it takes two arguments, a function and a sequence, and a function basically tests if each element of a sequence is true or not. Now so this filter function will basically take two arguments. So one is the function, and this function is basically going to test if each element of a sequence is true or not, and it's going to take another argument called sequence. And this argument sequence is the list or the tuple or basically any sequence or iterable that needs to be filtered. And it can be, as I mentioned, it can be sets, lists, tuples, or containers of more iterators. And what this function will return is an iterator that is already filtered. So let's look at an example now. So we have this list R, which we've generated, which is basically numbers from -5 to 4. So if I create this list here, you can see it will create a list of -5 to 4. Now, if I wanted to extract only the values that are lesser than 0, Well, I can use a for loop and use a if condition to check this, right? So if I did this over here, you can see it returns me some list called result, which contains only the values lesser than 0, which is basically checked through this condition. What if there was a neat or a more convenient or a more organized approach to doing the same thing? Instead of creating a loop ourselves, what if we defined a function where we are going to do the test, or we're going to create the condition, and we're going to pass this to a particular function and then apply that particular operation on every object of some sequence? Well, just like mapping, we have a filter function to do this. And in this example, what we're going to use is the lambda function, which takes an argument x and it checks for some condition x lesser than 0. And where it's going to get the x from is some sequence r, which in our case is the numbers from -5 to 4. And the filter will basically create a filter object type, which contains only the objects from R that meet this condition, that is x is lesser than 0. And when we use the list operation on top of it, you will see it results in a list with the values that have met my condition. So for our second example, what we're going to do is we're going to create a list which contains a bunch of letters, and we're going to only extract the vowels from these bunch of letters. So let's look at what we have here. We have some letters D, A, T, J, K, O, P, L, and we only want the vowels from this. So we want to filter only the vowels. So we can use that using the filter function by first of all defining a function that returns true if a check is met that one of the letter matches one of these letters in this list called letters. And if it doesn't, it returns false. So this is our condition that we've created. Once we create this condition, this function that checks this, we can pass this function and the sequence into the filter function, and then we can list out whatever we get. So you can see our filtered list contains only A and O, which is basically the only vowels that are present in our original list. Finally, we have the reduce function. This reduce function is basically a functools. It's in the functools module of Python 3.0. And what the reduce function does is it applies a function of 2 arguments cumulatively to the elements of an iterable, and it starts with an initial argument, and it returns a single result. So let's first import this function. And once we've imported it, let's use it in this example that we have here. So in this example, what we're going to do is we have some list called numbers, right? What if we wanted to get the sum of each element in this list? Well, we can iterate over it and store it in some variable called total in each step, right? This is what we would typically do. And in this step, what you can see is the loop basically iterates over every variable in numbers and accumulates them in total. The final result is the sum of all the values, which is the value of 10 over here. In this example, the variable total is what we call an accumulator, and we can apply the reduce function to do the same task. So how do we do it? Let's first of all create a function called myAdd, where we're going to take 2 variables, 2 arguments, and we're going to return the sum of it. Okay, so let's define this function, and now we have our list called numbers, right, which contains 1, 2, 3, and 4. Now let's do reduce myAdd to numbers. Now when I use this function, what it will do is it will apply the function of myAdd. It will take basically each and every element in a sequence. So it will take 1 and 2, then add them together, and then it will create, basically what it will do is it will take 1 and 2, add them together, then we will have 3. So it will take 3 and then the next element, which is 3 again. So it will create the sum, which is 6, and then it will take 6 and then it will take the value 4 and it will give us the result 10. So this is how the reduce function would work. So this is how it will give us the result of 10. As you can see here, I've passed this function where I've defined that I want 2 arguments to be passed to a function, and then the return should be basically the sum. And then I've passed a whole list of like 4 numbers, and I've used the reduce function to basically do this process for 4 numbers in a step-by-step manner by taking 2 at a time subsequently. And my result, as you can see, is correct, as you can see here. So let's use the lambda function now to do the same task. So what I'm doing now is I'm going to define a lambda function, and that's the function I'm going to pass to this reduce. So when I pass this lambda function, which basically takes 2 arguments, x and y, and it's going to return the sum of that as x plus y. Now where it's going to get x and y from is in a very neat manner. So it will take first the first 2 elements, 1 and 2. It will then do the sum, and we get 3. Then it will take that same 3 and then take the next object, which is 3 again, and then give us 6. Then it will take 6 and then the next element, which is 4, and then give us 10. And then the reduce function will output the single result, which is 10 to us, as you can see here. In this video, we will be covering a sort of a project side type of scenario, which is basically going to be a problem case for you, and it's going to be slightly difficult, slightly tricky. But what we're going to do is we're going to tackle a particular problem, and we're going to what I'm going to do is also show you a solution to that problem. So let's start with this. So this question that we have is, we have this program that we have to write where we compute the frequency of words that exist in some input. Okay, the program should output after sorting the key alphanumerically. Now this input can be it's basically a block of text, right? So in our example, we have for example, if this was our input, right, what we want to see is an output which is basically saying that the word Python has appeared, say, well, in this example, it's appeared 5 times, and then the word read has appeared 1 time, and so on and so forth. Like for each of these words, we want to see how many times have they appeared in this particular block of text. So let's look at a particular example now where we have done this. So let's see here. So first of all, I'm going to create a dictionary. So why am I creating a dictionary is because I'm going to use each unique word as a key and the number of times they have appeared in a block of text as the value to that key. So I'm going to use a sample string, which is basically this long string that you can see here, which is stored in line. So this large chunk of text is what we're going to be analyzing. So how are we going to do this? It's pretty simple. So we have this. Now what we want to do is when we find one way of tackling this problem that we're going to do here is we want to check word by word. First of all, we want to see if it's a unique word, and if this word is, before I encountered it for the first time, then we need to store a new key in our dictionary called frequent table or frequency table. And if it has already, if there is a key already with that particular name, then we just want to increment the count or the value by 1. So let's see how we do this over here. So if you can see in the solution is as simple as this, but if you see what's happening, it's basically what it's doing is we're splitting up this string using the split function. What this will do is it will split up the string at every white space. So it will take this as one part, it'll take this part as another part. It will create an iterable with each word as the each iterable object in that container. So it's going to be a list of words like Python is 1, so on and so forth. And we're going to go one by one. So we're going to say for word in line.split. Now if this word if it exists in frequency table as a key, then what we're going to do is we're just going to increase the count of the value of that key by 1. But if it does not exist, then we're going to actually create a key with the word as that unique word, and we're going to create its value, initialize its value to 1. So when we execute this, now if we want to, once we've done this, we can sort it by the count of the words. So what we're going to do is we're going to create another tuple called sorted tuples, where we're going to use the lambda function out here to sort the dictionary in terms of its values. So what we're going to do is we're going to take the key being the lambda item with index 1. Index 1 is basically the value. So a particular key has a value. So the word Python appears so many times. The word, say, scientist appears so many times. So we're going to check which words have the highest number of occurrences, and we're going to sort it in a descending order. So that is basically what the reverse is equal to true does. So when we're going to sort this, when we're going to use the sorted function, when we say reverse true, it tells the sorting function to sort this dictionary frequency table in terms of value by the descending order. So whichever word appears highest, that will be the first word in our sorted tuple. So that's what we do in this line, and once we execute this, we're also going to print. So if you see the result of this activity that we've done, you can see that the word machine appears 6 times, learning appears 6 times, then Python appears 5 times, and so on and so forth. So we've created a sorted tuple where the first object of the tuple, we've created a list of sorted tuples where the first object of the each tuple is the unique word. The second one is the number of times that it has appeared in this particular example or this particular string. So yeah, this was the first basic project that we have tackled. In this, you might have seen some examples of how we do list operations and how we use the lambda function in sorting the dictionary by the values of the key. In this video, we will continue with what we started in terms of our project number 1. What we're going to do is we're going to tackle another slightly complicated a question or a situation. We're going to try to arrive at a solution. So in this, what we have is some sort of a robot, a moving robot, which moves on a Cartesian plane, a 2-coordinate plane, is going to move in terms of up, down, left, and right. Okay, and each time it moves up or down or left or right, it takes a certain number of steps in that direction. Integral steps, of course. So what we need to do is from its starting position, whatever its starting position is, which we're going to take as 0, 0 in this example, we're going to make it move to a particular location with the commands up, down, left, and right, followed by certain steps. And we're going to what we're going to do is we're going to calculate the distance between these 2 points. And we're going to calculate different types of distances. So you might be introduced to new concepts, new distance concepts in this video as well. So what we're going to be using for distance calculation is the Minkowski distance. And that is, we're going to take, so the Minkowski distance between 2 variables is basically the absolute difference between these 2 variables, so these 2 points, and we take it to the power of something. So if we want to say calculate the Minkowski distance with, in terms of the quadratic Minkowski distance with basically P2, so we are going to do xi minus yi, absolute difference to the power 2, and then we're going to take the second root of it after summing each and every point. So when we take p is equal to 2, we say the Minkowski distance behaves like the Euclidean distance, and this is probably one of the most common distances in case you've done basic Cartesian geometry. When you're asked to find the distance between 2 points on a plane, we can also take the absolute distance where we take p is equal to 1. So in this case, we're just basically summing the absolute distances between each point. No roots, no powers, nothing. Basically, p is equal to 1. And we call that the Manhattan distance. So we're going to take p is equal to 1, 2, and 3 in each case. And we're going to find the distance between 2 points based on these measures. So this is just a visual representation. This is basically the Euclidean distance, is basically the estimate of the value between these 2 points. If since this is a 2-coordinate system, whereas the Manhattan distance would be the absolute distance in terms of if we go up and then we go right between these 2, like say if this was and this was another point. So yeah, let's move on to the problem. In this particular example, we're going to start from the starting position 0 and 0 on a graph. And we are going to give the commands of up 5, down 3, left 3, and right 2. So first of all, what we want to do is we initialize the starting position as 0 and 0. And we also, just for the sake of this example, we initialize the end position as 0 and 0. So what we're going to do, first of all, is let's execute this much. Now we have this list of tuples. We're going to call this actions, and this is the actions that we're performing. So each tuple contains an action and the number of steps in that direction. So it contains 4 actions: up by 5 steps, down by 3 steps, left by 3 steps, right by 2 steps. So now we're going to iterate over each tuple, and we're going to get the direction first of all in this line for each step, and we're going to calculate the number of steps it takes. So for each action, it's going to first it's going to check what is the direction, which is done by this line, and we're going to find out the number of steps in that direction, which is stored in this line. So once you've gotten this, for each action, we have to update the end position, right? So what happens is if you go up by a particular direction, so you are basically changing the y-axis, right? The y-axis. So we're going to change end position and the first index, which is basically this part of the end position coordinate point. So we're going to say if it's moving by up, then we're going to update by adding the y-axis by the number of steps. So and if the direction was down, we're going to do the same thing for the y-axis, but we're going to decrement it. Similarly, if we move left or right, we're moving the x-axis, right? So we take end position and the first index. So we take the x-axis, and if we're moving left, it's a negative, it's a decrement, and if we're moving right, it's an increment. So if there's any other action, any other action, for example, that was given here, we say pass. So basically the only valid actions that we can pass is up, down, left and right. Otherwise we just skip that particular action. So this is what this particular loop will do. It will update our final position. So once we've done this, if I execute this, what will get stored in the end position is basically my end position. So now that I have my starting position and my end position, just to show you what the end position will look like right now, let's just do this. So if you see here, after I've moved up by 5 steps, down by 3 steps, left by 3 steps, and then right by 2 steps, my final end position is -1 and 2. My start position, on the other hand, was, as you remember, it should be 0 and 0. It is 0 and 0. So now we're going to find the distance between 0 and 0 and -1 and 2. So we're going to first of all create a function called Minkowski distance, which does a basic function of just calculate the difference between the the end position x coordinate and the end position y coordinate times or to the power of a root. And we're basically going to do this operation that you saw here. We're going to do this, and we're going to use this root variable to specify to p is equal to 1, 2 or 3, what p value we want to take for this Minkowski distance. So once we've done this, what this function will do is basically store this much, and it will wait for us to give us a root. So when we give root 1, it will create these, it will check the distance between the end and the starting points with the p value of 1. If we gave it 2, it will calculate Euclidean distance with p value 2. Similarly for 3, and we can calculate for any roots. So we're going to calculate for 1, 2 and 3 roots, and we're going to see what values we get in each case. So when root is equal to 1, I print a statement saying Minkowski distance with root 1 is something, and then root 2 it's something, root 3 is something. Let's see what results we get. So if you see here, the Minkowski distance with root 1 is actually 1.0, but the Euclidean distance between these 2 points is 2.23, whereas the cubic Minkowski distance with with root 3 is 1.91. So you see these 3 different distance measures for the same distance between 2 points. So in this video, by doing this activity, you will learn how to how to iterate through loops and perform these distance calculations, which you'll find pretty handy in many activities related to data science and machine learning. In this video, we will be continuing tackling different problems and problem cases in terms of a project called Project 3, where we're going to be using regular expressions to validate whether certain passwords that have been entered, do they match certain criteria or not. So let's look into our particular question. We have a website that requires users to input username and password to register. Now we have to write a program to check the validity of passwords input by the users. Now the criteria that the passwords have to follow are that there's at least one letter between A and Z and one number between 0 and 9. The third criteria is that there's at least one letter between capital A and capital Z. So this first and third point basically is saying that there should be one lowercase letter and there should be one uppercase letter. Now there should be at least one character from $, hash or the @ symbol. It should have a minimum length of 6 and the maximum length of 12. So when whatever passwords that we enter into our example, they must be comma separated. So if we're going to have an input, they're going to ask us for an input where we're going to have to input the different passwords in a comma separated way. So let's look at how do we tackle this. So for my example, I'm going to use these examples in terms of these are my password examples. If we're going to check if these are valid passwords or not. So let's copy this first of all. And now let's import the RE. This import RE is basically the regular expression module. Now in this step is going to ask us to input the passwords, as you can see here. So I will just Control V. So since this is comma separated, what it will do is it will split up each of these by the comma, and it will store them in a list. So it will take this as one password, this as another password, this has another password, and this has another password. Once I press enter, now if I want to check what's in list, what's in items, what I can do is just check over here what's in items. It's a list of whatever passwords I had entered. each object is separately treated now in this list. Now I'm going to create an empty list called value first of all. Once I've done that, I'm going to move on to the next step. So once I've created my list called value, what I'm going to do is now I'm going to search and I'm going to check for each condition using regular expressions for whatever criteria that we have initially. So if you see here, what I'm going to do is first iterate by each item in this to check for each password. Now my first check will be a basic check for the length of the password. If it's lesser than 6 or greater than 12, then our password is illegal, so we can't be using this and we will just continue and we won't check for anything else. But if it is within 6 and 12, the length 6 and 12, then we can continue with our check. So we'll do an else statement for pass, which basically moves on to this next block. Now once we've done this, what we will do is this first statement, what this is going to do is going to do an re.search. And re.search, as you know, is going to look for at least one instance of a letter occurring between A and Z. So this re.search followed by this. Now this is the regular expression that we have passed, and what this tells us is basically the square brackets, we're looking for anything between A and Z in terms of small letters. So if this condition is not met, then again we continue and we leave this particular search because one of our criterias is not met. Alright, but if it is met, then this if not statement will not we won't enter this block and we can move on to the next check. So now we move to elif not. Now again we're using if not statement. So this is basically checking for a negative case. So anytime one of these cases have been met, it basically means that our password has been invalid because these conditions are not being met. So we're trying to eliminate all of these conditions so that we get a valid password. So again we move on to the next statement, which is basically going to do the search for numbers. Once again, if we find a case, a password without any numbers, we continue and we don't check this password no more because we already know it's an illegal password. Now next check will be for capital letters A to Z, and the next check again will be for these particular symbols, the $, the hash and the @ one of these three symbols. We're going to search for a white space character. So if we actually do find a white space character in our password, that's an illegal password and we're not going to continue checking for those cases. So this is basically all our cases: lowercase letters, numbers, capital letters, one of these three symbols, and the existence of a white space. So once we've done all these checks, if none of these have been passed, we move on to this else statement where we just pass. And what we can do is we append the value p to the list called value. So basically what happens is, just to go through it again, if this condition is not met and this condition is not met, this is not met, this is not met, this is not met, and if this is also not met, then we're fine. So basically, as long as we have small letters, as long as we have a number, as long as we have a capital letter, as long as we have one of these three symbols, and as long as we don't have any white space characters, we can append p to this. Otherwise, it will continue and it will break out of this for loop completely. That's what the continue statement at the end of each of these blocks checks. Anytime this condition is met, this if not condition is met, then we break through this whole for loop and we don't append p to the value. But if we actually get to this stage, then what we can do is simply append p to value. Now finally what we are going to do is we're going to print out all the valid passwords. So just by a quick look, you can see here this is a valid password, right? So let's execute this and let's see what we get. If you see here, we only get one valid password, and let's look at why some of these turn out to be valid. So if you look here, all of the conditions are met. It has a capital letter, it has a small letter, it has at least one number, and it has one of the symbols, either $sign or the hash sign or the @ sign. In this case, we have two white spaces, one over here and one over here. So this is an illegal password. Similarly, in this case also we have an illegal password because it begins with a space. In this case, it's the same thing. We begin with a space, and also it does not have any of those symbols that we were looking for, the $, or the hash, or the @. So these three are illegal passwords and they do not get appended to value. However, this does get appended to value, and that's why we get the result for only one password, which is the only legal password.
Welcome to Web Scraping with Python. My name is Richard Kirshner with the Simplilearn team. Certainly there are many reasons to be able to go online and scrape different websites. They range everything from pulling out different links to pulling data off of websites. As a data scientist, you might need to get some information off a website that doesn't have a direct API to pull that information. And in Python, we have a wonderful tool. When you talk Python and you talk web scraping, we're talking Beautiful Soup, which is a package you add into your Python that you're running. And we can come over here to the website, www.crummy.com/software/beautiful-soup. You can actually read a little bit about it. Currently, Beautiful Soup 4 is the current version. If you don't remember the full website for it, you can always do what I do, which is go over and do a search for Beautiful Soup official site. And it almost always comes up right at the top, and you click on there and it'll take you to the crummy.com software site for Beautiful Soup. Now, we're going to use our whatever Python interface you want, IDE. I'm going to use Jupyter Lab, which is built on Jupyter Notebook through Anaconda. So when I open up my Anaconda Navigator, you'll see that I have my different tools available. Again, you might be using a different editor, and that's okay. You might be in PyCharm or something like that where you don't need to do this. And Jupyter Lab is Jupyter Notebook with added tabs and some added features. It's basically in beta testing, so it's got a few little glitches when you're saving things and moving between projects, but for the most part it's a great upgrade to the Jupyter Notebook, and you can use them together. So you don't have to, it's built on Jupyter Notebook, so anything you do in Jupyter Notebook you can open up in Jupyter Lab. And the first thing we need to do is we need to go ahead, in this case I'm going under my environments since it partitions the environments out, and I'm going to open up a terminal window. We have to install some packages in here to work with. Now there's a lot of choices on this. Because of the simplicity, will be using conda install. Now you can use pip install for the same thing, and we're going to install our Beautiful Soup 4. And you have to type out the whole thing, Beautiful Soup 4, and you can use a pip install if you're using a different environment. And I am using Python version 3.6, although according to Beautiful Soup they also work on 3.7 all the way from 2.7 through all of 3x. Now according to the Beautiful Soup website, the Beautiful Soup 4 works on anything, you can install on anything from Python 2.7 all the way through any of the Python 3 versions. This just happens to be Python 3.6 because there's a lot of other packages that don't work on 3.7 yet. And we'll go ahead and run this install on here and let it go through its environmental setup. And of course with conda, it goes in there and finds all the dependencies. Pip doesn't do as much as far as finding dependencies, but you know exactly what's on there with pip. So if you're doing a huge distribution, you probably want to use your pip install so you can track what's going on there. With the conda, I like to just let it take over since this isn't a major distributed package going out. Another quick note between pip and conda is that if you start on a project in one of these environments and you're using pip in there, stick with pip. If you're using conda, stick with conda. They track the packages and you can run into some issues where they're not tracking the same packages and something gets overwritten. So it's important to stay very consistent with your install on your environments. And we'll also need to go ahead and install our NumPy environment and our pandas on here. So go ahead and do that. If you haven't added those packages in, go ahead and install those into your environment that you're working in. And of course pandas is just simply install pandas. And let's just install a couple more packages. In this case, let's get our install our matplot library because we're going to plot at the end since we're going to be collecting data. And for this project, that will be all the packages we'll need. So we can go ahead and close out of our installer or whatever setup you have. And we'll go back to home and we'll just launch our Jupyter Lab, and that will open up in our browser window. Now, if you're coming from Jupyter Notebooks and first time in Lab, we can go ahead and just create our first notebook, Python 3. You can also do it under File, Launcher, and you'll see New Notebook. It automatically opens up and we can just click right on there. It'll pop open on the left, and I'll right-click this and we'll rename this. We'll rename it just Beautiful. And it is a IPyNB file on there. So that should look familiar because that's a Jupyter Notebook file. This is a new one. Now, I have multiple tabs, and in the past I usually hid this on the other computer, all my notes for the lesson today. But this is my notes going down, and we'll go ahead and just start going through this and see what it looks like to do a data pull from front to end and see how that works as a data scientist pulling that information in from the website. And the first thing I want to do is I want to go ahead and close this side window. That way it get the nice full screen. And we can also up the size a little bit. One of the wonderful things about working in a browser window, just do that Control+ thing. The packages we talked about is pandas. So we imported our pandas if you haven't already. That's our data frame. If you haven't done our pandas tutorial, definitely worthy of the time time to go through there and understand pandas because it's such a powerful tool. This basically turns your data into a spreadsheet data frame. Our NumPy is our number array, so it kind of works with pandas very closely as far as manipulating data in arrays. Matplot, we want to go ahead and bring that in, our PLT, so that we can plot the data at the end. And this line right here that says Matplot library inline is for the Jupyter Notebook specifically. It tells it to print that on this page. A lot of the newer versions don't actually require to have that line. They'll still print it on the page. But you should still include that if you're in the Jupyter Lab setup. And then we have our URL library.request. We're going to import URL open for opening up the website. And then we have our BS4, that's your Beautiful Soup 4. We're going to import Beautiful Soup. And then our last one is our RE. That is for manipulating our regular expressions. So when we get to that part of importing our data, we have to do a lot of reformatting so it's something we can use. And the RE is one of those tools. We'll go ahead and run this and just bring all that in. So this is all imported. All these packages are now into our web scraping program we're going to run. Now, if we're going to dive in and pull data, we should have a nice website to pull from. And let's go ahead and we'll use the HubberTiming.com results for the 2018 Martin Luther King race. And if we take this, you can actually just take this, where did we get this from? Well, you can go in here and find the website you're going to scrape from, and you'll see right here it says you just copy that link right in there, that HTTP. And this is the website that we're looking at, and you can see right here all the information that we're looking at. Let's say we wanted to run some statistics on this. It sure would be nice to be able to pull it off of here. And if they don't have a direct API, that means we need to pull it from their website. Some of these will have a download, although if you've ever done it where you have a download click and maybe you're paging through 100 websites. In one case, I was polling all the different United States bills that are passed to track who voted on them for a project. And you can imagine that there's, hundreds and hundreds of those, thousands of these documents that they voted on, who voted on it. It goes through the Senate, it goes back to the Congress. So I opened up a website, pull all the links off of there that match a certain criteria. And we'll look at that in just a minute, how we go through the HTML. And then I had to reformat them, or I could hand download each one at a time, which would just be a nightmare. So it's nice to automate it. In this case, we're going to be pulling up this chart. We want to figure out how to pull this chart off of this website. And so when we go back into our Jupyter Notebook, I've got my URL, just our name for it, and it's just a string. That's all this is. Nothing fancy there. You'll notice that on the slashes, we now have // You can do a single forward, and HTTP is a double forward. This is just how you have to switch it to match setup in there. And then it's going to go ahead and use the HTML equals URL open URL. And that's from our URL library request. So it's opening a link to that website, or at least pointing to it. And if we run this, this just sets it up. So this is all set up. And then once we've done our setup, let's go ahead and create an object called soup. This will be, and if you remember up here, here's our beautiful soup that we imported from the BS4. And this is the package that we're working with. And so we're going to do our beautiful soup on here. And on this, we need to go ahead and send it our HTML so it knows what it's opening. And then the second part is we have to tell it how the format is coming in. And the most common one for your HTML polls is an LXML setup. And so almost all of them you'll end up using the LXML. There's a few other options. And because this is so common in the newer versions, a lot of times they just leave it out just because it's already on the default. We'll go ahead and leave it in here just to remind us that it's there, and we'll go ahead and run that. And on the newer versions, they actually default it to the XML setup and the HTML. We'll just leave it out and call it HTML. So it's just going to pull from this URL. And when we run that on here, we've now created an object soup that has pulled the website into it. So soup contains the information along with information on that website and what's going on. So let's just go over what we did real quick before we start digging into the actual soup, before we start scooping out stuff. We imported our different modules that we're going to use with our package, specifically the Beautiful Soup. We did install the Beautiful Soup. If I remember correctly, you have to call it Beautiful Soup 4 specifically, so it knows what you're bringing in. And this line right here is very key. From BS4, because that's how it installs the module, we're importing our Beautiful Soup. And then we found our URL. In this case, we're going to go pull information from the Martin Luther King Dream Run. And then we set our HTML to our URL open URL. And you can see right here we imported that. So here's our URL.request, import URL open. So we're requesting a connection. And once we send that connection into the Beautiful Soup, it creates an object called soup. And then this one, of course, we chose soup just because it goes with beautiful soup. I guess we could have chosen beautiful. And now we can start extracting information from our website because we've pulled it down onto our computer under soup. And we can start by looking at the title of the website, soup.title. And if we print title.text, you'll see this a lot in Beautiful Soup because title contains all kinds of information, and if we want just the text from that title, you add the .text on the end. And you can see right here we have our 2018 MLK Dream Run 5K race results. If you look at the tab, that's the actual title up here, 2018 MLK Dream Run 5K race. That's what the title is on the website. And then you might be curious, what's in title? What's the whole title that it's storing up there? Well, let's go ahead and print it out. Here's print title and print title.text. And when we run that, you can see it has the HTML tags title on it, and then the / title to end it. And so we're really just pulling off this piece of the HTML code, and then we look at the text inside that particular part of the HTML. And earlier I mentioned links. What if you want to get all the links off this page? Well, that would be fun. We could do soup dot, and we'll do find _ put this in bracket, and then quotation marks, we'll go ahead and put A. A is the key find, and you'll start seeing a div and all the different options you have for finding these entities in a website. And then let's go ahead and just print our links, and you can see here that it now shows all the different links in here that are marked by A, because we did a find all A. And then we can also, because this is a little bit hard to pull off the H reference, so we can also add in our find all, fine tune that. In this case, the H reference equals true. We'll actually filter that out. And then finally we might do a for link in links, and we can simply do something like this for each link. We want to actually find the H reference because we know there's an H reference in it. And if I run this, you can see it just comes through and prints them out one at a time. Some of these are really useful. So you might be looking for something that has HTTPS in it, and you know that's a link running to something else. Or you might be looking for the mail to tag, so you know that's all the mail addresses. But either way, you can easily find all the links in your HTML document that you're paging through. And of course, any packages that have evolved over time, you can also do link.get hrefs, which should do the same thing as our other format. And you can see it certainly does. We get the same printout up here. In this particular case, we really want to get the data off the page. So let's go ahead and do that. Let's see what that looks like. And in data, let's call it all rows. There we go. Equals. And then we have our soup.find _ all. There's our brackets. And then if we're looking for each row in a database, you'll remember your HTML code, we're looking for the tag tr. So we want to find all tr. And we can take this, and let's go ahead and just take all our rows and do a print all rows. And about this time, you're going to guess that we're going to get a huge amount of information just dumped onto our page. And sure enough, we do. If you look at this, it just kind of goes on forever. But this is an array. Each row is considered an array. So because of that, we can do something simply as putting brackets and just print the first. Let's do the first 5 rows. So from beginning to 5. And you can see here's our first 5 rows on here. I sometimes like to just do, let's just do row 0. And we see that row 0 is finishers. Finishers 191. And just out of curiosity, if that's 0, what's row 1? Mail. Okay, so we're starting to see titles going across here. So if we come up here and we do rows, we did what, up to 10? Let's just take a look and see what 10 does again. And just take a look at that information that comes across. Place, bib, name, gender, age, city, state, chip paste, gender, and so on. So it comes all the way down here. We kind of have an ending right here, and then we have 1, and then we actually, it looks like we start to have information. So we have our 1, our 1191, Max Randolph, that must be the name, male 29, and so on. You can start seeing how the information starts getting displayed going down. So the next thing we want to do with this, and I'll go back up here and just edit the space we're in so it starts to make a little bit more sense. Keep it all together. And so we want to do for each row in all rows, we're looking at, what information are we looking at? Well, we have our TH up here, that's the header, our TD down here, which looks like the individual information. And we really are looking for the actual data. So we're looking for our TD tags in the rows. And we can do that because remember when it stores the row, it also stores the tags underneath that. So all rows have all the different tags in it. And you can see right here as you print each one of those out. And so when we look at each row, we can create another variable and we'll call it row list. And we'll set this equal to, in this case, row. because we've already pulled all the rows out of soup. So now we want to find for each row, and in there we want to find our TD. And if we go ahead and just print, I'm going to do it, if you notice I changed the indent, so I'm just going to print row list. What this does is the last value to go into row list, our last row is going to print now. And of course make sure you have an underscore instead of a period when you're typing. So row.find underscore all TD, and if we print the last row, you can see I have all the data coming across here. We have our 191, our 1216, Zuma, Okchoa, I hope I said that right, female, I believe that's age 40, and so on. And then we can take our row list, and there's a lot of things we can do with the row list. But we'll do let's do object, or let's just do cell in row list. And so we're going to look at each cell, because this is, if you look at this, they have commas separated between the different objects. And then we're going to go ahead and print cell.text. Let's just take a look and see what that looks like. And we can see here for each row we get 191, there's our 191, there's our 1216, 1216, our individual who's in the race, and so forth all the way down for those different settings. And let's go ahead and create a new variable up here. We'll call this all, let's just call it data. We'll keep it simple. So here's our data, and then we have our row. We take our row and we break it up into individual cells. So we'll call this data row, and we'll set this empty to an empty row. And we're going to take our cells, tab this, and we know that each cell generates a text. And so what we want to do is I want to take my data row, let's just replace that. And let's take our data row and let's append our cell.text. So I'm going to add each row is going to be a row of the different text on here. And then once I create each row, I want my data, which is going to be everything, to append each row. And here's our data row. And then if we go ahead and come down here, and let's just print data. Now, if we were working with large data, we'd be very careful about just throwing all our data on the page. But you can see here, we throw the data on the page and we get finishers, 199, male, 78, female, 113, 1, and so on. And if you look at this, this is the headers on the file. We have finishers, male, female. It's just like some general statistics on the first one. And then we have actually an empty data set, and then we have our data that continues, which is the actual information we're looking for. So we have 1, 1191, Max Randolph, male, 29, Washington, D.C., runtime, 1 of 78, and so on here. So we could really quickly get rid of that. A number of different ways to do that. One of them is just to do, we're going to set, if we do data 2 on, we should get rid of everything, but we want to keep Randolph, so make sure Randolph is in there. Oh, we lost Randolph. Let's try 1 on. There we go. There's Max Randolph on there. So we can just simply redo our data on here, and we can do data. Probably want to do it in all rows from 1 on, but I'm just going to do my data equals data 1 on down here. There's reasons to split it this way. In data science, sometimes you don't want to touch the original data in case you need it, in case we do need the first row. So we'll put it down here, and maybe we'll just call this titles. Titles equals data of 0. And so we could do something here where we print, we'll print up our titles, and we'll print our data. In this case, instead of 1 on, let's go -2. Let's look at the last 2 rows of data. So here we have our titles, and for some reason just put in finishers of 191. I was expecting a little bit more up there. And we have our last couple people, and they look like the data on these looks just fine on here. Turns out this is just some generic statistics up here. So we'll get rid of titles completely. It doesn't really do us any good. But we know that data comes in here, and we can look at our data and look at the very end of the data too, the -2 to the end. And we can see it pulls the data in pretty good. We don't have anything too funky in here we're looking at. It looks pretty clean. Now you got to be a little careful, because at some point we might have to come back here and clean up the data if we get an error for running data analysis. We might find out there's some unusual characters or something is misset in the data itself. And you also notice that everything is a string. So when we're bringing it in, we might have to do some conversions to test it out and convert them to whatever kind of data format we're working with. So at this time, we want to go ahead and bring in our pandas. And let's go ahead and call this df for data frame. We'll set it equal to, and if you remember correctly, we imported pandas as PD, and that's standard. You'll see that in most code examples where they import pandas as PD, and it is capital D, capital F for data frame. And we're just going to bring in our data. That's what we called it on here. And let's take this and we'll print. Now when you're working with data frames, you're usually talking large amounts of data, and so you almost never want to print the whole data frame out. We're going to go ahead and do that anyway, just so we can see what that looks like. And you can see in here, brings in our data frame coming in here. We just have a mess of information. This is our data. Let's go ahead and print df and see what that looks like in the data frame. And this is nice because it organizes it into a very easy to read table. And we have, they set the label 0, 1, 2, 3, 4, 5, 6, and so on. And then we have each row. We have Mel, 78, none, 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 going across. When we get all the way down here, we'll see Max Randall about number 3. And the first thing this does is this flags me that I brought in a bunch of information up here that we really didn't want. It's from 3 on that we want. And we can clean this up in one of 2 ways. We can try to clean it up under the data, or we can clean it up under the data frame, depending on what it is we're trying to do. And so to fix this, I want to go ahead and just change it up here in the actual data pull-in. We don't need that information. So I'll rerun it, reload our data from 4 on. And then when I run this, we see we have Max Randolph is right at the top of the list like he should be, and we have all the data going down. Now with the data frame, remember I said we don't usually print the whole data frame. We'll go ahead and do df.head. And this prints the first 5 rows, and you can see that we have 13 columns. Here's Max Randall all the way to Theo Kinman. And I usually also print df tell. And the reason I like to do these particular 2 setups, and I'm going to change it just to 2 rows, because you can do that, you can print as many rows as you want, is it's good to look at the first part and the end, because those are usually where you have extra data brought in, something's messed up. And you can also see that we have 190 rows in here. And it comes in with our Zulma, Lisha, and they're both on here on the list. So now we have a nice data frame, columns and rows. We can easily look at it, we can see the setup on here, and we can look at the names and everything. Now at some point you might be looking at these individual columns and find different information that needs to be re-edited. If you can, you try to do it with the whole column under pandas. You can, up in the upper part of the code where you went from cell to cell or row to row, you can look at individual cells, maybe find a marker in that cell that's something specific, like remove all colons or semicolons or something in there, or brackets. So there's a lot of options in there. But you'll find that this one actually comes in pretty clean on here all the way down. And the next thing we really want to do is we want to look at the headers. I don't know about you, but it doesn't make any sense to me when I have column 1, I don't know what 1191 is or 1080, need name Kaiser runner. I'm guessing that's column 2 is names. Third one, it looks like male or female, probably age, but I don't want to guess. I want this to bring in my column so I know exactly what I'm looking at. So how can we make Beautiful Soup do that for us? Well, let's take our column headers. We're going to set that equal to our soup find underscore all, and then we're going to look for our headers, our th files. And since we're in Jupyter Lab, in this case Jupyter Notebook, I can just type out column headers. If it's the last variable I have listed, it will automatically print it. So it's kind of a shorthand. And we can see right here we have place, I'm guessing that's bib, name, gender, age, city, state, chip time, chip pace, and so on. So we have all our headers right there. I shouldn't have to type them all in. And we'll go ahead and do it before. We'll go ahead and do a header list equals our empty array. And then we can do for column in column headers, and we can take our header list and just append. And what do we want? We want the text from the column, so we'll just do column.text. And then if we come down here and we print our header list, let's see what that looks like. If we did it right, we should get a nice list of all the different column headings we want. So we have place, bib, name, and so on. And then pandas, just because pandas is so cool, we can simply do df columns equals our header from our header list. We can simply set df columns set to df headers, and then if I print df.head, we'll take a look at that, and we'll see right here it has nicely placed our values on here. Place, bib, name, gender, age, and so on. So very quickly we've created this nice data frame. We have the data displayed in nice rows and columns and easy to read. And then as a data scientist, the first thing we want to know is the info. What is in these columns and rows and headers? And you see right here they all come up with non-null object. There's a big flag. So if I want to do anything with this, these are all coming through as strings or an object. I usually mean strings in this case, that they're a string variable. And we have, you can quickly read through this, 191 entries, date columns, total 14 columns. There's a total of 14 columns in the data, and it shows you all the different names and what type of column they are. And it's probably good also to look at the shape of the data, df.shape. We'll go ahead and just run that. You can see it's 191 by 14, 14 columns, 191 entries. This is more like the way you look at a NumPy array, 191 by 14 for the shape. And remember, this is a variable, so if I put it on, if it's a last variable or last value in the set of cells, Jupyter automatically prints it out. So if you're in a different IDE, you'd want to go ahead and use the print statement on here. And then one of the things you'd want to also go through, we'll create a second one, df2 equals df.dropNA. Now the axes is automatically equal to 0. So a lot of times you'll see something like axes equals 0, comma, how equals any. Axes equals 0 is default. That means we're looking at going down the rows. You could look at the column going across. Let's remove the how any because that's just going to confuse you. The axes is whether you're going down the columns or if you're looking at it row by row by row by row. Or you could be looking at it by column by column by column. This would drop any column and it would drop off the NA in any column. And how equals, and we want any. I always confuse all and any because they both start with A. All means that all of them have to be non-value, where any means that any of them can be there to drop it. So this would drop any column with a null value in it. But we want 0, and it'll drop any value with a null value. And then because 0 is always the default, we'll just leave it out. And then it's curious as to what the shape is now. Did we lose anything? Was there any null values in our df2 that we dropped from the df? And we'll go ahead and run that. And we see 191 and 14. So we didn't really drop anything. But it's always good to check. There's other ways you can also do, are there, let's see, any NAs? You can detect NAs in here. Null values, infinite values. That's another one you got to watch out for. We're working with data that we're going to do something with here in a minute. So you got to be a little careful also in the conversions. Are you going to convert something where people typed in weird characters to describe the data a certain way? So now we've got to this point where we have all our different columns, we have our different data, and at this point maybe you're asking, or maybe the shareholder of the company is asking, hey, can we look at the, based on the chip time, here's our chip time, can we plot that versus gender? How does gender versus chip time compare? And so we can do that. We can take that. And the first thing we look at is we say, hey, well, chip time came in as a string, and that's going to be an issue. Now, there's a number of ways you can change this. One of them is we could go all the way back up here where we created the data and find a way to tag it and say, hey, whenever this cell text, maybe instead of appending this, I noticed that anytime there's 2 colons in it, that's probably a time signature. And let's convert all the time signatures to date time filled or whatever. A lot of times you don't get that. You don't get that option. And that's always a question in bringing in data. Whether you convert the data coming in at the beginning, or do you wait till you have it, open it up, and then convert it when you go to use it. We're going to go ahead and convert it after we got it into our data frame. So we have our df2 here. We've dropped all of our NAs. We have a shape. In fact, let's do this. Since there's no difference between df and df2, well, we'll just go ahead and use df2. So let's go ahead and take our df2, and we want to take that specific field and convert it into some kind of numerical value we can use. And let's add another column. A lot of times this is something you want to do is where you want to go ahead and keep all the original columns and just add a new column in there. And this new column is going to be based on the, if we remember correctly, we had chip time. That's what we're going to look at. Okay, we want chip time versus gender. If we go into our pandas, we find out we have pandas to delta, and this is actually time delta. And then we just want to take our df2, and we're going to use the chip time column. So this is going to say, hey, let's convert everything in df2 chip time into a time delta format. That's the data type we're going to put it as. And we can go ahead and just run this. And if we go in here and we do info, df2, and we'll keep our, we're going to look at this particular column, but we want to keep it as a data frame. So this is a list of all the columns we want to look at. We'll just do .info on here and run that. And we do an info on that. You can see it's now a time delta 64 nanoseconds. Well, we really don't want nanoseconds. We actually probably want to do it in minutes. So let's take a look at that, and let's take this whole thing, df2, let's just set the df2. We have our df2, this is a column we're working with here, and we can use the as type property in pandas. And so we can set this equal to df2. We'll take our same column in here, and we'll set it as type time delta second. So it's still a delta time here. So if I run this, you'll see that it still comes up as, where is it? Oh, it turns it into a float. So we're now at a float 64, so it's a number of seconds in that delta time. And then finally, we want to go ahead and turn that from seconds to, say, minutes. And you know, there's 60 seconds in minutes, and so now we divide by 60, we still have a float. We have our info that shows us it's a float, and then we can go ahead and just do a print df2, and let's just keep it small. We don't want to look at all our data. We just want to do the head of it. And we run this, and you can see right here where we go to, it'll be the last one. Here's our chip time in minutes. And a lot of times, just to make life easy for viewing, since we're only looking at this particular element, we can do chip time in minutes, and now we just see that, oops, we take off. We'll go ahead and take off our info. Done with that, and we'll run this, and you can see we have our minutes. 16.8 minutes, 17.51 minutes, and so on. It's a float number. Now keep in mind, this is 0.8. That's not 16 minutes and 80 seconds. That can always throw you if you're going through so many numbers you forget. So important to remember that. And we're also going to look at, the other one we're looking at is what? Gender. We want to look at gender to chip time in minutes. And so we can see here under the head we get male, 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 and a number of different setups. And let's switch this to tail real quick and just look at the end of it. And here we have female, female, male, female, female. So we have two different genders, and we have our chip time in minutes. And if you remember, we brought in our PLT. If you haven't used the plot library, the matplot library, you have a drawing place you're putting stuff on. So we have our PLT, we're going to do a bar graph, and we just want to simply use our df2 gender and df2 chip time in minutes. So that's going to plot the two bars. And to make it pretty, we'll go ahead and give it the X labeled gender, the Y labeled chip time minutes. And that simply is, remember, it always plots X and it plots Y. We have our gender, our chip time. Give it a nice title, comparison of average minutes run by male and female. And if we go ahead and run this with the correct titles in here and everything matches, you'll get a nice graph. We can see here the comparison of average minutes run by male and female. Here's our chip time in minutes. The men seem to be slackers in this particular case. And it's actually, there's a number of studies that show that women tend to have, as far as doing cross-country, there's a lot of women who have a longer endurance than men. So it's not too surprising. But we can see here the average chip time around 70, and for women over 100 minutes. And then another really cool thing we can do is we can describe the data. So df2.describe, this again is a pandas function, just like info is. And we're going to include NP number, the numpy number. And if we run that, you'll see here it comes up and it says chip time in minutes, count, it gives you the average or the mean, standard deviation, the minimum, the maximum, all the different descriptive information you're going to want from your data set on there. And just because there's all kinds of fun ways, let's do a box plot to display your information. We can do a box plot where the column equals chip time in minutes. And let's go ahead and run that. Keep mistyping my chip time in minutes. And you can see it puts out a nice box plot showing you the information. We have our different values and floaters. And this is always interesting because this is a nice way of seeing where we have these floaters, one up here and there's two up above, and of course your nice spread on the box plot. And we can also modify this a little bit, and we can add in by equals gender, and then we'll just give it a blank title. I don't know why we're giving it a blank title. We'll just add a Y plot, Y label on there for runtime. And if we run this, you can see here box plot grouped by gender, chip time in minutes, and now we have our female and male, two different areas, and you can see how they vary. You have your two different your outlier up here, and you can also see how there's such an overlap between the two different values. So if I was looking at this, I'd be like, wow, I really could not draw a conclusive thing on this saying that women's runtime was more in general because they overlap too much. That would be one of the conclusions I'd have to come up with on here. And then we get to maybe the partners come in from the company and say, hey, we'd like to know the age versus chip time in minutes. That'd be something worth knowing on the statistics on this. this. And the first thought is we can simply plot it. And we can do this. We can actually plot the scatter plot, chip time versus df2 of age. Those are XY coordinates. But if you remember from df2 when we did the info, let's go way back up here, we're looking at a data object as far as our chip time on this and our age. Now we converted the chip time, but we also need to convert the age. And if we do it right here, we just plot it, and it'll actually let us plot it. It shouldn't. It should give us an error, but it does let us plot it. You'll see the ages come up a mess over here because they're converting it to weird float numbers and all kinds of things. So what we want to do is we want to take our age, and we'll just call this age underscore I. So we're going to take our age and we're going to create another column for df2 age underscore I. And the I is just going to stand for integer. It's our own choice of values. There is a number of ways to do this, but we're going to do pandas to numeric is the best way in pandas. And the reason we're doing this is that numeric creates a float value. So right off the bat, we want all our stuff converted. It converts it to the least common denominator. So if they're all integers already, you'll get integers. As you can see from here, it's doing some kind of conversion that converts it to a float value. The other thing that numeric does is if there's a null value or they put in like a blank line or a dash to represent no information, it'll convert it to a null. So it goes from like a string to a null versus just having some kind of made up number that Python somehow created for the graph we have below. And then we want to add our df2 age because that's what we're converting to numeric, and then we want to coerce it. And there's a couple different options on this, like you can have it where it just doesn't process it in pandas, but coerce means that if it gets a weird value, that is a null value now. And since we're dealing with errors, this is what happens when you get an error converting it. We want to coerce it. There we go, and put the end bracket on there. And then finally we want to go ahead and round this off. So we'll put brackets around all the way around it, and this rounds off everything in this series. So what we've done here is I've taken df2 age, which is a d-type object, which in this case is mostly strings with a couple of blank ones in there, and we're going to convert it to a numeric, which will automatically go to float. And then we're going to take wherever there's an error, wherever it says, hey, this doesn't convert, and usually that's a blank string. Like I said, I've worked with so many databases where someone puts down none, someone types in space, some types in a dash to mean none, and you get this really weird conversion coming up. This covers all of that in pandas, so it's really a nice way of just coercing it and saying, hey, if we don't have a number in there, let's make it a null value, and then we're going to round it off. And then finally, let's go ahead and take our df2. Here's our df2, and let's drop those null values. Drop NA, and we want how equals any. So that means if there's any null values in the data set, now this might get you in trouble because you might have null values in a different column, and so you might lose data that way. At this point, we could also do like certain parts of like drop just certain columns with null values. There's all kinds of other options in here, but we're just going to do how. We're going to just drop any, and we want to do it in line equals true. So that means it's going to reassign it to df2. So df2 now has rounded out, so it's rounded to the integer. We didn't do any places. The age, and it's going to be age I, and then we've dropped all our null values. That way we're not going to get any errors when we try to plot a null value. And it also makes sure that data, by deleting out the rows, because that's what this does, it automatically does axis 0, which is your rows, axis 1 is your columns. By doing this, it automatically removes all the rows with null values. So it just cleans out the rows. And then when we go ahead and plot this, we see we have a nice clean data, and we have age all the way up to 70. So we have our chip time set, and then our age going across, and it makes a nice plot that you can easily show for display and for and you can easily show that to your shareholders or whatever group you're working on. It makes a really nice and quick, easy display.
In this session, we will discuss the top tips and tricks in Python that you can use to solve your problems. First, let's understand what Python really is. So Python is a high-level open source programming language developed in 1989 by Guido van Rossum. It has simple, easy to use syntax. Python can run on different platforms such as Windows, Linux, and Unix. It has a large collection of libraries and can be integrated with other programming languages such as C, C++, and Java. Companies use Python for web development, software development, statistical analysis, machine learning, and deep learning. Python tips and tricks will help you optimize the code and reduce your time and effort while writing codes for solving problems. These tips and tricks are usually short snippets of Python code with simple illustrations to tell you how you can perform a complex task easily. It can also serve as examples that allow you to dive deep into understanding and exploring how each concept works and where it can be used. So in this video, we'll be covering the tips and tricks based on Python lists, tuples, sets, and dictionaries. We'll also see how to effectively use loops, iterators, and collections in Python. So let me take you to my Jupyter notebook where I'll show you the different tips and tricks. So here is my Jupyter notebook. So let's begin with our first trick. If you want to initialize a list or a tuple filled with repetitive strings or numbers written in the form of a string, we can do that using the multiplication operator. So let me show you. So first I'll declare a list. Suppose A is equal to, within square brackets, I'll declare a string, suppose India. And now if I use the multiplication operator and suppose I say 10, then I'll print A. So this will print India 10 times. If I hit Shift Enter, it will run that cell. You can see we have printed India 10 times. Similarly, let's add another element to our list or another item to our list. Say India, and then we have France. I'll use the multiplication operator and apply 10. So let me print my list again. If I hit Shift Enter, you can see India and France have been printed 10 times. Also, you can use an integer as a string and print as many times as you want. Suppose I'm printing 20 5 times. I'll use the print statement. You can see we have printed 20 5 times. But if I pass an integer as my first operand, it will result in the product of the two numbers. So for example, if I use C equal to 20 into 5, and if I print C, it will give me the product of 20 and 5, that is 100. Next, let's see how you can reverse the elements in a list. For that, we'll use the list slicing method. Let me first show you how you can reverse a string. I'll declare my list as list1 is equal to, and inside this list I'll pass in a few country names such as India, then we have USA, let's say we have France, and then Germany, and finally we have Spain. Now if you want to reverse the order of this list, you can use the slicing method inside the print statement. So I'll write print and I'll pass in my list, that is list1, and I'll use double colon followed by -1. So this will read my list from the end. So if I hit Shift Enter, you can see we have reversed our original list. So now Spain comes first, then Germany, France, USA, and India. Likewise, you can also reverse a list of numbers. So let's reverse a list of numbers. Suppose this time I'll use list2 is equal to, I'll pass in few integers, say 100, 200, 300, and 400. Now if I print my list 2 using colon colon -1, it will reverse list 2. You can see we have reversed our original list 2. So now 400 comes first, then 300, 200, and 100. Now let me tell you how you can print the elements in a list in any order that you prefer. Suppose I have a list that has values like 1, 2, 3, and 4. Then I'll print this list. After that, I'll use 4 variables such as a, b, c, d and assign it to our list. After that, let me go ahead and print any order that I want. For example, I use b, a, d, c and hit Shift Enter. You can see we have printed our list in the order that we wanted. So basically what this cell does is we have assigned the value 1 from list to A, 2 to B, 3 to C and 4 to D, and we are printing in an order B, A, D, C. So this is the result you can see. Now suppose you want to print in some other order, like say I want C first, then I want B, A and then D. So this is the output. Up next, we will discuss list comprehensions in Python. So list comprehension is an effective way to define and create new lists based on existing lists. So suppose you want to extract and separate all the letters from the word Simplilearn and add letters as items of a list. Ideally, you would use a for loop to do this task. So let's see how you can perform this task using a for loop. I'll assign an empty list, say letters is equal to, I'll use square brackets to assign my empty list. Then and declare a for loop. Suppose for I in, I'll pass in my string that is Simplilearn, and I'll append the letters using the append function. Now let me go ahead and print the letters. If I hit Shift Enter, you can see this will print all individual letters present in the word Simplilearn. But the same job, you can do it easily with the help of list comprehensions. So let me show you how to do that. First, I'll declare a variable, say letters, is equal to, inside square brackets, I'll write I for I in my string Simplilearn. Then I'll just print the letters. You can see we have extracted all the letters from the word Simplilearn. So this is how we use list comprehension. Now similarly, if you were to find the square of numbers, you would like to create a user-defined function or use a for loop to do it. So let me show you how you can proceed. So we were to define a function. So first I'll import the math module present in Python. And then let's say I'm defining a function called square, and I'll pass in a parameter as a. Then I'll write a is equal to, I'll use the power function. So I'll first give in my module name, that is math, and use the power function, that is POW, and I'll pass in my parameter, that is a, and since we want to find the square, I'll give in 2 and I'll return my parameter, that is a. If I hit Shift Enter, now we have successfully run our user-defined function. Now let me call that function. If I write square of a, it has given me 1 by default. Now suppose I want to find the square of integer 5. You can see it has given us the square of 5, that is 25. Now to find the square of a number, you can also create an empty list and use a for loop to iterate through a sequence of numbers and append the square of numbers to that empty list. So let me show you how you can do with this process. Suppose I declare an empty list called squares. I'll pass in my empty list, and then I'll use a for loop, say for example for I in range. I'll give 10 as my range, and then I'll append my square value. So I'll pass in my empty list, that is squares dot append. So I'll use squares dot append and pass I into I, and then I'll just call my empty list squares. If I hit shift enter, you can see from 0 to 9, that is a range of 10 values, it has printed all the squares of those integers. Now these two methods that we just discussed need at least 3 to 4 lines of code, but by using a list comprehension, you can find the square of numbers in just a single line of code. So let's use a list comprehension to find square of 5 whole numbers between 0 and 20 having an interval of 4. So I'll use squares is equal to, I'll say x double multiplication operator into 2 for x in, say range. I'll pass in my range, that is from 0 to 20 with an interval of 4. Now I'll print squares. If I hit shift enter, you can see it has printed the square of values. So first the number is 0, so 0 square is 0, then the number was 4, so 4 square is 16, 8 square is 64, then 12 square is 144, and then 16 square is 256. Moving ahead, in the next trick, I'll show you how you can keep track of the index positions and the items in a list. So for that, we will use the enumerate function to print the item values along with the index positions. So let's say I have a list that has items, say 310 to 94. I'm taking random integers, 450 and say 243. And now if I use a print statement, suppose I'll write using the enumerate function, then I'll use a for loop, say for example for index comma element in enumerate. I'll pass in my list, that is list underscore items. After that, I'll use a print statement. I'll pass in index, and then I'll give a list, and that will have my index followed by the value. I'll use another comma and pass in the element. Now if I hit shift enter, you can see we have printed the index position as well as the item value. So at index 0 we have 310, at index 1 we have 294, similarly for index 2 and 3. Now moving ahead, let us understand how we can convert two lists into a dictionary. So a dictionary, as you must be aware, comes with a key value pair. You can use the dictionary method and pass the zip function with our lists as parameters. So let me define our two lists, say item number and names. So I'll use item number and give him some random whole numbers, say 102, 410, and let's say 321. And I'll use my second list, that is names, and let's say this list has some string values like phone, next is laptop, and then we have say tablet. Now I'll assign a variable, say item dictionary is equal to, I'll use the dict function and then pass in zip, and I'll pass in my parameters, say item number and names. Finally, I'll print my newly created dictionary, that is item dictionary. Now let me run it. So you can see we have a dictionary created out of the list. So our keys are 102, 410 and 321, and the item values are phone, laptop and tablet. Now you can check that in the following way. So I'll pass in my dictionary and then I'll use the keys function to get the keys from the dictionary. So you see we have all the keys printed. Similarly, if you want to print the values from the dictionary, I'll use the values function. So that will print all the values. You can see we have phone, laptop and tablet. Now we'll look at how you can find the common elements in two lists. So let me declare my first list as list underscore A, that will be equal to Davis. Then let's say we have Karen, then we have John, we have Frank next, and then let's say we have another person, say Steve. And let me declare my list B. So list underscore B is equal to, I'll take Karen, next we have Davis, then suppose we have Jack, up next we have George, and then say we have Steve again. Now to find the common elements, I'll use variable, let's say common, and I'll again use a list comprehension, say A for A in list A, then use for B in list B, then I'll use an if clause. So if A equals to B, then I'll print the common variable. If I run this, you can see we have the common elements printed from both the list A and B. So Davis, Karen and Steve are present in both list A and B. Next, let's see how you can remove the duplicate items in a list. Such problems you would often come across while doing data analytics. So the idea is very simple. You just need to convert the items in a list into a set. So that will remove all the duplicate items in a list. So suppose I have a list of numbers. Let me take random whole numbers 20, 22, 24, so 26. Then we have 28 repeated twice. And then again suppose we have 20, and we have 22, and let's say we have 30. Now let me go ahead and print my list. So I'll say original list equals to, and then I'll pass in my list, that is list numbers. After that, I'll convert my list, that is list numbers, into a set. So I'll first use the list function, and then inside of that I'll pass in my set function and then declare my list, that is list numbers. Finally, I'll print my new list. So I'll type list after removing duplicates, that will be equal to, I'll give a comma and then pass in my variable, that is list numbers. If I run it, you can see our original list has all the elements that has duplicate values, and the final list, the output, you can see we have only the unique elements printed. Moving on, now let's have a look at how you can merge two dictionaries. So there are two methods to do this. Before that, let's see how the code would have looked like had you merged the dictionaries using Python 2 version or Python 3.4 version and below. So let's see, I have two dictionaries, say team A. I'll use curly braces to declare my dictionary. I'll give my key as 1 and I'll take Davis. I'll give my second key and say I have Andrew in my team. And then let's say I have my third key and let's say I have Karen. Similarly, let me declare my team B dictionary. I'll take the next key as 4 and the next person would be, say, John, and then I'll use my fifth key. We have Angela, and let's say I have my final member in the team, the sixth member, who is Suzanne. Now if you do it in Python 2 or Python 3.4 version and below, I have to define a function. So let me say define merge underscore teams, which will be my function name, and I'll pass in two parameters, say dict1 and dict2. Then I have dict3. In dict3 I'll use the copy method, so I'll use dict1 dot copy. Then let me go ahead and use my dict3 dot update. I'll pass in my dict2 and then say I'll return my dict3. Finally I'll print it, so I'll use merge underscore teams, then pass in my two parameters as team A comma team B. If I run it, oops, there is a mistake I have made, so this should be dict2 actually. So let me run it once again. You can see we have merged both our dictionaries. Now you can see it has around 6 to 7 lines of code or even more. Now if you want to do this task using Python 3.5 version and above, you can use the update method. So let's see how we can do. I have, say, A is equal to, I'll pass in my dictionary as A has value of 1, say B has a value of 2, let's say B also has a value of 1, and my second dictionary would have key B again and it has a value of 2, and key C will have a value of 1. Now if I write A dot update B and if I print A, let me run it, you can see we have merged both the dictionaries here. Now there's one more method which you can use. Let me show you. So I'll copy paste my team A and team B again, and then let's say I'll declare another variable called final team that will be equal to, I'll use curly braces and then say I'll give 2 star and then team A, comma 2 stars again, and then team B. Then I'll print my final team. If I run it, you can see we have merged both our team A and B, and this is our final team that has 6 elements. Now before moving to the next trick, if you have enjoyed watching this video so far, then please consider subscribing to our YouTube channel and hit the bell icon to never miss an update. Also, if you want to get the source file I am using in this live session, then please mention your email IDs in the chat section. We'll share the source code with you over email. Now let's move on. Similar to a list comprehension, you can also create a dictionary comprehension. Let me show you the trick. Suppose I want to find the square of numbers, so I'll pass in my variable that is square, and I'll use my dictionary comprehension, say x, comma x star star 2. This will find the square of a number. For x in range, say 5. So I want the square of the first 5 numbers. Then let me just call it. You can see it has printed a dictionary that has the square of numbers from 0 to 4, that is 5 numbers. So 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, and 4 square is 16. Now let's see the trick to check if all the elements in a sequence are true or false based on a condition. You can do this with the help of all function. All function in Python returns true if all the items in an iterable are true, otherwise it returns false. So I'll directly use my all function. So I'll say all. Now let's say I'll use a variable a, %2. If it's equal to 0, then I'll say for a in range between 0 to 10 with an interval of 2. If I run it, it gives me true because I have defined my range from 0 to 10 and an interval of 2. So the numbers will range from 0, 2, 4, 6, 8 and so on. So all these numbers are divisible by 2 and the remainder is 0, so it gives us true. Now if I change the third parameter in my range function, see I'll make it 3 and I run it, it gives me false. Up next, we'll look at a common programming question that you often get to see in any interview or programming test, that is swapping two numbers. Let's see the trick to swap two numbers in a single line of code. So I'll declare two numbers, say x and y. Let's say we have x as 10 and y as 20. I'll use a print statement, say before swap, give a comma, and I'll declare my variables x comma y. Now to swap two variables, I can simply use x comma y equal to y comma x, and then I'll again use a print statement, say after swap, and I'll write x equal to, say x, and y will have the variable y. If I run it, you see before swap x had 10 and 20, and after swap you can see we have x as 20 and y as 10. So we have swapped the values of the two variables successfully. Now moving on, the next trick I am going to show is how you can concatenate a list containing strings. So we'll use the join function for this. let's say I have a list characters and it has a list of strings, say P, comma, Y, comma, T, comma, H, comma, O, and we have the final string that is N. Now if you were to concatenate all the list elements, I'll declare a variable called word and double quotation marks, and then I'll use the dot operator and join function. I'll pass in my list that is character, then I'll print my variable word. Below you can see the resultant output. So we have successfully combined or concatenated each element or item in the list character. So we have Python printed. Now let me show you how you can find the most frequently occurring values in a list. So I'll declare a list called test, and suppose it has some random whole numbers, say 1, 2, 3, 4, 2, 2, then we have 3, 1, 4, 4, 4. I'll use print statement and pass in my max function. Then I'll convert the list into a set, give a comma, and then I'll use key is equal to test.count. So what it basically does is it will first count the number of times each element is occurring and then find the maximum value out of it. If I hit shift enter, you can see it has given me 4, which means the item 4 has occurred the most number of times in my list. You can see we have 4 times. Moving forward, the next step is how you can use the if-else statement using ternary operators. Ternary operators are commonly known as conditional expressions in Python. These operators evaluate something based on a condition being true or false. So I have my two variables a, b, and it has values 10 and 20 respectively. Now if I use a print statement, say both a and b are equal if a equals to b, else a is greater than b if a greater than b, else b is greater than a. So first I am evaluating this condition. If a is equal to b, then we'll print both a and b are equal. Else if a is greater than b, we'll print a is greater than b. If both the conditions are false, we'll print b is greater than a. So let me run this. We have the output b is greater than a because our b value is 20 and a is 10, so b is greater than a. Now let me create a NumPy array and find the cumulative sum in a sequence of numbers. For this, you can use the CumSum function. First I have to import my NumPy library, so I'll write import NumPy as np. Then I'll declare a variable, say res, which is for result. I'll use a list function and then pass in my CumSum function. And let's say I'll give a range of 10. Finally, I'll print the result. If I run this, you can see we have calculated the cumulative sum of the numbers ranging from 0 to 9. So The first element is 0, then the next element is 1, so 0 plus 1 is 1. Then the next element is 2, so 1 plus 2 is 3. Then 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, and so on. Let's now understand how you can use iter tools in Python. Iter tool is a module in Python that implements a number of iterator building blocks. It provides several functions that work on iterators to produce complex iterators. We will see an example to find the list of matches to be played between the teams in a league. Here we consider each team will play against all the other teams in the league. So to use the iter tools, I'll first import it. So I'll write import iter tools, and then let me go ahead and declare a list, say football underscore clubs. Let me take a few club names, say Manchester United. Then we have Real Madrid. I'm taking the top clubs from Europe. The next club we have is, say, Arsenal, followed by Chelsea. Then we have, say, Liverpool. And finally we have Barcelona. Then I'll use my list function and use another function that is present inside the iter tools library, that is combination. So it will give me all the possible combinations. I'll pass in my list name, that is football underscore clubs, and I'll give another parameter, that is r equal to 2. If I run it, you have all the matches that would be played in this league. As I mentioned, each team will play against all the other teams. Now we will see the trick to print the total permutations in a given set of numbers using the iter tool and its functions. Now to do this, I'll use a for loop. So I'll use for p in iter tools dot, I'll use permutations function. So permutations, and then let's see, I'll pass in my list that has values 1, 2, 3 and 4. I'll print it. I'll use print. Then I'll use the join function, convert it into a string for x in p. If I run it, you can see below we have all the permutations listed. Up next, let me tell you how you can print all the false values present in a list. Now to do this, we can use the filter false function present in the iter tools module. So I'll use list and then use my iter tools dot filter false function. I'll pass in bool as my data type. Let's say we have a list containing none, then we have false, we have 1, 0, 10. If I run it, it will print all the false values present in the list. So we have none, false and 0. So if you have liked watching this video so far, then please subscribe to our YouTube channel and hit the bell icon to stay updated with all the trending technologies. Also, if you want to get the source file that I am using in this live session, then please mention your email IDs in the chat section. Our team will share the source code with you over email. Again, if you have any questions related to the tips and tricks we have discussed so far, then please put your queries in the chat section. Our team will answer it in the chat. Up next, let me show you the trick to perform certain mathematical operations inside a list containing pairs of tuples. First, we look at how to add elements in a list of tuples. So for that, I'll import my iter tools. You can skip this step because we have already imported our iter tools module. And then I'll import operator. We have a list of tuples, say a2, 5. Then we have 10, 4. We have another pair says 60, 3. Now I'll use list function, and inside of it I'll use my iter tools module. So I'll write iter tools dot star map function, and I'll use my operator and add, comma, I'll pass in my list, that is A. Now if I run it, we have the addition of the pairs of tuples present in the list. So first pair is 2, 5, so the addition is 7. Then 10 plus 4 is 14, and 60 plus 3 is 63. Similarly, you can also multiply the pairs of tuples in a list. I'll just copy paste this code, and here instead of add, I'll use mul to multiply. If I run it, we have the output below. So 2 into 5 is 10, then the product of 10 and 4 is 40, and 60 and 3 is 180. Now let us explore a bit about the collections module in Python. So the collections module implements specialized container data types containing alternatives to Python's general purpose built-in containers such as list, tuple, dictionaries, and set. I'll show you how to change the order of the keys inserted in a dictionary using the orderedDict function. So first I need to import the orderedDict function from the collections module. So I'll write from collections import orderedDict function. Then I'll say d is equal to orderedDict dot, I'll use the from keys, and let's say I have my key as A, B, C, D, E. Then I'll use another function called move to end, and let's say I want to move my key B to the end. Then I'll use inverted commas and pass in my join function, and inside that I'll say d dot keys. If I run it, you can see we have shifted the key B to the end. Now if you want to move the key B to the beginning, you can do something like this. So let me copy the last 2 lines of code from the above cell. I'll paste it. Now here I can give another parameter, that is last, and I'll say false. If I run this, you can see we have the key B in the beginning now. Now the final trick I'm going to show you is how to perform mathematical operations using a lambda function in Python. So lambda is an anonymous function that does not have a name. It can have any number of arguments but only one expression. The expression is evaluated and the result is returned. So let's see how to add and subtract numbers in one line of code using the lambda function. So first I'll declare a variable, say function is equal to, and I'll assign a dictionary. I'll pass in my sum and then use the lambda function. I'll pass in variables x comma y and I'll add x plus y. Similarly, I'll now subtract. I'll use the lambda function again, pass in my variables x comma y, and I'll write x minus y. Now let me run it. So if you want to find the sum of two numbers, so I have to call this first. So I'll use func, and using square brackets I'll give my sum and then pass in my values, say 10 comma 3. This will add 10 plus 3 and return the result as 13. Similarly, if you want to subtract two numbers, I'll just write subtract here instead of sum, and it will return the result, that is 10 minus 3, which is 7. I think with that we have covered all the important tips and tricks that you should know in Python.
Welcome to Python interview questions. Certainly the questions we're going to ask in here are very general with a few specifics towards data science, since that's the main direction that Python's going in. And you'd want to expand your questions for your interview depending on the domain that you're using the Python in specifically. Let's dive in and get started with some Python interview questions. Number 1, what is the difference between shallow copy and deep copy? And you can see with shallow copy we have object 1, which has child 1, child 2, child 3, and so on, and object 2, which has child 1, child 2, child 3. A deep copy creates a different object and populates it with the child objects of the original object. Therefore, changes in the original object is not reflected in the copy. Copy.deepCopy creates a deep copy. Shallow copy creates a different object and populates it with the references of the child objects within the original object. Therefore, changes in the original object is reflected in the copy. Copy.copy creates a shallow copy. And you can look at this. If we make a change to child 1, it's only a pointer. So if you make it in object 1 and a change to child 1 in object 1, it will also make that change in object 2. Number 2, how is multi-threading achieved in Python? Oh, this is a good one. With multiprocessing and multi-threading, this question is actually asking you, do you know the difference between multiprocessing and multi-threading and how multi-threading works? Multi-threading usually implies that multiple threads are executed concurrently. The Python global interpreter lock doesn't allow more than one thread to hold the Python interpreter at that particular point of time. So, multi-threading in Python is achieved through context switching. It's very different than multiprocessing, which actually opens up multiple processes across multiple threads. So, multi-threading. Discuss the Django architecture. So the Django architecture, and the first thing to know is that the Django is a web service, way to build your web pages basically. And so when you look at the architecture, you can see here we have a nice model drawn out where the user initiates the Django, which initiates the URL, which initiates the view, what they're going to view, and you have your model and your template. So the model of data, whatever data model you're pulling, goes into the template and then goes back up the pipeline to the user. And the important thing to note is there's a template, the front end of the web page. This is what they're going to see. There's a model, the back end where the data is stored. So you can keep the template and the looks and everything looks the same, but you can swap out the underlying information that goes into that template. Then you have your view, which interacts with the model and template and maps it to the URL, and then the Django serves the page to the user. So your Django grabs it and says, okay, thank you for the URL, and here you go, user. What advantage does NumPy array have over nested list? So NumPy is a module you import. Almost always see NumPy, import NumPy as NP. NumPy is written in C such that all its complexities are backed into a simple to use module. Lists, on the other hand, are dynamically typed. Therefore, Python must check the data type of each element every time it uses it. This makes NumPy arrays much faster than lists. I would also add in that NumPy has a lot of additional functionality that you don't have in lists. There's a lot of things you can automate in the NumPy. quick flip over to our Jupyter notebook. Any IDE will work. If you're going to do a set of interview questions, taking a quick look at code is always important. We have our import numpy as np. We'll go ahead and import time. Here's our list sub for I in range of 100. And all we're doing is we're going to time it. So we're going to create a list, then we're going to create a numpy zeros array. And you can see here, look how quick you can create this numpy zeros array. Here we are appending 1 0 at a time for a regular Python list, and here we are with numpy. They're all zeros, and they're all of type integer. I believe it's either float or integer on this. I'd have to actually do a type on it. And then, so if we take in and we create a TL1 time equals time, and then we do for I in range of 100, for j in range of 100, L of I, j equals L of ij plus 5. So we're just doing a simple calculation on our array and subarrays. This is an array of arrays. And we'll do the same thing with TL2. TL2 time.time, TL1 equals, so here we have our final time on that. And then we'll do this with an array op, and this is what I really love, a equals a plus 10, and then you can just print it right out. So you can see right here with a numpy array, we're doing the same thing. If I run this, our time is significantly different. Here we have 0.09 and 0.003. So you can see that the time drops significantly when you're running this on a numpy array versus a list array. Also important to note, these times aren't going to be, they'll change each time I run it depending on what I have running in the background. So there we go. Number 5, what is pickling and unpickling? Amazes me how many times I pickle and unpickle something. Converting a Python object hierarchy to a byte stream is called pickling. Pickling is also referred to as serialization. Unpickling, converting a byte stream to a Python object hierarchy, is also called unpickling. Unpickling is also referred to as deserialization. So if you just created a neural network model, you can now save that model to your hard drive, pickle it, and then you can unpickle it to bring it back into another software program or to use at a later time. How is memory managed in Python? Number 6. Python has a private heap space where it stores all the objects. The Python memory manager manages various aspects of this heap like sharing, caching, segmentation, and allocation. The user has no control over the heap. Only the Python interpreter has the access. You have a nice little diagram here. Here's your program. There's your interpreter. We have our heap, memory management on the garbage collector going off of there. Number 7. Are arguments in Python passed by value or by reference? Arguments are passed in Python by reference. This means that any change made within a function is reflected on the original object. So you can see here def function of L of 0 equals 3, L equals 1, 2, 3, 4, function L, print L, and you're going to get 3, 2, 3, 4 because we passed L in there, so it's a pointer. Here we have def function L equals 3, 2, 3, 4, L equals 1, 2, 3, 4, function of L, print L. Because in this function I have assigned, instead of operating on a piece of L, the list, I've assigned a whole new value to that list, or L. It then at that point will create a new object. So if I make changes to the object, it's going to change it in the outside the definition. If I use a variable and I assign it a completely new value, like L equals 3, 2, 3, 4, that will not show up when you're outside the function. Number 8. How would you generate random numbers in Python? To generate random numbers in Python, you must first import the random module. The random function generates a random float value between 0 and 1. The random range function generates a random number within a given range. And you can see here 1 is the lower end, 10 is the upper end, and step 2. So it would be 1, 3, 5, and so on as far as the options in the random generation. Number 9. What does the double forward slash operator do? In Python, the forward slash operator performs division and returns the quotient in float. For example, 5 over 2 returns 2.5. To do a double forward slash operator, on the other hand, returns the quotient in integer. For example, 5 double slash returns 2. 5 divided by 2 and you drop the 0.5. Number 10. What does the is operator do? The is operator compares the ID of the two objects. And you can see in here where list1 equals brackets around 1, 2, 3, list1 equals list2 equals true. And you have the double equals in Python, of course. And you can do list1 is list2, where list2 equals 1, 2, 3 is false. List2 is not the brackets 1, 2, 3. It equals it, but it's not the brackets. And if we do list3 equals list1, then list1 is list3 equals true. Number 11, what is the purpose of pass statement? The pass statement is used when there's a syntactic but not an operational requirement. For example, the program below prints a string ignoring the spaces. And so here we have variable equals Simplilearn. We've added 2 spaces in it. For I in variable, so it goes through each I. If I equals space, do nothing. Else, print I, and then we'll have the end equals bracket bracket, and they'll print out Simplilearn. Now, of course, you would probably write this if I does not equal blank space, print. But this would be another way you could do that if you need a placeholder for that first logical set or that first area. And you can also do a function like this. You could do function, whatever your def function name, brackets, colon, pass. So it goes into the function and does nothing, but it's a placeholder. Number 12, how will you check all the characters in a string are alphanumeric? Python has an inbuilt method, isAllNumber, which returns true if all characters in the string are alphanumeric. And so you can see here, ABCD, 1, 2, 3, isAllNumber, output equals true. And the second line, ABCD, the @ symbol, 1, 2, 3, the pound symbol, isAllNum, output equals false. So really you just want to know about isAllNum, all numerical, alphanumerical. Number 12, how will you check if all characters in a string are alphanumeric? So here we go. If you know isAllNumber, which returns that the characters in the string are alphanumeric, one can also use regex instead. And so we have Boolean RE match. What's important about this is to note your capital A dash to capital Z, A lowercase to dash to Z, 0 to 9 means that that array includes all of those, the way they have it written out. Plus a $sign, and then we have what we're comparing it to, the string we're comparing to, the ABCD 1, 2, 3. And so we can do an RE.match, and if it matches, if all these things, if all the different entities in that array matches the first one, we get an output true, and if not, an output false. Number 13, how will you merge elements in a sequence? Sequence. There are 3 types of sequences in Python. There's lists, tuples, and strings. Python, of course, makes this easy. If we have a list 1 and list 2, and list 1 is square brackets 1, 2, 3, list 2 is 4, 5, and 6, we can simply do list 1 plus list 2. And our output is 1, 2, 3, 4, 5, 6. If we have tuples, your tuple is the curved brackets designates it, and again, just add them together. Same thing with strings. We have Simplilearn, S1 plus S2 equals Simplilearn. Number 14, how will you remove all leading whitespace in a string? Python provides the inbuilt function lstrip to remove all leading access from a string. And you can see here, space python dot lstrip, leading strip, Python. And you can also do strip, which relieves leading and ending. Of course, there's also the ending set. Number 15, how will you replace all occurrences of a substring with a new string? The replace function can be used with strings for replacing a substring with a given string. Syntax, string.replace old, new, count. Replace returns a new string without modifying the original string. Hey John, how are you, John? ? Replace John with capital JOHN 1. And then you can see right here, hey John, how are you? And since we designated with the 1, just says we're only going to replace one of these. 16. What is the difference between del and remove brackets on lists? Del for delete. Del removes all elements of a list within a given range. Syntax, del list start to end. Remove. Remove brackets removes the first occurrence of a particular character. Syntax, list, remove, element. And we see a nice example over here. If we delete the list 1 to 3, it will delete the first, in this case B, 1, 2. It doesn't do 3, remember that. 1, 2, so it will delete B and C and you end up with a D. Where if we do remove B from the list and we have an A, B, B, D, it's only going to remove the first B. Number 17, how to display the contents of text file in reverse order. Open the file using the open function. Store the contents of the file into a list. Reverse the contents of the list. Run a for loop to iterate through the list. Number 18. Differential between append and extend. Append adds an element to the end of the list. You can see right here we have a list 1, 2, 3, 4, and we append 4, and we end up with an output 1, 2, 3, 4. And extend adds an element from an iterable to the end of the list. And we have here list equals 1, 2, 3, list.extend 4, 5, 6. Output is 1, 2, 3, 4, 5, 6. So if you want to append an array to the end of another array, you want to use the extend. Number 19. What's the output of the below code? Justify your answer. This is a great interview question because these are the kind of things that come up when you're proofing code. Def, add to list, value, and list. So we have value in and a list in, or list equals an empty, in this case, an empty list. List.append value, return list. List 1 equals add to list 1. List 2 equals add to list 1, 2, 3, empty bracket. List 3 equals add to list A. And then we want to print them. List 1 equals, and you can see the formatting. We have our placeholder, list 1, list 2, and list 3. So when it prints list 1, we get 1, comma A. And what you want to notice here is that list 1 and list 3 are equal. Why are they equal? Well, when we passed the information to the add to list, we passed value without passing the list equals brackets, without passing a second value. What this means is that list, as we have it, if you don't have a list, it'll start off with empty list, which we append the 1 to. The second one, list 2, we appended a value to an empty list. So it's only going to be 1, 2, 3. It doesn't matter what the list was before, we've already assigned an empty list. And then list 3, here's the tricky one. We're adding A to the list, but because we didn't designate the list, list is a shared value. In other words, it doesn't reset it. And we end up with list 1 equals list 3, 1, comma A. Default list is created only once during the function and not during its call. Number 20. What is the difference between a list and a tuple? Lists are mutable while tuples are immutable. And you can see an example down here where I have list equals 1, 2, 3. Square brackets denote it's a list. List of 2 equals 4, and I print it out and I now have 1, 2, 4. If I do the same thing with the tuple, I get an error, because you can't change the tuple 1, 2, 3 into 1, 2, 4. You have to completely reassign tuple to a new value. What is docstring in Python? Docstrings are used in providing documentation to various Python modules, classes, functions, and methods. And so you can see here we have def for a function, add AB, and this is a docstring. We have the triple brackets on there. You can add carriage return in that so that you can go multiple lines. And it says this function adds 2 numbers. And then sum AB returns sum. And so we have down here 2 different ways of accessing this function. Output, accessing docstring method 1, this function adds 2 numbers. Accessing docstring method 2, help on function add in model main. This function adds 2 numbers. And so you can see the code down here has 2 very different end values. The second one is basically a help menu. There's our help menu. Number 22, how do you use print without the new line? The solution to this depends on the Python version you are using. In Python version 2, you can do print hi and then you add a comma afterwards. Print how are you? And you have hi, how are you? In version 3, print hi, comma, end equals, and it'll add a space on the end there. You can put different characters in there, but generally you just want to put a space on the end. Print how are you, and now we get hi, how are you? Number 23, how do you use the split function in Python? The split function splits a string into a number of strings based on a specific delimiter. So we have string, split, delimiter, comma, max, the maximum number of splits. The character based on which the string is to split by default is space. So here we have an example. We have a variable red, blue, green, orange, and we want to split it by commas, and we only want to do the first 2. So if we print the list now, you'll find it has red, blue. It only split it the first 2 times, and then it gets to the third one and just groups them all together, green and orange. If you leave the 2 off, it'll split the whole thing. Number 24, is Python object-oriented or functional programming? Python follows object-oriented paradigm, and you should really know in depth what they mean by object-oriented paradigm if you're doing any interview for scripting languages. Python allows the creation of objects and its manipulation through specific methods. It supports most of the features of OOPS, which has inheritance on a polymorphism. So you have an object and you can inherit all the traits of that object and then add new traits in or alter some of those traits. That's what object-oriented means. Python follows functional programming paradigm. Functions may be used as first class object. Python supports lambda functions, which are characteristic of functional paradigm. So you can set a variable to a function as opposed to setting it to an object. Number 25. Write a function prototype that takes variable number of arguments. Here we have def function name list. So we could have, in this case, whatever the list is, def function. The asterisk denotes that we're going to take multiple arguments of a variable, and then we can do for I in var, print I. So if you send function of 1, you'll end up with a 1, function 1, 2, 5, 6. It'll actually print those out one at a time. The first one just prints out a 1 because it only sent one variable. The second one will print 1, another line 25, another line 6. Number 26. What is asterisk args and asterisk quargs? Args used in function prototype to accept varying number of arguments. It's an iterable object, def function args. And you can imagine it's just a basic list. So if I add the numbers a comma b or a comma b comma c, it doesn't really matter. It will have that number of objects in it, whatever I send to it. And there's other uses for it, but that's very basic. Quargs, I can actually tell it what I want to send. So used in a function prototype and to accept varying number of keyworded arguments. Both are iterable objects, so you can go through them one at a time. And the def function quargs, you can now set like color equals red, units equal 2. So you'll see that, especially in machine learning, there's a lot of they'll have inline equals true, that kind of thing. Number 27. In Python, functions are first-class objects. What do you understand from this? This means I could return a function. It could be one from another function. I could create a function and treat it just like an object. I can assign it to a variable. I can pass them as arguments to other functions. Number 28. What is the output of print name __ name? Justify your answer. The double underscore name double underscore is a special variable that holds the name of the current module. Program execution starts from main or a code with 0 indentation. Thus, double underscore name has a value double underscore main double underscore in the above case. If the file is imported from another module, then double underscore name underscore double underscore holds the name of this module. Number 29. What is a numpy array? And we briefly touched numpy array compared to a list early in processing speed. Now let's go ahead and look at some of the more specifics. A numpy array is a grid of values, all of the same type. So if they're either all float, all integer, all string, and is indexed by a tuple of non-negative integers. The number of dimensions is the rank of the array. And the shape of an array is a tuple of integers giving the size of the array along each dimension. Number 30. What is the difference between matrices and arrays? A matrix comes from linear algebra and is a two-dimensional representation of data. It comes with a powerful set of mathematical operations that allow you to manipulate the data in interesting ways. Now, an array is a sequence of objects of similar data type. An array within another array forms a matrix. Like we said here, two-dimensional, so if you have an array of 3 by 4, that would be a matrix. Number 31. How to get indexes of n maximum values in a numpy array. Of course, the first thing to do is to import your numpy as np. You don't necessarily have to use np, but that is the most standard use of numpy. We create our array equals an np.array of 1, 2, 3, 4, 5. And then if we want to get our indexes of n maximum values in a numpy array, we can do, one way to do it is to take our array, sort it, then do -n colon. That means we're going to do, once you've sorted it, you can do -n. N would equal then the number of indices, so it's not the actual letter n, colon. And really this is about understanding this notation, that we can sort it, so it goes from lowest to biggest, and then we can get the top values for n indexes. And then we have our final set of brackets with the -1 on there. Number 32. How would you obtain the resulting set from the train set and the test set from below? And let's go ahead and look at the two different variables. We have train set equals an array of 1, 2, 3. Test set equals a numpy array of arrays. We have 0, 1, 2, 1, 2, 3. What's important here is that, one, it's a numpy, so that leaves A out, and then we're stuck with 3 other options, and I'm going to say that D is out, none of these. And let's look at np.concatenate versus np.vstack. Concatenate would put one set after the other, so you would end up with, probably give you an error, because one set is 1, 2, 3, and then we're going to concatenate array 0, 1, 2 and array 1, 2, 3, the array of arrays, onto the end of that. what we really want to do is stack. And by the way, you can actually switch. There's variables you can put into concatenate, obviously, that can change this. So you could use the concatenate with a lot of fudging around. But really what we're looking for is VStack. V stands for vertical versus the HStack, which is horizontal. And if we do a VStack, we can simply do train set, comma, test set, and stack them together. And so we have C, resulting set equals np.vstack, train stack, test set. Both option A and B would do horizontal stacking, but we would like to have the vertical stacking. Option C does this. Again, you could add the axes in and use the concatenate to stack it the correct way. Number 33. How would you import a decision tree classifier in sklearn? We have sklearn.decisiontree import decision tree classifier. From sklearn ensemble import decision tree classifier. And we look at these and they're all import decision tree classifier. That actually last part happens to be correct, and it's really just a vocabulary knowing where is the decision tree classifier stored, what module is that a part of, and it is of course part of the sklearn.tree. Number C. Number 34. You have uploaded the data set in CSV format on Google Spreadsheet and shared it publicly. How can you access this in Python? What's important here is to know that we can read stuff with pandas. So we don't show it here, but you can. There's actually a number of ways to do this. What's important here is to know a couple things. One, we have our link generated from the Google Docs and spreadsheets, and then we can do a stringio request get link.content. So there's our source. And then finally, we know that pandas can read a CSV. There's obviously many ways to read a CSV, but data equals pd.read_CSV source. Number 35. What is the difference between the two data series given below? Below we have df name and df location, colon, comma, brackets around, asterisks around name, comma, where. And then we have df equals pd data frame, aabbxxuu, comma, 21, 16, 50, 33, columns equal name and age. So let's take a look and see what they're looking at. We have, just glancing at the questions, they want to know, is it the original data frame or is it the copy of the data frame? And you can see here that 1 is view of the original data frame and 2 is a copy of the original data frame. 2 is a view of the original data frame and 1 is a copy of the original data frame. Both are copies, both are views. And if you're working with pandas, you know that unless you specifically in certain things tell it to do it inline, and a lot of functions don't allow you, that you're always taking a slice and it is always a copy. So C, both are copies of the original data frame. Number 36, you get the following error while trying to read a file, temp.csv using pandas. Which of the following could correct it? So here's our error. Trace back most recent call last, file input, line 1 in module, Unicode encode error. ASCII codecs can't encode character. Ooh, I hate it when that one comes up. And we have 4 different entries. We'll go ahead and just pretend that D doesn't exist unless we really can't fit it into one of the other answers. And the first one is PD read CSV has our file compression equals gzip. Well, gzip is just an unzipping and you actually get a zip error on there. The second one is dialect equals string. Again, not an encoding or coding setup. And then we have encoding equals UTF-8. Well, that would be the encoding error, switching it from the character code. There's UTF-8, there is Unicode. That's the most common two that it goes between. So really this is about understanding the difference between a UTF-8 coding and a Unicode and the error that comes up quite regularly with that. Number C, encoding should be UTF-8. Number 37, how to set a line width in a plot given below. So looking at this, we have import matplot library, pyplot as PLT, and you should know your way around this, how to do a plot in there. PLT.plot 1, 2, 3, 4, plot equals show. And so this is a little bit of a vocabulary test. The vocabulary is it width equals 3, line width equals 3, LW equals 3, or something else. And the vocabulary word that we're looking for is LW equals 3, which stands for line width in pyplot library, pyplot. Number 38. How would you reset the index of a data frame to a given list? So this is a vocabulary challenge in understanding what reindexing is. Reindexing as we have the different values here. We have the first one, which is reset the index. Well, we're not really resetting the index. Reindex number B means we are double checking our indexes to the column and to the main index, and so the values match correctly. Where reindex like now brings in a new index outside of our data frame to a given list. So this is coming from external, and thus the vocabulary word like is our key word, that it's external, and we have a data frame to a given list. Number 39. How can you copy objects in Python? The functions used to copy objects in Python, we have copy for shallow copying and copy deep copying for deep copy. Number 40. What is the difference between range and xrange functions in Python? Well, this is a good one. We have matrices and arrays. With a matrix, the range returns a Python list object. Xrange returns an xrange object. And with arrays, an xrange returns an xrange object. Xrange creates values as you need them through yielding. The key here is that xrange returns the values as you need them. So it actually processes it post, like if you have for x or for a variable in xrange, it is processing them as you need them, 0 to 9. It doesn't create an array 0 to 9, it just hands you 0, then 1, 2, 3, 4, 1 at a time. Number 41. How can you check whether a pandas data frame is empty or not? The attribute df.empty is used to check whether a pandas data frame is empty or not. And so you can simply create we have down here import our pandas as PD. We create our pandas data frame equal to an empty array, and is df.empty comes out as true. One of the catches you got to remember with these vocabularies is with empty along with some other pandas setup, whether you need the brackets or not at the end. Number 42. Write the code to sort an array in NumPy by the n-1th column. This can be achieved using argsort function. Let us take an array x, then to sort the n-1th column, the code will be x to colon n-2.args_sort. So let's see what that code looks like. We import NumPy as np. We'll create our array, our NumPy array, which is 1, 2, 3, 0, 5, 2, 2, 3, 4. So we have 3 different entities with 3 different columns in there. And we go x of x, and so we take x of all the rows, first entity, or in this case it's actually the second one because it's 0, 1, 2, .argsort. So that would be the second entity, or -2 would also be the same. You could also do, instead of 1, you could also do -2 there instead of the 1. Argsort, and then we get an output of the array 1, 2, 3, 0, 5, 2, 2, 3, 4. Number 43. How to create a series from a list, NumPy array, and dictionary. So we'll go ahead and import our NumPy, our pandas, and have my list. And you can see here we have my list equals list of A, B, C, D, E, F, G all the way through. So my list now makes a list of that. For array, we have np.arange to 26. My dictionary will create a dictionary with zip my list, my arguments. So I'll just use the NumPy array we just created with my array to go into the dictionary. And the solution is simple with the pd.series my list, pd.series my array, pd.series my dictionary. So it's all about knowing the dot, capital S-E-R-I-E-S. Don't forget that capitalization. Number 44. How to get the items not common to both Series A and Series B. And you can see here we have, instead of Series A and B, we have Series 1 and 2, and we have 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. The solution is we take a panda series. We have a series U equals a panda series, NP union 1 dimension, series 1, series 2. So we can now make a union of them. We now have series 1 panda series with an intersection, and then we can remove one from the other. Series U is series U dot is in series 1. So if the union is not in the intersection, then you know it's a unique value. A little bit of logic going on there and playing with 3 different terms to get the answer we want. 45. How to keep only the top 2 most frequent values as it is and replace everything else as other in a series. So again, we're working with pandas, because if you're talking series and data frames, that means we're working with pandas. So we're going to import pandas as PD. We'll go ahead and create our panda series. We're going to do that by creating a NumPy random state 100, so 100 in the NumPy one. And then we have our panda series. You can see here we're random integer, NumPy random.random integer 1, 5 by 12. And so the solution for this is we go ahead and we've created a PD dot, remember the capital S series solution. We're going to print the top two frequencies, and that is our series dot value counts. And then we take series values count dot index of up to 2. So we're going to take everything up to 2. And then we'll do the series is in. So if it's not in the first 2, then it's going to equal other. And this would be something you'd want to write down on paper. If it looks confusing, take a moment, pause the video, write this down, and see if you can figure out how the logic came together and try to throw yourself a couple other little logic puzzles like this. Number 46, how to find the positions of numbers that are multiples of 3 from a series. And in here, we're actually going to use a numpy to solve it. The first part, series, lets you know it's going to be a panda series. And if we come down here, we have np.argwhere, so this is a vocabulary question. Series with, remember the percentile 3 is a remainder, so if the remainder equals 0, then we're going to generate that string where the object divided by 3 equals 0 has no remainder, so then we know it's a multiple of 3. Number 47, how to compute the Euclidean distance between two series. And this one's really cool because we have our panda series, P and Q. And what I like about this one is they give us two solutions you can go with. And really you should kind of know both. The first one would be, yes, you know what the Euclidean distance is. And that is we can take the first series minus the second series squared. And then sum them up, and then we do the square root, which is the same as taking the power to 0.5. Doing the power to 0.5 is easier than doing the square root. So a lot of times you'll see that as a switch, but you could have also done the square root and used the math in there. So there's solution 1, you should know your Euclidean distance. And then solution 2 is the numpy solution. So we have np.linalg.norm. That's how we're going to compute our Euclidean distance. P minus Q. Very elegant and very straightforward and easy to compute. Number 48, how to reverse the rows of data frame. So here we have our data frame. We're going to create a numpy array by 25, reshape it 5 minus 1. And this creates a 25 by 25 data frame. And so our solution is to do the df location. And this is just understanding how steps work. The steps, you have your colon, colon, minus 1. So we're taking all the rows, all the columns, minus 1. So we're stepping minus 1 going the reverse direction. And then we're just going to use across all the different columns on there. Let me say that again. The first colon is going to be your row, starting row, stopping row, step minus 1. That's all this is about, is that step minus 1, comma, and then all the columns. 49. If you split your data into train test splits, is it possible to overfit your model? And the answer is yes, is definitely possible. One common beginner mistake is retuning a model or training new models with different parameters after seeing its performance on the test set. My favorite example of this is you have your script put together and you keep hitting the rerun button until you get the answer you want, not taking the answer it first gave you, or running it over an array and recording all the answers to see how they vary. Number 50, which Python library is built on top of Matplot library and pandas to ease data plotting? The answer to this is Seaborn. Seaborn is a data visualization library in Python that provides a high-level interface for drawing statistical information, informative graphs.
And with that, we have come to an end of day 6 of software development. I hope the session was interesting and informative. On our last and final day of software development, we will learn the paramount of software and web development, the JavaScript. Many believe it's simple-looking, complex programming language that is rigorously used in day-to-day programming. Simplilearn is all about explaining the most complicated concepts in the most simple and effective manner. Until next time, thanks for watching. Don't forget to subscribe to stay tuned for more from Simplilearn.